Hi, my name is Bob Tabor, and in this course, you'll learn about JavaScript, the language. This course is aimed at those who are absolute beginners, so beginners to JavaScript, and frankly, given that we're going to discuss some very basic things like if statements and for loops, it's really designed for those who are beginners to programming in general. So if you know some HTML and some CSS and you want to learn JavaScript, awesome, you're in the right place. Also, there's nothing specific to Windows in this course. The tools that I use will be free and available in Mac and Linux as well. So you should be able to follow along no matter which operating system you're comfortable with using. Now, my background is really not all that important, but in case you're curious, I am a software developer by day, and by night I run a website called Developer University, or DevU. You can visit me at www.devu.com. Occasionally Microsoft invites me to create courses, and what you see here is a collaboration between myself and the good folks at Microsoft Virtual Academy. I've been creating courses like this since 2004, and I created a very successful version of a JavaScript course way back in 2011. It's been viewed millions of times, and I've gotten a lot of very positive feedback about it. This is a rewrite, a complete rewrite of that course, because frankly, JavaScript has changed dramatically in the, 6 or 7 years since I originally recorded that course. And so if you're already a software developer coming from a different programming language, this is kind of to pick back up what I said earlier, this might move a little bit slow for you. It just wasn't designed with you in mind. There might be some other courses that can move you through the introductory material a little bit more quickly than what I plan on, than the pace that I plan to take with this course. And my focus is the JavaScript language, the pure language, not web development necessarily, although we will discuss JavaScript in the context of the web browser at the very end of this course. But I felt like teaching JavaScript and how it's implemented in the web browser clouded the discussion of JavaScript, the language itself. So we're going to be writing what amounts to console, or rather command line style applications to isolate JavaScript, the language, as purely and simply as possible without clouding it with a bunch of HTML and CSS and things like that. We're going to discuss the language. We'll discuss popular patterns that have emerged from the JavaScript development community to help overcome some of the challenges associated with working with such a highly dynamic language. Such a unique language and sometimes kind of a quirky language. The last time that I recorded the course about JavaScript, way back in 2011, the course actually had a fairly long shelf life, and so much has changed with JavaScript since then that it necessitated that I actually play catch up and kind of learn some of the new features that were added because I wasn't keeping my skill set up. That's how quickly things change out from under you if you're not careful. If you know anything about JavaScript, you know that the community around JavaScript is moving extremely quickly. It's the most popular programming language, not just in the web browser, where there are hundreds of JavaScript frameworks and libraries that you can leverage in your own applications. But it's also becoming one of the most popular languages for server-side web development, meaning the code that actually runs on a web server that can perform business logic, that can interact with data storage, databases and other styles of data storage. And we're not going to talk about any of those topics in depth per se, but it is important to know that it all starts with a basic understanding of the things that we will discuss in this course, the absolute basics of JavaScript. So since this course may have a long shelf life, it's important to know that some of the features of the latest version of JavaScript, which I will be covering in this course, may not yet be implemented in all web browsers, depending on when you view this course. And then you have to take into account that some of the people viewing your website, for example, might be using very old web browsers. And so you have to keep that in account as well. So I'm going to make two general suggestions, and I'm going to try to remind you about these at the very end. There are still people on the internet that are viewing web pages with browsers that were created 10 years ago. So clearly in these cases, the newer features of JavaScript, many of which we'll discuss in this course, will not be available in those browsers, and your JavaScript won't even work in those web browsers. So you have a choice at that point. You can go one of two routes. You can either attempt to write your code in such a way that it is as friendly as possible to those older web browsers. Or you can use a tool which will transpile your JavaScript code that you write using the latest features of JavaScript. It'll transpile it back into a version of JavaScript that is compatible with all web browsers, even those that were built 10 years ago. And it uses a combination of techniques to accomplish this. We're not going to get into any of those. But if you want to take the first tact, if you want to be careful with the JavaScript that you write and only use those original features, I guess you can say, of JavaScript, or the early features of JavaScript, there's a website for you. You want to take a look at this website called Can I Use? And so we can take a look at maybe one of the newer features of JavaScript, the let keyword. I'll type it in here in the search box, Can I Use? And it will show us the let keyword, gives a quick description of what it is, and then it will show for the current versions of each of the web browsers whether it's supported or not. And you can see that the let keyword does have wide adoption across all modern web browsers, with a couple of exceptions. Now, if you want to go ahead and use the absolute latest version of JavaScript, and then take that second tact where you transpile your code so that it's backwards compatible with as many versions of the various web browsers as possible, then you want to check out a website like, and a tool actually, called Babel.js. So you can find it at babeljs.io, and it will again use a combination of techniques to take your code. And you can see some of this little animation that's on the page right now. You can actually use this to type in some code here and see how it converts it into the older style JavaScript. And I'm not going to cover how to use Babel in this course, but you should know up front that writing JavaScript for web browsers requires that you give some careful thought to how your JavaScript will ultimately be consumed and who your targets are. And that definitely means that you're going to have to take into consideration the fact that some people will be using older web browsers. But writing JavaScript that will run on a web server using a framework like Node.js is a bit easier because, well, you're going to have some upfront knowledge about where that code will ultimately be executed. But this is not a course specifically about Node.js either, even though we're going to use Node.js as a lightweight means of executing these little tiny JavaScript examples that we're going to create throughout this course. So you're going to learn enough about Node.js to be able to write a simple tiny application, but it won't do anything cool like serve up a web page. However, I'm sure there are other courses here on Microsoft Virtual Academy and elsewhere that will help you kind of take that next step. So the game plan for this course is to start in the very next video by installing the tools that you'll need to get started. And then we're going to start with the absolute ABCs of JavaScript and programming in general. And I encourage you to follow along by typing in the code that I type in the video. And that's, typing it yourself is the absolute best way to learn. It starts to develop muscle memory. You'll have many of those aha moments where you realize, oh, I see how these two things are related. You can hear it, and that's one thing, but to type it in and to see it on your own computer working is something entirely different. I highly recommend that you become an active learner by typing in the code yourself. But I encourage you also to pause and rewind the video as many times as you need. This isn't a race. You don't consume these kinds of videos the same way you would watch a TV show, a movie, or a YouTube video. If something's not clear to you, don't just let it go in one ear and out the other and worry and say, I'll figure it out later. No, stop down and figure it out now, because you never know. It might be something foundational you'll need to know in the next lesson and the next lesson. But by the end of this course, you're going to be well positioned to move on to a more advanced JavaScript course to learn how to use modern client frameworks like React and Vue and Angular. Or you'll be well positioned to learn more about server-side frameworks and libraries like Node.js and Express.js and others. But no matter what, you're going to have a great foundation to build on. If something I say doesn't make sense, again, I can't stress this enough, seek out other sources online. And you're going to ultimately want to know something from me. I've recorded enough of these courses. I know the questions that are already coming. You're going to ask me if there's a book that goes along with this course that I could recommend. And I'm sorry, I don't really have a specific recommendation. Honestly, my recommendation is that you exhaust the dozens, if not hundreds, of JavaScript online resources where you can simply use them for free and find them in an instant. If you want to get more explanation about any given idea that's covered in this course. Okay, so let's go ahead and get started. I want to encourage you to take your time. Don't feel overwhelmed. Stick with JavaScript, stick with this course, and you're going to be well rewarded, I promise. It'll be more difficult than playing a video game, than watching a movie or reading a book, but I promise you, you're going to wind up enjoying it even more than any of those things. Even if I wasn't paid to write code, I would do it because it's fun, it's mentally challenging, and you get this rush whenever you write code and you see it working and you're like, wow, this is awesome. So I'm glad you're going to get an opportunity to do that. It's the most fun you're going to have on a computer, I promise, and you'll wind up enjoying it. So stick with it, and I'll try to encourage you along the way. All right, so we'll get started in the next video. See you there. Thanks. All right, so let's get started. We're going to install the tools that we're going to need for the remainder of this course. Fortunately, we don't need a lot, and everything is free. And everything I show you will work regardless of which operating system you currently have installed. So regardless of whether you're using Windows, Mac, or Linux, everything I show you will be available for those platforms. The first thing we're going to need is a web browser. I'm pretty sure you already have one of those installed. Any will do. I would probably recommend that you either use Microsoft Edge or you use Google Chrome. The second tool that we're going to need to install is Node. It is the JavaScript runtime. It's what will actually execute the code that we write. And we'll talk about that more in just a moment. And then we're going to need an authoring tool, something where we can actually type the code in. Now, in the past, I've used Notepad to actually demonstrate, because I didn't want to recommend one tool over the other, but then Microsoft came out with Visual Studio Code. It's available on all three platforms. So it's also available for free. So no matter what you're using, you should be able to download it and follow along. Now, you may already have a favorite tool for creating web pages and so forth. Feel free to use that. I'm not going to do anything that's so Visual Studio Code specific that it will exclude you. Please follow along no matter what tool you prefer. But let me put in a good plug for Visual Studio Code. I've been using it pretty much as one of my exclusive tools in my full-time job for the last 3 months, and it's really good. So I highly recommend it. Let's get started. We're going to need Node, and you may already have Node installed. So let's just see if you do or not. Let's go, and in Windows, I'm going to open up a command prompt, and I'm going to type in node-v. If I had Node installed, it would display the version of Node that I currently have installed. I don't have Node installed on this computer, so I get an error message. That's good. So to begin, we're going to go to node.js. I can type. There we go. nodejs.org. And again, regardless of which operating system you're using, you should be presented with an opportunity to download either the supported version or the current version, which has like the latest features. You don't need that. Just use the LTS version, which is recommended for most users. As long as you're using the version that I'm using or greater, we should always be in sync. Again, we're not going to use any really advanced features of Node, so this shouldn't really matter much. I'm going to go ahead and run it, run the installer here. What you see next, depending on which operating system you're using, you may see something a little bit different than what I see on screen, but hopefully you've installed things frequently enough that you can work your way through it. So here we have the Node.js setup wizard, and I'll just walk my way through, agree to the license. I'm going to pick a place on my hard drive to install this. There are some options. I'm not going to really do much of anything, but I do want to make sure that in Windows that this is added to my path. This will make sure that Node is available in any directory of my hard drive. So when I type in node v from anywhere in my command prompt, it'll pop up. Okay, so just make sure that everything is selected and you'll be fine. It's not that large. Next, I'm going to have to agree to Windows UAC. You may see something different here on the Mac or Linux. I'm going to go ahead and agree to that little security prompt. And it only takes a minute or two to install Node, and then we'll move on. But basically, Node, in a nutshell, is the V8 JavaScript engine that they ripped out of Chrome. They added some tooling around it to support things for like HTTP, working with requests and responses, and with the file system. And they created one of the most robust web server tools that is available today, and many large applications are using Node currently to host their applications. We're not going to use it for that. We're going to use it for something much more mundane, which is to really just write out little text messages to a console window as we get started. Then we'll graduate on and use it in web pages much later in this course. All right, so I should have it installed, right? So I come over here and it still says it's not installed. I'm going to have to reboot my computer. So let's pause. I'm going to pause the recording of the video right here. I'm going to reboot, and then when I come back in, we should be able to move on from there. All right, so I've rebooted. Let's open up a command prompt, type in node-v, and I can see the version number, so we're successful. The next step is to install Visual Studio Code. Visual Studio Code is different than the full version of Visual Studio, so Visual Studio Community, Professional, or Enterprise. Visual Studio Code is a lighter weight code editor, mainly used for web development, but I know people that use it to develop C# applications and other type of applications where you can use the command line tools to compile your code and things of that nature. That's not something I would ever want to do. It's great for web development, and that's what we're going to use it for authoring our JavaScript files and then executing Node commands in a built-in little command window, command prompt like we see there. Again, available for all operating systems. You just go to code.visualstudio.com. It should be able to detect which operating system you're currently using, and it gives you a download option for that. All right, and we're going to go ahead and run it in place. Again, Windows UAC prompts me to make sure that I am authorized to install it. We get to the code setup wizard. I'm going to go ahead and accept the agreement, and we're going to work our way through the defaults. Sure. And you can see that we can also add Visual Studio Code to the path, which will become available after restart. I don't need that necessarily for this course, but hey, you know, it doesn't hurt. In fact, let's go ahead and use it for everything here. That's up to you. You can read those options and choose what you want, but for my purposes, this will work just great. And we'll see throughout this course some of the things that Visual Studio Code will do for us as we're typing our code. Simple things like code coloring and code completion, managing our files, giving us an environment to execute command line tools like the Node command line tool. And there are many things like that, IntelliSense, others that will give us the tools to hopefully allow us to author our JavaScript code accurately. So let's go ahead and launch it. And let's just do what I call a quick smoke test. And we don't need get for this course. I'm just going to hit close on that. So what we'll do is go to the Explorer. It's the little icon in the upper left-hand corner here. Let me kind of pull this out and make this a little bit sized a little bit more nicely here. Great. I'm going to close down the welcome screen. I am going to click Open Folder, and I'm going to go on. For me, I'm going to go to my C drive, and I'm going to create a source folder. Now, depending on your operating system or what your preferences are, you may want to create a folder somewhere else. But create a folder because we're going to put some JavaScript files and later some HTML and CSS files in that folder, and we're going to want a folder structure. So right here in the Open Folder dialog, I'm going to right-click and select New Folder. I'm going to call this source, lowercase s in source, and then select that folder. And now that becomes the working folder that I'm going to use to add additional files and all the work that we do for this course inside of there. Here, it doesn't really wants me to put git, install git, and I don't want to do that. What I really want to do is go to terminal, all right, and depending on which operating system you're installed on, you might see something different here. In Windows, you see PowerShell. It doesn't really matter as long as you get a command prompt. And here I'm going to type node-v, and I can see that. That's awesome. And then what I want to do is add a file inside of this folder, this working folder. So I'm going to click on this little file with a plus symbol in the upper left-hand corner. I'm going to type in app.js, and it opens up a new file here in the main area with a little JS icon right next to it. And here I'm going to type all lowercase console.log hi. I'm going to go to the end and hit a semicolon. So let's kind of walk through this. The word console, a period on your keyboard, the word log, L-O-G, and then an opening and closing parenthesis. Inside of there, I want to put an opening single quote mark and a closing single quote mark, and then some word. I put hi, you could put your first name. It really doesn't matter. But what does matter to me, at least, is that you end it with a semicolon. And as you're going to come to learn, writing code is an exercise in precision. If you don't write exactly what I write, there's a chance that you will not get the results that I get. And so you want to double check and make sure there's not extra spaces. You want to double check to make sure that you're using the right characters. Like, this is not a comma, it is the period on the keyboard. All right, this is not a curly brace, it is a parenthesis. This is not a double quote, although that would be acceptable. In this particular situation, I would prefer if you used a single quote, which is on the same key, you just have to hold down the shift key, all right, to get to it. All right, so now I'm going to use Control S on my keyboard to save, or it might be Command S if you're on the Mac or something else on Linux. I don't know, whatever you use. Or you can just go File, Save. All right, now watch what happens when I just use the space bar on the keyboard. Did you notice, see that little symbol there? It went from X to a circle. That means that file has not been saved yet. That change that I made is not saved. So here again, I'm going to use the keyboard shortcut to save it. Then I'll come back down here into the terminal. Now, how can I do this easily? Well, on Windows, the keyboard shortcut is Control and then the back tick. That's usually next to the number 1, kind of to the left of it on most keyboards. So the back tick will close and open up that little terminal window at the bottom. And now I can type in node space, and then I want to use the name of this file, so app.js. And hit enter on my keyboard, and it should print out that word, hi, that I have inside of those 2 single quote marks in console.log, all right? Now, we can also shorten this up, node space app. We don't have to use the file extension, and it will work as well. All right, so assuming that you were able to follow along and you got to this step, then you're ready to move forward, and we're ready to get started actually writing some JavaScript. Let's start that process in the next video. We'll see you there. Thanks. So our job as software developers is to author code which is using a language that's human readable, and author in such a way that can be understood and parsed and interpreted and ultimately then executed by a computer. And the code that we write, we save into files, and we ask some execution environment, whether it be a web browser or in this case Node, to take a look at this code that we wrote in this file and to interpret it and to execute it. All right, and so it's important, first of all, as we get started, understand that how our code is going to be used. We're working and learning the JavaScript language, but ultimately the code that we write will be executed in, let's be honest, 1 of 2, maybe even a 3rd environment. We're either going to write JavaScript code that will ultimately be executed in Node. And typically when we're writing code for node-based applications, we're writing applications that can access the file system, access the network, respond to HTTP requests, and provide an HTTP response. Things that are more server-side in nature, all right? And then we'll also then write JavaScript code that will execute in the context of a web browser. And we would expect for that code to be able to dynamically interact with elements, HTML elements on a given web page. All right, but we might also use JavaScript to write video games in an environment like Unity, for example, and be able to author and control the various objects on screen and their animation and their interaction and so on. So what I'm trying to get at here is that there's a difference between the language itself and then the environment that it runs inside of. And we need to be aware of that those are two separate things, even though sometimes they feel like one thing. In this case, console, for example, the console.log function is provided to us by Node. It allows us to tell Node that we want to print something to the command line like we did just a moment ago. Now there's also a console.log function in most web browsers, and it allows us to print little debugging messages or console messages that can only be viewed inside of a web browser whenever we have the developer tools open. And we'll see how to do that much later in this course once we start building web pages and JavaScript that can interact with them. But at any rate, let's get back to the matter at hand here. If I write my JavaScript incorrectly, then the runtime, whether it's Node or a web browser, won't be able to compile it, and it'll give us an error. And so JavaScript is similar to English in so much that JavaScript has a syntax, and it has a proper syntax versus a syntax that's incorrect. So if you've ever taken an English class, you'll know that there are parts of speech that you're supposed to use punctuation at the end of a sentence to indicate the end of a complete thought. There are nouns and verbs and adjectives and adverbs and prepositions and all these sorts of things, right? And so, in general terms, the same thing is true with JavaScript. There are parts of speech. We'll talk about those. And so you will be learning a new language, starting with your ABCs and with I guess vocabulary words, so to speak, and then to move on to authoring sentences that are complete thoughts, and then stringing those sentences together into paragraphs in order to accomplish some higher level task, and even kind of arranging those paragraphs together to create entire applications. All right, so hopefully that analogy will serve you well as we get started here. Our goal as we get started is to author JavaScript statements, and a statement is basically just one complete instruction. It's like a sentence in English, and each JavaScript file that we create, like this app.js, it'll contain one or more JavaScript statements that will execute in sequential order from top to bottom, at least usually. And I'll talk about the exception to that as we get further into this course. But there are some other similarities between JavaScript and English. For example, there's an end-of-line character. I was very, very specific about adding that semicolon at the end of our statement. And that just is an indication to the compiler that this is a complete thought and it should be carried out as is. All right. Now, we also see that we have our statement all on one line of code. And generally speaking, as we're getting started, we're going to write our JavaScript statements one per line. Now we'll bend those rules as some of our statements become very long. We can actually, for readability's sake, from a human perspective, we can split things up onto multiple lines if we need to. JavaScript, specifically Node, doesn't really care about that. That's really more for human readability. It can deal with multiple lines or a single line for a given statement. But be that as it may, we're going to try to strive at the beginning to write one statement per line in our files. And a statement usually consists of one or more expressions. So We'll talk about expressions a little bit later, but this particular expression is essentially just executing a function that's built into Node. It's the log function. It belongs to an object called console. We'll talk about objects and functions a little bit later here. And we execute it by using operators. Those, in this particular case, this is the function invocation operator or the method invocation operator. It's those open and closing parentheses. And we can even then pass in what are called arguments to those functions. So you can see that each little piece of this has a name and it has a role to play in creating our functions, and we'll learn more about that as we move on here. One thing to note is that JavaScript is case sensitive, and this trips up a lot of people to begin with. That's why I was very specific to say, hey, don't accidentally or mindlessly use capital letters. Make sure everything is lowercase. Let's see what happens if I were to save this work that I did here with the capital C in console and the capital L in log. Let's go node space app and hit enter, and we get a reference error. Console is not defined. It's not defined inside of Node. Console doesn't exist with a capital C inside of Node. It exists with a lowercase c inside of Node. The same thing is true with the function name log. Let's go ahead and I'll just use the up arrow on my keyboard. That'll give me the last command that was used in the terminal. So again, node app, and I'm going to try to execute this little program again, and I get another error. This time console.capital log is not a function. That's true. It's because it's lowercase l in log, and I'll save that change and then we'll re-execute this and it will work. Now there are some things that, especially when your application is small, don't matter. So you might have accidentally left off that semicolon at the end and the application still runs, but that's a bad practice to rely on that. You should always try to create properly formed sentences, even though you could write an English sentence or a text message that somebody could understand that has no punctuation, has no capital letters and things of that nature that would make it a well-formed English sentence. And you're relying on the person receiving that text message to understand what you're trying to say. The computer doesn't work that way. It needs to know exactly what you're saying, and so you have to be precise. Precision is the key as a software developer. All right, so what I want to do here as we kind of start wrapping things up for this first foray into JavaScript, I'm going to comment out this line and add some new code below it and use that as kind of the next step beyond where we're at right now. So to tell the compiler to ignore a line of code, I'm going to add a code comment. And here I use 2 forward slashes. I added also a space, but that was really just for readability's sake, so that myself as a human, I can kind of make an easy distinction, because sometimes all these characters run together. I like adding a space between this. But these two characters say, forget everything on this line of code. Don't compile it. Don't try to use it. All right. And we'll see in a moment that there's another way to create code comments as well. But here, let's create something a little bit more interesting. I'm going to say let x equal 7. I'm going to say let y equal 3. Let z equal x plus y. And then we'll do console.log. And then I'm going to use open and close parentheses. I'm going to use a single quote. I'm going to type in the word answer, colon, space. I'm going to go outside of that quote. So I'm going to go between the closing single quote and the closing parenthesis, and I'm going to make some space for myself in there. I'm going to use the plus key, or the plus operator, and the letter Z. I'm going to go to the end of the line and use the end of line character, the semicolon. I'm going to save it all. Now, before we actually execute this, what do you think this will do? What do you think will be printed to our console window? Do you have any guesses? Well, I'm betting that your background in math or algebra probably will lead you to the correct answer. And I think that your intuition in many cases is something that's important as you're learning JavaScript. It is human readable. it should be somewhat understandable. It might require a little extra explanation because there's some things that are not extremely obvious, but for the most part, this shouldn't blow you away, and nothing we cover should ever blow you away. It just might require a little extra effort than you're normally used to putting into things, but by no means impossible, right? So just take some comfort that this is well-traveled ground, and that if I can understand it, I promise you can too. Let's run the application and see that we get the correct result, which is answer colon space and the number 10. So how do we get that? Well, we have something here, let x. And even though, again, you're not a JavaScript developer, or an advanced JavaScript developer just yet, I'm willing to bet that you understood that we were creating a variable, essentially, a bucket that could contain a value. And immediately we set that variable equal to the value 7. And then we did the same thing with the value of 3. We put that into a different variable, a different bucket called y. And then here we have an expression that will add two values together. What are the values inside of those variables x and y? Well, we just assign them in lines 3 and 4. And we know that that probably means we're going to add those together to get the result of 10. And we assign that into a new bucket, a new variable named z. And then we merely print out that literal string. But then we also say also append the letter or the value that's in z. Now, hopefully that made sense to you even before we ran the application. But you can see here that, for example, the plus symbol has double duty. It's serving to be the addition operator, but it's also serving to concatenate two values together. In this case, two string values together so that we can print it out to screen. So we're going to use this kind of as a starting point and talk about this at more length in the next and subsequent videos. But hopefully up to this point, you get some comfort level. You're writing some code. You're getting your hands dirty in the code. And, I know you can do this. So just keep pushing forward, and let's pick it up in the next video. We'll see you there. Thanks. In this video, I want to continue talking about line number 3 so that we completely come to a full understanding of what variables are in JavaScript. So I'm going to add a new file, and I'm going to do that by hovering over the source tab of the Explorer. And I want to type in variables.js, like so. And then I'm just going to copy in the code that we had here. We'll use this as a starting point. All right, so let's focus in on line number 1. Let's just, first of all, let's make sure this still runs, and let's go node, and this time we're going to give it the new file name variables, and we get the same result as before. Great. So what is a variable? I think I said at the very end of that previous lesson that a variable is basically just an area in the computer's memory where we're storing a value. We're requesting or declaring our need for a new variable, a space in the computer's memory where we can put information and retrieve information. And then we can, from that point on, continue to use that variable to store different values and retrieve those values back out throughout the lifespan of the application. So there are actually several different parts to the variable declaration statement in line number 1. The first is the let keyword. And let's start talking about the parts of speech in JavaScript. A keyword is something like let, and we'll see some other examples a little bit later, but essentially think of it like a verb in the English language. It's an instruction to the JavaScript compiler that we want to do something, that we want to take action. So we want to create a variable with the name of X, and we're expressing that intent to JavaScript using the let keyword. All right. So that's the first part of it. And then the second part is the name of the variable that we want. So we're requesting that a area of storage, a unit of storage is assigned to our application where we can put things. But how do we reference that? Again, it needs a name so that we can get the values and put new values in memory, all right? And so that's usually called an identifier. We want to declare a new variable with the identifier of x, and we're going to talk about naming our identifiers, naming our variables. There's some rules and some conventions that we need to follow as developers. All right, we'll come back to that at the very end of this lesson. Now, before we get too far, there's actually a couple of different ways to declare a variable in JavaScript. The original keyword that you'll see used in 99% of all tutorials and articles and books and videos is the var keyword. And until recently, this was the only way that you could declare a variable. In the latest version of JavaScript, however, the recommendation is to abandon var unless you really need it. Use the let keyword instead, or the const keyword, which we'll talk about in just a moment. If we were to save our application using the var keyword in line number 1 and then rerun it, nothing would change. So what's the problem with var? There are some, well, I guess there's two ways to kind of explain it at this point. The first is that its usage is very nuanced. It does stuff that somebody new to JavaScript may not anticipate the ramifications of until it's too late and there are problems in code. We'll talk about the var keyword and how it relates to scope and so on in an upcoming video, but we need to introduce some more concepts before we can get to the point where that discussion is even interesting, okay? So its usage is nuanced and the ramifications can be pretty challenging if you're just getting started. So that's why the people who decided what goes into JavaScript said, why don't we introduce a new keyword called let? It will work like most other programming languages. As you try to learn JavaScript, hopefully it won't be problematic. So that's why we have the let keyword. The other keyword for declaring a variable is const. And we use that whenever we want to express our intent to the JavaScript compiler that we do not intend for that variable to ever change its value. So what we initialize the value to, in this case to 7, we wouldn't expect that to change throughout the lifetime of the application. And if we try to change it, like in the very next line of code, we can attempt to set it equal to 6. I'll save that. Let's go over and try to run that code. We're going to get an error, and it actually is pretty helpful. It gives a little caret right underneath the equal sign, and it says assignment to constant variable. That's the problem. And the issue here is that we've said to JavaScript, we never want to change that value, and then the very next line of code we say, yeah, I'm going to assign it a new value and set it equal to 6, and it says can't do that. Okay, so for the most part, we're going to use the let keyword most of the time because that's the recommendation now as we learn JavaScript. All right, so just want to point out that we can uncomment out line number 2 as we assign the value of x to different values. And we can keep doing this as many times as we want to. So at this point in line number 1, we've declared the variable, set it to 7, then we've assigned it the value of 6, then 5, then 4. We can keep changing the value in the computer's memory. And what is the value in line number 6? What's x's value? Well, the last time we assigned a value to it was 4. So the application now, whenever we run it, will give us 7 because 3 plus 4 equals 7, right? So that's what we get in line number 7. Great. All right, so I guess this should be obvious at this point. The equal sign here is actually what's called an assignment operator. This is how we assign a value into a variable. And we can keep assigning values as many times as we want, but we can only declare a value or variable one time. So if I were to try and come down here and say let x equals 7 again, or let it equal 8, I'm going to get an error. Whenever I try to run the application, the identifier x has already been declared. Again, you can only declare a variable once, but you can assign its value as many times as you want to after that. All right. So in line number 1, not only are we declaring the variable, then we're also assigning its value right off the bat in the same line of code. And when we do that, it's a technique called initialization. This is actually two lines of code rolled up into one. Lines number 1 and 2 now are roughly equivalent to what we had before. Well, roughly equivalent. There is one difference here. At the end of the execution of line number 1, what is the value of x? Well, let's find out. Console.log, and then we'll just say, what's the value of x at this point? And then let's run the application. And you can see that first value that's output above what we get now in line number 11 is the term undefined. We'll explain what undefined means in more detail a little bit later, but essentially it is what it sounds like. We've declared a variable, but we've not defined it, we've not put a value into it, so it's undefined, all right? And that's generally not something we want. It might be in some cases something we need, but for the most part, we won't do that. It's preferable that at the moment of declaration you also initialize your variables if you can. All right, so that would be valid right there. All right, so now let's finish this up and talk about the rules for naming our variables. The variable name itself, I think I've already referred to this as an identifier. And so there are rules for identifier names, and then there are some code conventions. And these are not enforced by the JavaScript compiler, but are rather things that are best practices as determined by the community of software developers who've come before you. So let's talk about those things which are hard and fast rules that will actually break your application. Rule number 1 is that all identifiers, all variable names, have to begin with either a letter, a $, or an underscore. So that's rule number 1. Rule number 2 is that the variable names can contain letters or numbers, $, or underscores, but no other special characters, and you can't use a space in between, two words that you intend to be considered together as an identifier. Identifier can't have any spaces, all right? And then rule number 3 is that you can't use any keywords. So I can't do something like this. Let equal to 8. And if we try that, we're going to get a weird error. Let is disallowed as a lexically bound name, all right? And so even if we were to scroll up just a tiny bit, it puts those carets right underneath the let, the second one, because we're trying to use that identifier, but it's already a keyword, right? So you can't do that. All right, so those are your own. Oh yeah, there's one other rule, and that is that variable names, identifiers, are case sensitive. So we could do this, and it would be a perfectly acceptable application. These are two different variables, uppercase x and lowercase x. So if you intend to do something like this, let's see what we get here. All right, it doesn't blow up. So we were able to use x and assign it to 8, but we didn't declare the variable. Well, something fishy is going on, and we'll get to the bottom of it before the end of this course. But the key to this is that we're not working with the same x as we're working with here. All right, so let's just get rid of that. But those are the rules. It has to begin with a letter, a $, or underscore. The rest of the name can have pretty much anything, including numbers, but no spaces or other special characters. Can't use any keywords for names of variables, and be aware that variable names are case sensitive. Now, there are code conventions, and these again are just good practices. The first one is that variable names should be descriptive. And unfortunately, X, Y, and Z are not very descriptive names. Ideally, we would use something like maybe, let's go down here. So let first number equals 7, and then let second number equals 3, and then we could use that in line number 12 instead. Here's some better ones actually, like if we wanted to capture information or represent information like the first name, or let zip code equals 75082. And so on. All right, so use names that represent the thing you're trying to store and from an application perspective. What meaning does this variable have inside of our application? Meaningful variable names. The second is camel casing. So if you are going to use multiple words, you should use this format called camel casing, and that means that the first word of your variable name should be lowercase. So the F in first is always lowercase. But then any subsequent names that we append or words that we append together should have a capital letter. So you can see that I followed this convention every single time in lines 15 through 18. Lowercase z in zip code, capital C in zip code. All right, so camel casing. Third one is to be consistent, and that is to always follow the same kind of naming convention. And this would be true kind of across not just the names of variable names, but for every other type of identifier that we wind up creating in our application. Stay consistent, pick one style and stay with it throughout the remainder of the application. And then the other is to not rely on case. We've already seen the danger of that. But what if I intentionally want to do let zip code equals 60459? What we've just done, while it's grammatically correct from JavaScript's perspective, and those are two separate variables in line 18 and 20, we've introduced some subtle dissonance in the application. Now it's more difficult for me to see that these are actually two different variables, and maybe I intended to do that, but that's poor programming practice. We might choose maybe a better name like first zip code and second zip code. That might be a better way to go about that same sort of thing. Okay? So those are the code conventions and the naming rules for variables. And that's just about everything you need to know about variables. Just about. There's actually a little bit more that we need to talk about, and we'll finish up this discussion in the next video when we talk about the values that we're actually assigning into variables and their data types. And we'll talk about that next. See you there. Thanks. In this video, we're going to talk about the values that we store in variables, and we're going to talk about the types, or rather the data types of those values and why they're important. So to begin with, let's go ahead and create a new file called datatypes.js, and this is where we're going to do all of our work. And one of the things that makes JavaScript so unique when compared to other programming languages is that whenever you declare a variable, like we do here, let x equals 7, the variable itself does not have a data type. Only the values that we store inside the variables have the data type. So we can kind of see this whenever we're working with variables. We can use something called the type of operator, and this will tell us the data type that we're working with. So, well, let's go ahead and go back to here. Let x equals 7. So let's start off by just doing console.log, and then we'll say type of, all one word, lowercase, and then x. And let's save that. Save it. And here I'm going to type node and then data types. And you'll see that it outputs a number. So that's one of the first data types. The X data type is a number, and a data type is really just the kind of data that we want to store. So if you want to perform math or some algebraic operation, then you want to use a number. And if you want to do a yes or no, true or false evaluation, then you'll want to use a Boolean. And if you want to display something on screen, then you'll want to use a string, which is basically a shorthand for string of characters. And you usually represent those with single quotes with whatever string of characters you want to use inside of it. So let me give you a few examples here. We've already looked at number. Let y equal true. And so then we'll do console.log type of y. And then I'll just go ahead and do z as well. Let z equals hello world. And then console.log z. whoops, not just Z, I want type of Z, all right? And so now let's go ahead and run this, and we can see that we get the three data types that we're currently working with: a number, a Boolean, and a string. So in the case of a number, it can be any positive or negative number. It can even have decimal values. In the case of a Boolean, it can either be true or it can be false. Those are the only two values. And then if we want to create a string, it's going to be anything inside of the single quotes. It's a literal string of characters. I literally want HELLO space WORLD, all right? And so those are your three of your seven basic basic types, data types. There's also another case. Let's let A and then console.log the value of A, and then console.log type of A, all right? And just to remove the confusion here, I'm going to use a multi-line comment. This allows me to avoid having to do this on every line, right? I can just do this little /* at the top, then go down to the bottom of where I want to comment out, and then */. And you can see everything that's highlighted in green or turned to the green color is now commented out, just as if I had commented out each individual line separately. So here I'm just creating a variable A, but I'm not initializing it to a value. Remember, do you remember what it output when we did this before? It output the value undefined, but we want to see what the type is, because we said that it's the value that's assigned to the variable that has a type. So what is the type of a variable that has nothing assigned to it? Well, that's what we're going to get to the bottom of right now. So we see that the value is undefined and the type is undefined. So now we have four types. We have number, Boolean, string, and undefined. And there's two or three others that we're going to look at here before the very end. We'll get to them. They're a little bit more complex, but those are the four that we have to work with, at least to start off with. And so that's all I really wanted to say. The next thing we're going to talk about very quickly is how I would convert one type into another type. How do I force JavaScript to treat a string like this, console.log, and then a literal string of the value 9? How do I make it treat it like the number 9? Well, we'll talk about that in the next video. We'll see you there. Thanks. In the previous video, we learned that values, not variables, have a data type, and that the data type is essentially a description of what you want to do with the data. There's more to it than that, but for our purposes right now, it's essentially what we intend to do with the data. And we learned of 4 data types, and we'll learn about a couple more a little bit later. There's the number data type, the string, the bool, and the undefined. So let me ask you this: what happens when we need to use them together and they don't quite work the way that we think they should? What options do we have then? So let's go ahead and create a new file. I'm going to call this Coercion, COERCION.js. I think that's how you spell it. And let's start off with a quick little example here. So let A equals 7. Let B equals the string, the literal string. So I want to use single quote 6 single quote. All right. And then let C equals A plus B. And then console.log answer. And then C. All right. Before we execute this application, what do you think is going to be output when we run it? What will the answer be? All right, get that in your mind. And now let's go node and coercion. And looks like we don't get anything at all. Oh, I need to save it. Okay, there we go. Let's try that again. There we go. We get the answer 7, 6. Wait, 7 plus 6 should be 13, right? Why are we getting 76? Something, I can see what's happening. It's not treating these as two numeric values. It's treating them both as string values. So it's not adding two numbers together. Somehow it's coercing that A from a string or from an integer into a string and then concatenating together A and B. So this operator, the plus operator, we saw how we can use it for addition, but we also, it plays double duty, and it's the string concatenation operator. But moreover, JavaScript realizes that it can't add a number in a string. Those are, it's like adding, you know, an apple and a car together. It's not like making an apple and an orange even. It's not like fruit salad. It's like two disparately different things. What do? Well, I will take the numeric value and coerce it, convince it, force it against its will to become a string, and then I will concatenate the two together. So that's the notion of coercion, and most people consider that to be an evil thing or a very dangerous thing. And others just say, well, it's just what happens, you know, it's just part of the language. Now, what if I really wanted to perform addition on two integers? Well, then I would need to take steps to force the string 6 to become a number so that I could then add them together. And so to do that, there's actually a special function that will force that conversion. So let me change this just a little bit. And we already have the value b, so I'll just reuse the value b, and I'll set b equal to parse int. Now, I want you to notice something. I haven't really talked about Visual Studio Code much, but one of the nice things about Visual Studio Code is that it popped up this little box called IntelliSense. And IntelliSense is just a visual cue as I'm typing to show me things that I might need to reference, or things that will help me to find the right command or the right idea. In this case, I knew it was something parse, so I start typing in, and I can then use the arrow keys to start looking. I'm like, oh yeah, there's parse float. That would give me a number with decimal values. But this, in this case, the string that I want to use, I know that it will only be a value without any decimal point. So I want to use the parse int. Now what I can do is just use the space bar, or like the opening parenthesis, whatever the next logical character is, to do what's called code completion, so I don't have to type everything else. Now in this case, I know that I'm going to need to use the parenthesis for reasons I'll talk about later. So I'm just going to do an open parenthesis. Well, it didn't do it for me. Well, let's just go ahead and use the tab key instead. All right, so the tab key will give me what I want. Now I'm inside the parentheses, and I need to pass in, first of all, the string that I want to change. So in this case, take the value of b, and then I need to give it optionally what's called a radix or radix, and that is essentially the base system. So if I wanted to use like a hexadecimal, I might give it 6, but in this case I'm going to give it 10 because I want to a base 10 or a decimal conversion. All right, so that's a little technical, but typically if we use 10 in there, we're going to be just fine. So essentially what I want to do is take this 6, and based on the normal decimal system, I want to convert that into a numeric value, and then I want to continue on in lines 4 and 5 like we had before. Let's see what we get this time. The answer is 13, just as we had hoped. All right, so the parse int is a built-in function to JavaScript, and I can count on it being available in Node or in a web browser or any other implementation of JavaScript. All right, so I guess this begs the question, what if I try to do something kind of evil with this? So let d equal parse int, and then I'll use the tab key to do the code completion. And this time I'm going to pass in a character that will not convert to or even a string that will not convert into a numeric value, especially one that's decimal. So I'm going to save this. Well, let's go ahead and console.log it. And D. And so let's go to that, and then we'll do this. All right, and I get NaN, which represents not a number. It's not really an error, it's just telling us that the value we passed in is not a number. We could actually do something along these lines as well. Let E equals is NaN, and then I can give it some numeric value. In this case, I'll give it D, and I'll do console.log E. So let's save that, run it again, and so this time, now I'm evaluating whether D is not a number, and that is true. It is not a number, because I can see it here that's printed out. All right, so we saw two built-in functions, but there's a bunch of built-in functions for various things, all kind of centered around, in this case, just working with coercion and checking the results of that attempt to coerce or convert one data type into another. All right. Unfortunately, there's no parse Boolean, so you can't take a string of true or false and convert it into a Boolean. You'll have to take a few extra steps. There's a bunch of examples online for that. And so depending on the type of conversion that you're attempting to perform, it may not be easy to convert from one to the other. There's always a way, and usually you can find some code online, especially on a site like Stack Overflow, that will help you figure that out. But that's all I wanted to say. Let's continue on in the next video. We'll see you there. Thanks. In this video, I want to refocus on the JavaScript syntax specifically and the various parts of speech inside of a properly formed statement in JavaScript. So I started by explaining JavaScript by saying that you write statements, each of which are executed sequentially, and statements are complete thoughts, complete instructions to the JavaScript compiler of what we want it to do for us. And I said the statements are made up of one or more expressions, and that an expression is made up of operators and operands. And I just made that statement in passing and kind of blew past it really quickly. But I wanted to take a few moments and explain why that is an important statement whenever we're setting out to write code. And so we've already looked at a couple of different operators. If we're thinking about the most atomic level of our JavaScript statements, we're thinking about in terms of operators and operands. So operators are things like keywords. We've already looked at the addition operator using the plus symbol. We looked at the string concatenation operator using the plus symbol. So that one is doing double duty, and it will be understood based on the context of how it's being used. And then there's the assignment operator, the equal sign, that we've already looked at. And soon we're going to look at a few other common ones just to start building out a list of operators that we can use to do more interesting things inside of our application. But there's also an operand. So operators are things like keywords and those various symbols that we've already looked at, and we'll add more. Operands are something like identifiers, a variable name. We'll learn about functions soon, and functions are another type of operand. And so unlike keywords and operators in JavaScript, which are fixed and part of the language, you and I, programmers, give operands their name. And so by combining operators and operands, we create expressions that are then used to compose statements. And so sometimes it's easy to spot an expression, and then sometimes it's not so easy. But identifying several major categories of expressions, we can better understand why JavaScript works sometimes and why it doesn't work sometimes. So for example, in the English language, we cannot write a sentence, a proper sentence, like this: the dog, period. If we said, hey, the dog, our friend would say, what are you talking about? The dog did what? Which dog? You know, give me some more information, right? Why is that not a proper sentence in English? Because it didn't have enough inside of it to be considered proper. We have a noun, we have the dog, but we don't have any verbs or adjectives or adverbs describing or you know, kind of giving us more detail about the dog. The same thing is true with JavaScript. So we can't, for example, and let me just create a quick file here. We'll call this expressions.js. So we cannot do something like this in our program, right? Because the JavaScript compiler will say, okay, what do you want me to do with that? That makes no sense to me whatsoever. I don't know what you want me to do with A. I don't see it. It's not one of my variables. You're not asking me to create a new variable. There's nothing inside of A. A means nothing to me, all right? So at a minimum, we're going to need to either, and these are the types of expressions at a very high level, we're going to either declare a variable. So we would do something like this once again, let A, all right? And even in this little tiny two-word line of code, there's already an operator and an operand. Here's the operator, the let keyword, and here's the operand, a name we want to give to a new variable that will be created in memory. All right, so that's one type of expression. We're going to call this types of expression. Here we'll just use some comments. Types of expressions. Number one, variable declaration. I think I spelled that right. All right, so let's go ahead and just move that up to the very top and say, this is bad. And then we'll do something like this. I kind of like doing some ASCII art there whenever I create lists inside of my code. All right, so there we go. The other one is to assign a value. So the other type of expression, we can assign a value. So A equals 3 or 4. And then another type of expression is to perform an evaluation that returns a single value. And so that might be something like, and if we're talking purely about the expression itself, it might be something like that, B plus C. So in a more interesting example, we might do something along these lines. And I'll just comment this out because I want to reuse a, there we go. Good. All right, so here we go. Line number 16, I'm going to go let B equals 3, let C equal 2, and then let A equal B plus C. Now, I just want to focus on line number 19. And I want to say that there are 3 expressions in here. Can you find them? All right. Well, let's identify them. So number 1, we're going to see that let A, so that's a variable declaration. The next thing that's going to happen is we're going to perform an evaluation of B plus C. Right, and that will basically add those two values together because we're using the addition operator. And then finally, we'll do the result of B plus C is assigned to A. So 3 expressions all combined into a single statement, and there's a lot more going on than meets the eye, but that is the kind of thinking that will help you understand why your JavaScript code works sometimes and sometimes it doesn't. You have to think in terms of writing expressions that do things to form properly formed JavaScript statements. All right, so hopefully that little lesson in syntax is helpful. Let's talk about operators and the different types of operators. And again, we've used this collection of 5 or 6 operators so far. Let's add to that collection. I'm going to go create a new file called operators.js. And so there's several categories of operators, and I'll just kind of go through them really quickly here. So there's assignment, like the equal sign. It's really the only one in this category, but it's a pretty important one, and we've seen it used quite a bit. There's maybe some other keywords and things that can fall into this category, sort of, but the assignment operator is usually the only one in this category. Then there's arithmetic, with which, as you might suppose, would allow you to do mathematical style operations. So that's the plus, where we're adding two numbers together, subtraction, multiplication, that's the asterisk key over the 8 on most keyboards. There's also the division, all right. And then there are some special ones like, let's call these, and they're kind of arithmetic, but I'm going to call them increment, decrement. So this is the plus plus and the minus minus. And used out of context, these don't seem so interesting, but what we could do is, for example, let's go var a equals 1, a plus plus, and then console.log a. All right, let's save that and then go over to our terminal, and I'm going to do node operators. All right, and so you can see that we increment the value of a. So let's do this. Let's now increment it one more time and see, and let's save our work here. And then let's run it again. And wait a second, the value is still 2. How is that possible? Let's do this. Let's console log a, like that. So now we're going to print the value out twice. We're going to print it out. I thought maybe we would get 3, but we didn't. But if we print it out a second time, let's see what value we get. And so when we print it out the second time, we get 3. And the reason is this, because this operator, this increment operator, works after the line or after the value is already utilized inside of this line of code. So basically, hey, console.log, here's a, and after you print that to screen, then let's add something to it. That's why we're able to see the new value if I print it a second time. All right. What we may have preferred instead of this is to go console.log and put the plus plus before the a. That means I want you to first evaluate the increment of a and then print it to the console.log. All right, so let's save that. Let's rerun this, and now we see 3 in both cases. The same would be true with the decrement, where we could subtract either before or after the evaluation of that variable. All right, just something to keep in mind. All right, so that's increment and decrement. There's also, going back to arithmetic, there's the modulus. And this will give me the remainder amount. So let's go var m for modulus equals 10 divided by, whoops, that's not what I wanted, 10 modulus 3. And then I want to console.log m. And just to kind of keep everything clean, I'm going to comment out all of this as well. Keep it around for posterity, but otherwise, that's all I want to see. What will I get back from this statement? And I get 1. What is 1? It's the remainder. So 10 divided by 3 equals 3 with 1 left over. That 1 is the modulus, all right? And actually, this becomes a lot more interesting and important when we're looping through lots of values, and every like 10th or 20th or 100th item, I want to print a little message to screen to say, hey, we finished processing the 10th, the 20th, the 30th, the 40th, the 50th item, all right? And I use that actually frequently, so I'm a pretty big fan of modulus. Let's comment that out. So moving on to the different categories of operators, let's talk about the various string operators. And we've already seen these. So this is going to be like the literal string operator. We're using single quotes. And then also we saw the string concatenation operator that will take two strings and allow them to be appended together to create one new string. Other operators, precedence. So we might, order of operations, we actually use this quite a bit, even in non-mathematical situations. So, for example, let's just do var b equals 1 plus 2 times 3. Now, if you're coming from algebra background, there's an order of operations where things should be done in a certain order. And I'm pretty sure, if memory serves me correctly, it's been a long time since I've had an algebra course, but you perform algebra before you perform addition. So if I were to do a console.log here, I would expect B to output 2 times 3 plus 1, so that would be 7. Let's see if my memory serves me correctly here. And yes, it does. But what if that's not what I want? Well, I can use, just like in algebra, I can use parentheses to kind of control the order in which things are evaluated. So in this case, I would do 1 plus 2 first and then multiply that by 3, which will give me a completely different result of 9, because 3 times 3 equals 9. Okay, so we'll use this, the opening and closing parentheses for different purposes. For example, whenever we want to do console.log, these parentheses are also used as the function invocation operators. All right, and that just says here's a function name called log, and we'll learn about functions soon. But I want to actually invoke the function now, and I can even use the function invocation operators, the opening and close parentheses, to pass in arguments. And we'll talk about that a little bit later, but again, that is the open and close parenthesis. There are other operators, and I'll just put them here. They may not make a lot of sense at the moment, but they will soon when we look at decision statements. So there's the logical if, I'm sorry, the logical and the logical or, okay? So when I want to add two things together and evaluate two things together, either one of them needs to be true or both of them needs to be true. And we'll look at that in a little while. There's also the member accessor operator. So when we did console.log, if you look at IntelliSense, as I hit the dot on the keyboard, there's that period. Why are we using a period there? That allows me to access the various members of this object. And we'll talk about object, and we'll talk about properties and functions or methods of objects soon. But that's what allows me to access the log function of the console object inside of JavaScript. So here again, comment that out, but we'll use the period for that purpose. We're going to also look at the code block operator soon. And so, you know, I'm going through all these and I'm saying, hey, we'll look at these soon. Really, the point of this exercise is to say that there's lots of operators, and we're going to have to begin to identify what all these special characters are. And the only way to do that is to, first of all, learn that they exist, what their function is, and then use them as we're writing programs. And so I think that's really the only thing I wanted to say. I mean, let me just put one more in here. The array element access operator goes by different names, but I'm just going to use that. And so we'll use square brackets for that purpose. So almost every single character, the special characters that are above are numeric values, and we can access using the shift key, and the various ones that are usually on the right hand side of the keyboard, the various braces and brackets and colons and semicolons, and all of these are used for various purposes in JavaScript and in most programming languages. All right, so I think that's all I really want to say. Let's pick back up in the next video. You're doing great. Hang in there with me. We're getting through some of the easy stuff, and we're going to start moving on to some challenging stuff here really quick, but you're doing great. See you in the next video. Thanks. Up till now, each variable that we create can store one value at a time per variable. But what if we need to work with lists of data? In other words, I need to keep track of several people or several numbers, and I need to store them in such a way that it doesn't matter if I have 2 or 10 or 100, I can kind of keep them together and move them all around and use them in my application as a list, as a grouping of related values. In that case, I want to create an array. And so let's start by creating a new file called arrays.js. And first of all, it's basically, an array is basically a variable that can hold many different values. And so we can declare variable and initialize its value like so. So here we'll do let a equals, and here we're going to use an opening and closing square brace or bracket, and then I'm going to give it a series of values. Each value will be separated by a comma for let's say 15, 16, 23, and 42. All right, and so now I have an array of those values. Now these are just numeric values. What if I wanted to create an array of string values? I can do something similar. In fact, I can use any data type inside of here that's allowable in JavaScript, and we'll see some examples of that a little bit later. But I might want David, Eddie, Alex, and Michael. All right. And then what if I want to get one of the values? I can just do console.log. All right. Inside of here, I'm going to use the variable name. So in this case, I'll use A. And then I'll want to provide a index to retrieve one of the elements. So each of these is an element of the array. And I want to use an index, a numeric value that allows me to get at one of those elements inside of the array. The indexes are 0 based. That trips up beginners sometimes. For example, to get at the number 4, the first element in the array, I would use the index 0. If I want the second item in the array, the second element of the array, I would need to use the index 1, and so on. So to get at it, I'm going to use A, and then right next to the A, square brackets, and then I'm going to give it an index. So here we'll grab the first value, and then I'll grab the second value. All right. And then I want to show you how console.log will just print out all of the values for you nicely if you just want to give it the name of the array itself, the variable itself. So let's save our work, and we'll go node arrays. All right, so you can see the first element of the array at index 0 gives us the value 4. The second element of the array at index 1 gives us the value 8. All right, hope you can see the correlation there. Or if I just want to print out all the values in the array, I can just provide the variable name that contains the array, and it will print them out for me, just like I have kind of here when I actually initialized our array variable. All right, let's comment this out. Now that is how we access individual elements. What if I wanted to change or set the value of one of the elements? The same would work. So in this case, I would say, for example, A0, and I would set it equal to 7, like so. And so then we can just do console.log, like so, and then we run our application. Now you see the first element of the array has been changed from 4 to 7, because that's how we can access a single element and assign it a new value. All right. All right. So what about these mysterious arrays? What is their data type? So let's do console.log type of A, and we can see that it's of type object. And we'll talk about the object data type later, because there's a lot more to it than just being able to create arrays, but it's a little bit more advanced at this point. We'll get into it soon. Just keep in mind that an array isn't a data type of itself. It is a type of something called object, and we'll talk about objects later. All right. So the other thing that's important to remember is that an array can include elements of different data types. So let me just do let C equals We'll start it with 4, and then we'll do Alex, and then we'll do true. All right, so we've used 3 different data types right there, and we can just do node arrays. Oh, I need to actually do a console.log C. There we go. There we go. All right, so you can see that a single array can hold different data types. There's no restriction there. Let's comment that out. What happens if I try to access an element that with an index that does not exist? So let's do console.log, and I happen to know that the B has 4 different elements in it, 4 names, and let me try to access the 5th element by using the index 4, and this will be undefined. So just like a variable without any value assigned to it is undefined, so is a element of an array undefined if we don't give it a value. Now, I can also just programmatically determine the number of elements in an array by using a special property called length. So I can do console.log a dot, and remember the dot is the member access operator. So arrays are objects, and this particular object has a special property called length, which will give me the number of elements in that array. So I would expect to see, let's see, 1, 2, 3, 4, 5, 6. So the question is it going to give us 6, the actual number, or is it going to give us to it in a 0-based fashion? And the answer to that is that it will give us the actual number, not 0-based. And this will come into play a little bit later when we use the length of an array and we iterate through each element of the array to print them to screen when we learn about looping. All right, so just keep that in the back of your mind. Now, there's a lot of strange things that you can do with arrays, and some of them are not always intuitive. Like, for example, if I wanted to just randomly create a new element, so in this case, I'm going to create use the index 10, which means this would add an 11th element to the array. What happens with all of the elements between where we left off, 0, 1, 2, 3, 4, 5. So 6 through 11, what will we get? So let's just assign this to 77, and then I want to do a console.log of a, and then I want to do a console.log and a.length, like we just learned about, and kind of see what happens here. And then let's run that. All right, so we can see that it prints out 4, 5, 6, 7, or I'm sorry, 4, 8, 15, 16, 23, 42, and then it says there's 4 empty items, and then there's 77, and it says that there's 11 items, 11 elements in this array because we filled up the 10th index, or index 10, with a value. So it will create essentially what's called a sparse array, and that means that there are empty elements inside. Now, this isn't usually the way that you want to work with arrays if you need to add new values, because it's not as safe. We're inadvertently creating elements with nothing in them. There's a safer way to go about this using some additional built-in functions of the array. And so if I wanted to add that value and add it to the end of the array, no matter how many elements are currently in the array, I could use the push method. And so I say, hey, I want to push the number 77 to the end of the existing array. So let's copy this and paste it here. And then if I wanted to remove it, I can use a method called pop. So this function pop will remove the last element of the array. In fact, I can call it several times to keep removing elements of the array. And here we'll just print out what the end result is, just like we did previously. So now this should put some fireworks into our terminal window. So you can see that using push in line number 29, I was able to add the number 77 to the end of the existing array. And that gives me 7 total elements. Now I call pop 3 times. It removes 77, 42, and 23, leaving us with just 4 elements in our array. Okay, so we're going to continue to use arrays. They're a great way to keep lists of things together and accessible, and they'll become even more important again as we learn how to loop through arrays and to evaluate each element. We can even use arrays to hold on to other things like objects and functions, and we'll learn about some advanced use cases with arrays a little bit later. All right, so that's all I have to say about arrays. Let's move on and start looking into some things that are beyond the absolute basics. We'll start moving and talking about functions. All right, see you there. Thanks. Throughout this course, even from the very first line of code that we wrote, we use the console.log function to print things to our terminal window. And I kept referring to log as a function as part of the console object. In its simplest form, a function is merely a block of code that we as programmers can name. And once it has a name, then we can call it by its name. But it's just one or more lines of code that we put into a block, and then we say we want to execute that block over and over and over again throughout our application. So again, that's a very basic explanation of what a function is, but in JavaScript, functions can do so much more. In fact, most of this course will be devoted to working with functions because, frankly, they're one of the primary constructs in JavaScript for getting things done. So first of all, let's go ahead and create a new file. I'm going to call this function declarations.js. All right. And first of all, if I have some code that I want to reuse throughout my application, I want to add it to a function. So we can create a function, and I'll walk through and explain the parts of a function here in just a moment. Let's create the most basic function that I can possibly think of. And I'm actually going to copy and paste some code in so we don't have to type it all. But nothing here should be all that revolutionary. So I've created a new function called say hello. Notice my name. I use camel casing, right, in order to name my identifier, my function name. All right. And then I have 3 lines of code. Notice that they're inside of these curly braces. Notice that they're indented, so we see kind of a relationship between this code on the inside and this line of code and this line of code on the outside. So it kind of represents a container relationship. This code sits inside of, or is part of, or is rather the body of the function that we've just declared. All right, so here we just declared a simple function. This is called a function declaration, this style. We're going to look at other ways to define functions later, and I'll draw your attention and why you'd want to choose one or the other later. There's at least 2 other ways that I'm thinking of off the top of my head. But first of all, notice that we use a keyword called function. Then we give the function some identifier that we come up with, something meaningful. We'll use similar rules to what we use for variable names. All right. Then we use an open and close parenthesis. You'll see how these will be used in a little bit to define arguments or input parameters to our function. But right now it's empty. We don't require that the caller give us any additional information. And then we use the open curly brace here and the close curly brace here to define the container, to define the code that we want to be the body of this function. And everything inside of that is just any JavaScript that we want to write for the most part. All right, so how do we actually then use this? Well, we gave this block of code as defined by the open close curly brace. We gave it a name, and so we should be able to call it by its name. So I should be able to do something like this, right? Say hello. And that will get me most of the way there, but to actually invoke a function, we have to use the function invocation operator. In this case, it's the opening and close parenthesis, and obviously we want to use our end of line statement here. So let's go node and then function declaration. And let's see. Oh, declaration, sorry. There we go. All right, and we get hello. So hopefully you weren't expecting something super interesting. We're just printing out 3 lines with what I would call a flower box kind of around it, some dashes to style it up a little bit. We can do some interesting things with regards to assigning the function to a variable. So let's do let a equals say hello. Now, do I want to invoke the function here? No, and I'll explain why in a little bit. I merely want to get a reference to the function, and then I'll do a and invoke the variable. So this variable is now pointing to this function, and now I say, okay, I have a function inside of this variable, go invoke it using the function invocation operators. In fact, here, let's do it a bunch of times just to make sure that we're seeing what we think we should see here. And so we can see hello, hello, hello all 3 times in a row. Great. So let's comment that out. Now, up to now, this function's not all that interesting. Let me just copy it, and I'm going to comment it out, and I'll create a new version of this function down here beginning in line 17, and I want it to actually allow me to pass in a name so I can say hello Bob, hello Steve, right? So we'll just create a new argument into our function say hello by giving it a variable name. So essentially now we're able to use this variable name in the body, and we expect the caller to give us the name it wants us to say hello to. So here I'm just going to use some string operators here with name and make sure things are spaced nicely. And so here I can do, say hello to Bob, say hello to Beth, say hello to Mr. Tibbles, my cat. All right, and let's go ahead and run it. And you can see now how I'm able to reuse that code, but change it up by passing in the name that I wanted to say hello to. All right. So let's comment all this out, and let's talk about one more thing that we can do with functions, and that is return values from functions. So this first function that we created, it's merely just outputting. We're not expecting it to perform some operation and then give us some value back. But what if I wanted to create a more interesting function that implements some business rule in my system, in my e-commerce system, like to calculate the sales tax on a given amount, say a subtotal of all the items that are in my shopping cart. I might create a simple function called calculate tax, like so, and we'll get to the body in just a moment, but I want to allow the caller to pass in the amount that we're going to charge tax to. All right. Then I'm going to say let result, just the name of a variable result, be the amount, that value passed in, times 0.0825, which is the sales tax where I live. And then I want to use the keyword return, and then the value I want to return. So you can return one value from a function. In this case, I want to return the amount of tax. So I'm going to return result. Now what I'll do is I'm going to call calculate tax, passing in an amount. So let's say $100. And I want to capture that into a variable. I know it's going to return a value to me. So let's just do let, and I can reuse the variable word result, but I might use something more descriptive like let tax equal calculate tax, and then console.log the amount of tax, like so. Let's save that, and then let's run it. And you can see that for a $100 purchase, it would charge $8.25 in tax. Okay, but that's what the purpose of the return keyword is to actually give me back something. So this is an expression, a function invocation expression. It's going to give me a value back that I can then assign to the new variable tax. And then I can work with that value, in this case, in a number representing the amount of tax. All right, and I think that's all that I'm going to say about this for now, but there's lots to say about functions. It's going to, again, consume the majority of this course, and you're going to have to become very familiar with the ins and outs of working with functions, and we'll start that process in the next video. We'll see you there. Thanks. In the previous video, we learned how to create a function declaration. And a function declaration and a variable declaration are similar in so much that they both have an identifier or a name because we plan to call them later on in our JavaScript. But what if we don't need a name? What if we're in a situation where there's just a need for a function, but that function will never get called for the rest of the application, and we know that? Then we can take a different tact. We don't need to add a new identifier. We can just create what's called a function expression, and we don't have to supply a name. We just give it the body of the function and say, here, go do this when you need to run some code. All right, and a good use of that is whenever we need to create some code that should run in the future. So here, let me start off by creating function expressions.js, a new file, and here I want to use the setTimeout method that's available inside of JavaScript. And if we use IntelliSense, we can see that there's actually two input parameters to this function setTimeout. We're going to first of all need to give it something called a handler, which I happen to know is just a function. Now I could give it a function declaration, but usually people just create function expressions here for the handler. And then the second thing we'll need to do, and I'll use the down arrow to move from the first argument to the second argument, is to give it a timeout. And so that's the number of milliseconds that I want it to wait before executing this code. And I'll show you how that might be interesting in just a few moments here. But the first thing we need to do is create a function expression to pass in. So just here right in line, I'm going to create a function open close parentheses, open close curly braces, which denote the body of this expression I'm creating. Inside of here, I'm going to do something simple like console.log I waited 2 seconds. And then here at the very end of the function declaration, I'm going to give it that second argument, the number of milliseconds that I want to wait before executing that function expression. So I'm going to say wait 2 seconds, and then I want you to call this inline function I'm creating, and the body of it will merely just log out I waited 2 seconds. All right, so here we go. Let's go and do node and then function expressions 1000, 1000, and you can see it prints to screen I waited 2 seconds. All right. Now it's kind of hard to read it like this all in line. One of the things in JavaScript that's a little bit challenging, especially if you're getting started, is the number of curly braces that you'll encounter and differentiating, for example, this outer set of parentheses and this inner set of parentheses. And Visual Studio Code tries to help you. Like when I put my caret right next to that opening curly brace, it tries to find the matching closing curly brace. And you'll see as we add more curly braces for different purposes and indentation levels inside of our application, Visual Studio Code does a pretty good job most of the time of finding its match. It's just a matter of looking for that caret that surrounds the closing one. Here over you can see whatever in column number 61 here. I'm looking at the bottom. Okay. Anything inside is just the body of the function, and the same rules apply. Whoops, I didn't use a semicolon at the end of that line, but I should have. All right, this shouldn't change the function in this simple case, but nothing changes about how we work with this. Now, to be honest, most people do not put this much code on a single line. I may want to split this up into multiple lines. So I would do this in a way that feels natural to me. And you can see that as I put my mouse cursor next to where I feel like the split should have been, like at the beginning of console.log, and here at the end of our body of our function expression, Visual Studio Code naturally will create some indentation. Now, if I don't like that level of indentation, I'm free to come in here and to change it up. Like I would prefer to use a tab here. So I'm using the tab key on my keyboard to move things out and the shift tab to move things back. That only works if my mouse cursor is here right at the beginning of that line. If I were to move one character in and use the tab key, well, that's not what I want at all. That's going to split that word up. But if I use the keyboard, the arrows on the keyboard to maneuver, and then the shift tab to move it out, I can move things in and out. But that is pretty much how I would like to see that function represented, right? And then I use a comma to pass in a second argument, in this case the number of milliseconds, to my set timeout function. All right. So, but the focus of this is that function expression. I never want to use that function again, but I need it in this case as an argument to pass into my set timeout function. All right, so functions can take functions as input parameters. Okay, so just keep that in mind because things are going to get a lot crazier than that. And let's move on and talk about using both the function declaration and a function expression to do something just a little bit more interesting here. Same basic idea here, but what I want to do is start off with a counter. And this will count the number of times that we actually execute our function expression. I'm going to start with a function on the outside, function timeout. Let's call this function timeout, like so. And then inside, I'm going to set timeout using that built-in function to JavaScript and pass in a new function expression. All right. And then I'm going to here give set timeout, say in 2 seconds, I want you to basically run this function expression that I've defined right there. So I pass in the second argument of 2000. Again, using Visual Studio Code to help me find the matching set of parentheses at the beginning and the end to pass in the input parameter to the set timeout function, recognizing that the function expression is the first argument to that, and 2000 is the second input parameter to that set timeout function. Here's what I'm going to do now. I'm going to append, so I'm going to put a little space there between hi and the closing single quote mark, counter. But I want to, after every time I reference counter, I want to increment it by 1. So this will allow me to count the number of times that set timeout has run. Now, one of the things that I want to do is after I have printed that line, I'm going to schedule the next time that this code should run. So I'm going to schedule and call timeout in a recursive manner. So I'm using the name of this outermost function and saying, hey, now that you've run me again in 2 seconds, because I'm going to basically call set timeout again. All right. Now I need to kick this off the first time, so we'll call set timeout once here on line number 15. And that will kick things off, and then I'm going to hit Control and C on my keyboard to stop the execution because it'll just keep looping and looping and looping. All right, hopefully in your mind you understand the sequence of events here. I'm going to call this function declaration once. The body of that function will create a set timeout. In 2 seconds, I want to execute this function expression, which will not only show me the number of times that this function has been called because I'm keeping count of it in that counter variable. But then also it's going to call the timeout function again, which will schedule 2 seconds from now the next call to the set timeout function. Okay, so let's see it run. Hopefully this all makes sense. So I waited 2 seconds, saw it run once. All right, so twice, 3 times, and you see it'll just keep going every 2 seconds until I hit Control-C on my keyboard to stop its execution. All right. All right, the last thing that I want to show you now, I'm going to comment all this out, is that you can create a function declaration, or I'm sorry, a function expression that says something like console.log, and I'll make something a little bit more interesting later. And then I can immediately invoke that function by, first of all, surrounding this function expression in parentheses, just to kind of say, hey, I want to group all this together, and then using another set of parentheses as the function invocation operator, like that. Do you see that format? So there's this inner set that we use just to define input parameters. We don't need any, but we still need it in order to create a function expression. Then we're going to group this whole thing together and say I want to execute it. So there's actually, what, 4 sets of parentheses. We just have to keep them straight in our mind of what each of them are doing. But this last set will do what's called, and this kind of structure is called an immediately invoked function expression. In other words, I will have a function expression and I want it to be invoked, immediately when this application is run. And this actually is a pretty common pattern in JavaScript development. It comes in super handy, and we'll talk about why it comes in handy a little bit later. But we want to just remember immediately invoked function expression. It's also just known as an IIFE. Sometimes I think it's pronounced iffy. All right, so keep in mind iffies, and we'll come back to them a little bit later. All right, so let's move on and move away from functions just for a little bit. We'll come back to them later. But hopefully you can now tell the difference between a function declaration and a function expression. Most importantly, for our purposes, you want to keep in mind what immediately invoked function expressions are. Okay. All right, so we'll come back to this, and let's move on. See you in the next video. Thanks. In this video, we're going to talk about decision statements. There's actually 3 that we're going to consider. The if, the switch, and a ternary operator. And so whenever we need to add logic to our application, in other words, perform different blocks of code based on some condition that we evaluate, we'll want to use one of these decision statements. And so let's go ahead and start by creating a new file called decisions.js. And here what we'll do is start with the if statement. So the basic structure looks like this. If, and then we'll evaluate something here, some expression. So let me just kind of start off with this. Some expression, that expression should equal true or false, and there's lots of ways to evaluate this. We'll come back to it in just a moment. But we'll consider those in between the opening and closing parentheses. If that is true, whatever that expression is, then we'll execute all the code inside. So let's begin simple. Var count equals 3. We'll just hard code a value and then say, so if count, and then we'll use the equality operator. So this is going to evaluate for equality. If count indeed is equal to 4, then we will that expression will return true. If it's true, then we'll perform whatever code we write here. So console.log and count is 4. So the first time we run this, we're not going to get really anything. All right, so the first time we run this, we're going to not get anything. It'll just exit. What we can do is change this to count equals 3, like so. And now when we run it, we'll see the message count is 3. All right, very uninspiring. Let's set this back to 4. And here we can consider the alternative that the count is not equal to 4. And we could kind of give the counter message. Count is not 4. This much we know to be true. All right. All right, so count is not 4. We basically skipped over this block of code because this returned false. Therefore, we executed the else statement, this second block of code, and skipped over the first one. Okay. So there's actually several different variations of this we can use because there are some different conditions here. Maybe I don't want to jump right to that else statement. Maybe I want to keep evaluating. I can use an else if. And so here I might say else if the count is greater than 4, then I could maybe do a message like console.log count is greater than 4. And I can do kind of the opposite as well, else if count is less than 4. So console.log count is less than 4. I guess I changed modalities there. And then at that point, this will never happen ever because one of these three conditions would occur. We'd never get to this final else statement, right? It would never happen. So let's go and save our work here and see this run. Count is less than 4 because it's 3. Okay. So that's the general structure of the if statement. It allows us to evaluate one or more expressions. If that expression returns a true, then we execute the code in the code block associated with that expression. We can create optional else or else if statements to continue to evaluate other expressions. Usually you'll want to make related ones, but you don't necessarily have to, although that may not make a whole lot of sense, depending on your business rules. And then we can finally use a catch-all in case none of the previous else-if statements are correct, and kind of capture that. So let's go ahead and comment that out. That's our first structure, and we'll use the if statement a lot. The next type of statement is a switch. It's a little bit more tricky to use. Let's start off with just typing out the switch keyword and what we want to evaluate. And so what we'll do is actually evaluate whatever's in this expression against a number of cases. So I might, for example, let hero equal Superman. And then depending on the hero, I might want to print out the superpowers that that particular hero has. So based on the hero, if that hero, so if the case is Superman, I would say, well, that hero has console.log super strength. May also have X-ray vision. All right, let's add another case here and say case Batman. And notice that kind of the format of this is to use the case keyword inside of this block that belongs to the switch. The case keyword, the value we want to compare our case against, and then a semicolon, and everything beneath that will become part of the body of that case that gets executed. So in this case, we'll say, what are Batman's superpowers? He has intelligence, and he has fighting skills. All right, and then we can also then say, well, the default for that hero is that they're a member of the JLA. Now watch how this works. It works a little bit different than the if and else if. So let's go ahead and say what we have and then rerun this. All right, so in this case, it was Superman. And notice that we matched the case Superman because it prints out super strength and X-ray vision. But then everything else inside of all additional cases, including the default case, will be true as well. So he also is intelligent, he has fighting skills, and he's a member of the JLA. Now if we were to change this to, let's say, Batman, and we were to run the application, you'll notice that it skips over all of the console log statements that describe Superman's superpowers, and they come in, however, here at Batman. So console log intelligence and fighting skills, and he's also a member of JLA. Now we could try somebody like a Green Arrow, not particularly one of my favorite heroes, and he's just a member of the JLA. All right, now if we don't want that flow through style, what we can do is actually use a break statement in here. So let's go back through this now and see what happens whenever we break out of a given case. So back to Superman, and now when we run it, we only see that he has super strength and X-ray vision. Batman has intelligent fighting skills, and then Green Arrow is just a member of the JLA. Okay. All right, one other quick tip here is that whenever you're evaluating strings, there's a possibility, like for example, Batman. What if we had capital B in Batman, all right, and then we run the application, and you see he's a member of the JLA. Why didn't it catch the case Batman? Because capital B Batman is not the same as lowercase b Batman in that string. Now, what we can do to circumvent that, whenever we're working with strings and we want to do some comparison with them, we can use the toLowercase method of our strings. So strings have a built-in method called toLowercase, and that will take whatever that input is, and it will make sure that all the letters are lowercase so that we're really comparing apples to apples instead of apples to oranges. So now when we rerun the application, we get what we would expect with Batman. Okay? All right, so let me comment this out. We've looked at the if statement, we've looked at the switch, and then the third one we're going to look at is the ternary operator. And this is useful whenever I want to just do a quick inline evaluation of some expression and then return back a value, a string, number, boolean, whatever, probably just a string or a number, back, depending on whether that expression evaluates a true or false. Very small, short, concise, inline statement. So I'm going to create two variables. I'm going to do something a little bit different though. The first variable I'll create like you would normally expect, but instead of ending that line and moving to the next one, I'm going to do another variable creation, variable declaration, and assignment right here in the same line. So I'm going to create another variable called b and initialize its value to the string 1. All right. So just a slightly different technique. You might see that online. Moving on. So we're going to create another variable called result, and we'll set that equal to some evaluation of an expression. Does A equal B? So two equal signs that are next to each other is the equality operator. This is a check for equality to say, does A equal B? And if that is true, then what we'll do is return the word equal as a string. But if it's not true, notice the colon that separates the true from the false, we'll return the word unequal. So the ternary operator has kind of got several parts here. There's an expression, there's a question mark that has true or false ramifications, and we'll just do a console.log and the result, like so. So now let's go ahead and run that, and these are equal. Great. We could also do this in line. So let me just take this part right here and do that instead. And you can see how we can basically perform that same check without having to create a new variable to hold the result. All right, so it's a nice inline way of running a quick check and then returning back a string, one string or another string. Now, let me just go back for a second here, or actually, let's do this. And then we'll do console.log result. Okay, let me comment this one out. I want to keep it around for you in case you want to reference that in the future. We used two equal signs, but there's another type of equality that we can check for, and that's strict equality. And this will check to make sure that these two values are equal, but then in addition to that, it will not coerce, for example, the number one and the string one. It'll say, are these absolutely equal, even with the same data types? All right. And so in this particular case, we should expect a different result. These are unequal. They are not the same. All right. So these are the same because I'm looking for equality. But if I'm looking at strict equality and I'm not allowing JavaScript to coerce the integer into a string and then check for equality, then I have to say, no, these are not the same because one is a number and one's a string. All right. All right. So let me comment that out and let's do one more check here. In this case, I'm going to use a different operator, the not equal to operator. So I'll just use the word not unequal and not equal and not unequal. All right. Which would be the same as saying equal. All right. So now let's see and run that. And this produces a false, so this would be returned back and then displayed on screen. But then we can also do strict inequality by adding another equal sign to that operator. And these are not equal again because it is true that A is not strictly equal to B because they're different data types. All right, hopefully that makes sense. All right, so let's go ahead and stop there. And hopefully all of this ternary operator business and equality and strict equality makes sense. And let's move on. You're doing great. We'll see you in the next video. Thanks. In this video, we'll talk about iteration statements. Iterations allow us to loop through a body of code, a block of code, a number of times until a certain condition is met. And there's a couple of different types of iteration statements. We'll look at two in this lesson, and we'll even look at them in relationship to arrays, something I promised several lessons ago. So let's start off by creating a new file and call it iterations.js. And inside of here, we'll create our first for loop. So for, and then there are three parts inside of the opening and closing parentheses. First of all, we'll let I equals 0, or we can actually just shorthand this and not even use the keyword let. And here I less than 10, I plus plus. And so this is going to take some explanation, but let's just get this working first and then I'll come back and I'll talk about it. And we'll just print out the value of I. All right. What do you think is going to happen here? If I didn't tell you anything about how the for loop actually works, what do you think will be printed to screen when we execute our script? Let's find out. So let's go here and type in node iterations. All right. So we get several, it looks like 10 different values printed to screen, each on a separate line, 0 through 9. And then our application exits. All right, so let's talk about this. It's a shorthand syntax, and there's three parts as separated by these two semicolons inside of this this evaluation header for the for. First of all, we declare a variable. In this case, I've declared I. That's why we use the let, but then I said, well, we really don't need it. Let's keep it short. So we're declaring it, and then we're going to initialize its value to 0. In the second step, we're going to say continue running this for loop as long as this condition is true. So as long as I is less than 10, continue running the body of this for loop as defined with this a set of curly braces here. And then finally, after you've run an iteration, increment the value of I by 1. All right. And here we're going to then print out the value. And that's why we start at the value of 0. And then we work our way all the way through this 10 times. On the 10th time, I gets incremented to 10. This check is performed. It's false. And then we exit out of the program. All right. Now, let's do something a little bit more interesting like I suggested before. Let me comment this out. Here, let's go let A equal to, and this should look familiar, 4, 8, 15, 16, 23, and 42. Whoops, I guess I forgot equal sign there. And now what we'll do is for I equals 0, I is less than A dot length I plus plus. Inside the body of this, we'll do console.log A, and what element? Well, we'll use I, because I will start off with the value of 0, and it will continue until we get to the length property, which is not 0 based. Once we get to, for example, the 0, 1, 2, 3, 4, 5, so length will be 6 elements. So once I is 6, it's no longer true that I is less than the length of this array, and we'll exit out. So let's go ahead and save this and then run. And we can see we get all of our values printed out to screen. So that's the proper way to iterate through, or one way I should say, to iterate through an array. Now, one thing about Visual Studio Code that I really love is that they have this notion of code snippets. So if you ever forget this syntax, and it can be a little daunting at first, there's a way to remember it perfectly every time, and that is to let the code snippets build it for you. So I type in the for keyword, IntelliSense pops up with a little window under it, and I'll use the arrow keys to go to the for loop JavaScript. All right, there's a couple of fors, but the one that we want has this little box with dots underneath of it. That tells me that this is a code snippet. I hit enter on my keyboard, and now I get the basic structure of my for loop already created for the purpose of an array. Now notice that every word index is highlighted, and I can change that every instance of that by just using a letter. Like I'm going to change this to the letter B instead of index, and notice that it changed it everywhere. And then I'm going to hit the enter key on my keyboard, which was the wrong move. Then I'm going to hit the tab key on my keyboard, and I can change the name of the array now. Everywhere the word array is used, I can swap that out with the letter A, for example. I'll use the tab key one more time. Here it puts me to another replaceable area for the element, and here I'll use C. I'll use tab one more time, and then it kind of exits me out of that snippet replacement structure, and now I can continue on and type like console.log, and we'll just print out C. Okay. So let's grab A from our previous example, and then we get the same results as we got before, but this time we didn't have to memorize exactly how to use for. The code snippet walked us through and allowed us to replace the names of the various replaceable areas, like the name of the counter, the name of the array, and the name of the given element C that we extract out of our array. Okay, so let's comment that out. That's for, and now let's take a look at the while loop. So we'll talk about the difference between these. It may not be obvious at first, but essentially we'll do this. All right, so take a look at this. Knowing what you know about loops, what do you think is going to happen here? Well, we start off with 1, and we're going to continue to execute this loop until this condition is false. So the very first time we run it, 1 is indeed less than 10. So we'll continue to run the body, the block that's associated with our while statement, and we'll print out the value of x and then increment its value by 1. We'll continue to do this until we increment the value of x and it becomes 10, at which point this is no longer true, it becomes false, and then we'll break out and continue on. So let's go ahead and see what the value is that we get. So we get 1 through 9, that's expected, and once we hit 10, we break out. Great. All right, so what's the difference between the while statement and this first for loop that we did here at the very top? Well, the difference is that the for loop, first of all, has a lot of infrastructure that we have to build, these 3 pieces. And it uses a series of indexes that represent the number of iterations that will move through this block of code. Now, the while statement is a little bit different. Anything can be used to drive the iterations. As long as this statement continues to be true, we'll continue to execute this block of code. And so we control the number of iterations in the body. In this case, here I do the x++. Now we don't have to use counters. We could use anything, any kind of business logic, like we may want to read to the end of a file, and once we hit the end of the file, it makes sense to continue to read each line of the file, then we would want to break out. So the while is a little bit more flexible in so much that we can build the business logic for how many times we're going to iterate in the body of the while statement. Whereas with the for, we're pretty much limited to the number of times we want to run this being the number of times that we've kind of preset it up here in this top section outside the body itself. Okay. Now there's also one last thing we can talk about, and that's a way in both the for and the while we can kind of circumvent this check right here, and we may want to do a check like this. So if x is equal to 7, then we'll call the break statement. All right, so learning what we've learned about the if statement, it probably should look more like that. All right, so let's make sure it works. All right, in this case, we got 1, 2, 3, 4, 5, 6. Once we reach the 7, we circumvent this check and just say, hey, I want to break out of this. All right, so we can use that always to break out, just like we broke out of the switch when we wanted to not let it flow through additional cases. Now, the one thing I will say, if you notice how I typed this to begin with, let's retype that. So hold on, let me comment this out so that you can see it in the code if you want to download my code. But we could also do it a little bit more shorter and in line. Since I only have one statement that I want to make right after the if statement, I can do it on the same line, and I don't need to surround it with a code block. A code block indicates that there's usually more than one line of code. In this case, there's just one line of code. I could put it on the separate line and use some indentation like that, or I can just keep it all on the same line since it's so short. But that might improve readability, or I might decide that this is a more readable form. That's kind of up to me, and if I'm working on with a team of software developers, I might want to get and kind of do it the way that they do it. But stylistic for me, this is so short, I can read it all in one shot. If X is 7, then break out of it. It looks good. It's very readable. I'll be able to understand what I'm doing later on. It doesn't take up and move the code down. So I like that format if I just need to create one statement right after my if. So sometimes it makes sense to split things on separate lines. Sometimes it makes sense to keep two different statements on the same line. Again, I think it kind of is a stylistic choice that you'll have to make for yourself at some point. All right, so that is iteration statements. We looked at two different kinds, and we looked at how code snippets can be used to help us remember the format. Now, I believe the while has, in fact, I believe most of the things that we've looked at has some code snippets available to them. Like if I find it here in IntelliSense, I hit enter on the keyboard, but there's not as much to it there. I mean, while with the condition, I can change this to X is less than 10, right? It's not so much for me to type that out, but the for makes a little bit more sense because there's so many parts to it and replaceable parts of that. Okay, so let's continue on in the next video. We'll see you there. Thanks. It seems like quite a while ago we talked about variables, but now that we're working with blocks of code inside of blocks of code like we had here in lines number 23 and then 29 through 31, we need to talk about variable scope. And when I use the term scope, I mean variables are a little bit like people, in so much that variables have a lifespan. They're born, they do work, and then they die, and they're removed from computer's memory when they go out of scope. And we'll see an example of that in just a moment. But they're also like people in so much that they have a citizenship, I guess you can say. In other words, depending on where they were born, they can work inside of some code blocks, but not other code blocks. And so the remainder of this video, we're going to look at lifetime and availability, or citizenship, I guess you can say, inside of the rest of your application. So let me create a new file, and we're going to call this scope basics. And there will be more to say about scope as we move forward and learn more about functions and so on in just a little while here. But let's start and create a first example here. So let a equals first. Then I'm going to create a function called scope test. And inside here, I'll just do a console.log. And the first thing I want to see is if I declare a variable out here, outside of my function, can I reference it inside of my function? And so to find out, let's just call scope test and see what we get. So here we're going to type node scope basics, and we can in fact view the value of a variable that was declared outside of the scope of a function. We can view it inside of the scope of that function. All right. So the next thing that I want to do is to say, hey, let's create a variable here. Now, if I create a variable inside of a function scope, can I view it out here outside of the function scope? So console.log b. And let's see. And so no, not only can I not see it, but my application actually blows up. And you can see the little caret here is right underneath the B, and it says B is not defined. So in other words, you can kind of think of it again in terms of the lifespan. We created a function and we created a variable inside of that function. That variable lives as long as that function is running, but after the function, after that code block has completed executing, then B is removed from the computer's memory and essentially thrown away. Therefore, we cannot reference that variable outside of the function because it no longer lives. It's dead. All right. So we're going to have to comment that out, and we can go ahead and comment this out as well. Now, let's do one more thing here. Let's say if A, and we'll just do something silly here. If it's not equal to an empty string, so just two single quote marks next to each other, so then can we still see the value of A even inside this innermost block of code that we defined with an if statement? If we can, we should see then it printed here a second time the value first. So let's save what we have. Let's run this again. And so we see first. The first time it's printed out and the second time that is printed out. All right. So yes, if something is declared in an outside scope, it is visible, or it has citizenship in every inner scope from that point on. But here once again, if we were to create a variable third and then try to reference it outside of the code block in which it was defined, like so, will this work? What do you think? We're going to get that same kind of error before. We get the little arrow pointing to the C, and it says that C is not defined. The variable C was defined inside of this code block, and once we executed that code block and got to the end of it, then C was removed from the computer's memory. It's no longer available to us. In a sense, dies, and it's no longer available. Okay? Now, let's just do one last thing here just to kind of understand that we are, in fact, able to work with the variable that was defined in the outermost scope. Can we still work with it, do it, use it, and change its value? So I'm going to change this to changed. And then I'm going to reference it here, console.log A. And so now let's run our application one more time. All right. So the first time that it's run, this first console.log, it will be the value first. But then we change the value and we log it again, and that's where the second changed comes from. After we've executed that function, then we execute line 20, and that's where this third changed appears. All right. So I guess the moral of the story, once again, to kind of reiterate what we said, when you declare a variable, you have to understand in which scope it was defined, because based on the scope, or rather the code block in which that variable is defined, it's going to have a lifespan and it's going to have citizenship. If it was defined in the outermost scope, it will have its life and its citizenship in all inner scopes. But if it's defined in an innermost scope, it will not be available to outer scopes. Now, one last thing, and I'll kind of end it right here. If we were to take, and this is probably just a question for you, just thought question. If I define B here, right above that if statement, and then I attempt to use it right here, and call this inside if, do you think that we'll be able to reference that value? Well, based on what we know about the rules, I would expect to see the value second printed out. So let's try it. And in fact, we do see it. So hopefully that supports your new understanding of the scope of variables, defining them outside of a code block versus defining them inside of a code block and trying to reference them outside. Okay? So hopefully that all makes sense. We want to make sure you're clear on that. We're going to revisit the topic of scope because there's a lot more to this, but this is your first introduction so that you kind of understand what the rules of scope are, at least in the most basic sense. All right, so we'll continue on the next video. See you there. Thanks. Scope is a topic that we'll keep coming back to over and over throughout this course. It's important because at least when your JavaScript is run inside of a web browser, you must be aware of the topmost level of scope, which is referred to as global scope. In Node, like we're using here, it's not as much of an issue. They've got some safeguards against it. But in web development, working against the global scope is a crucial concern. A lot of consternation and consequently a lot of effort has been exerted to preach that declaring variables at the global scope is a bad idea. So you would never want to do something, let me create a new file here. Returning functions.js. There we go. You never want to do something like this. Note the use of the var keyword. And you never want to do something like this. Although you're more likely to do it than the previous line in line number 1. Now, the reasons why you would never want to do this will require a little bit more explanation a little bit down the road. And I'll make this point emphatically when we start writing JavaScript for the web browser later on in this course. But for now, just understand that much of what I'll say and why I say it over the course of the next 5 or 6 lessons or so will be working towards a solution to avoid writing your code in the global scope if at all possible. Now, the eventual solution that I want to demonstrate relies on how JavaScript functions work. But we need to take a few baby steps to get there. So the first aspect of this technique that I want to demonstrate has to do with returning a function from a function. Now, up until now, our functions performed one or more actions and then exited quietly. We may have returned a simple value like true or high or something along those lines. However, we can create functions that can not only perform some action, but then at the very end can return a value to the caller, and not just any value, can return a function. So let me comment all this stuff out, and I'll say, don't do this to make sure you never do that, and this either. And then I'll just do a multi-line comment here. And so let's start off really simple. This is something that we've already talked about when we talked about declaring functions or function declarations. So here's function 1, and inside of function 1, we can just return the string 1, right? It's not very exciting, but it demonstrates the point that you can use the return keyword to return a value to whichever calls that. So for example, let value equals 1, for example. And what would we expect to be in our variable value? Well, we would expect to print out the string ONE or 1. So console.log and value, like so. And just to see this working, let's go ahead, say node, and then returning functions. And we see it returns here at the bottom of our screen the string 1 as we'd hoped. Now we could also kind of paraphrase this, make this a little simpler by just doing it all in one line, right? So we could put the call to the function and not use a variable. We could just make the call to the function, which returns a string, and that returned value will automatically be passed into the console.log method. Let's save that. Hopefully that makes sense. And that's a common technique that we'll want to use. But things start to get a little bit more mind-bending when you start to think of a function as just another data type in JavaScript. So, for example, let's go back to this. I'm going to copy this again. And then let's go console.log and then type of value. All right. And well, let's do this. Let's get rid of the method invocation operator. So now we're just setting a reference called value to our function 1. Let's see what we get. And you can see the type is function. So let's think about all the data types we know about now. We know about string, we know about number, we know about Boolean, we know about undefined, and we know about function, right? And we're going to learn a couple more before this is all said and done. But at any rate, notice here again, in fact, we could even do this a little bit differently. I may have muddied the waters by introducing a variable. Let's just do that instead. And we should get the same result. All right. So I guess the heart of the matter here is that we can get a reference to a function, and we can store that reference to the function out in a variable, which means we could also do something like this. So now we have a reference to the function. We can call the function using the method invocation or the function invocation operator. So let's go ahead and run it. Whoops. I guess we need to actually then go console.log. There we go. Now we're getting somewhere. There we go. Okay. So hopefully that makes sense. I just have a variable pointing to the function, and then now that I have a variable pointing to the function, I can execute the function by just using that variable with our method invocation operator, right? All right. Hopefully you're still with me so far. Hopefully this isn't too mind-bending. Let's continue on here. So since a function is just a data type like any other data type that we've learned about so far, our functions could return a function because we're just returning a value, right? And that value can be any type. So in other words, let's do this. Function2. And here we're going to do return a function. Now this is a function expression inside of a function declaration, right? And here console.log and 2, like so. And then do something like let my function equal 2. Now what gets returned to my function? It'll be this inner function expression. So I should be able to do something like my function with the method invocation operators. And let's see what we get. And we get the value 2 like we'd hoped. All right. So hopefully you can see here we're using the return keyword to return a function expression. We get a reference to that function expression by calling the outer function declaration. Now we have a function in hand, or reference to that function, this inner function right here, and we merely invoke it. Hopefully all that makes sense. And we might be able to do this a little bit differently. Let's try just a slightly different tact. So here I'm going to go function 3, and here I'm going to return function and then return 3. All right. Oops, let me spell return correctly. All right, so in this case, I'm returning a function that returns a string. So I should be able to do something like console.log, and then I'm going to call 3. What do I get back from that? I should get back a function. So I should be able to invoke that function to get back the string to give to the console.log. Now you would never do this and you would never see this, but this is just to illustrate a point that of what you're really working with, and that's references. Whoops, let's actually execute it. There we go, 3. What you're working with here are references to functions that can return references to other things and maybe even other functions, right? So again, that last one's pretty far-fetched. You probably never do that. But the fact is that what gets returned from our 3 function declaration is a function, and then it can be invoked with the function invocation operator here, the second set of inner parentheses right there. All right. So on the surface, this might not seem like a very significant development in our JavaScript journey, but nothing actually could be further from the truth, because this is actually a huge step towards moving our code out of the global namespace like I talked about at the beginning of this video. But to complete the story, again, we have several more baby steps to go. We're going to need to step away from functions for a little bit and come back to them once we've learned a little bit more about arrays and objects specifically. All right, so just keep this thought in mind and we'll continue on. You're doing great. Hang in there. We'll see you in the next video. Thanks. If you remember, when we were looking at arrays, I did the type of on an array, and it returned back the word object. So that's actually another data type in JavaScript that we haven't looked at until now. Obviously, given the title of this lesson, we're going to look at objects. So an object is similar to an array in some ways, but its intent is dramatically different. An array will hold a list of information. In other words, there may be many data items, whether they're strings or numbers or booleans or even objects, each stored in a different element of the array. Contrast that to how an object works. An object contains the related properties of a single data element. So array, many data elements. An object, one data element but has attributes. So the settings of the properties define the characteristics of the object. So let's say, for example, that you want to have a car. And so an array will only really let you save maybe the year of the car or the make of the car or the model of the car as a string or maybe some identifying number. But an object would allow us to define all of those properties kind of in the same container. So, you know, if you try to keep track of all the properties and maybe even all the methods that belong to a car, but you keep them as separate variables and separate functions, you'd run the risk of clashing with other variables and functions that have the same name for a different car. Okay, but objects let us keep that information kind of safely locked away in their own little container where the relationship between all those properties and functions are obvious, that they all kind of belong together to describe one car. And then you might have another object that describes a different car. And you can keep both of those objects, those two cars, in an array of cars. So hopefully you can see the relationship between those. All right. So let me first of all start out by creating a new file, object.js. And so, you know, I may have an object that has a series of properties that describe a specific car, and I might want to, for example, keep track of the make, the model, and the year, and so on. And I may have some functions that I need as well, things like getting the price of the car based on some criteria, maybe, you know, the year of the car and things of that nature. And I may want to print out a special description of the car that includes many things like the make, the model, the year in a special format. But I might define a car object like so. So let's do let car equals, and then we define an object using a code block, so curly braces. Now I'm going to use kind of a name value pair here, so let me just go ahead and start typing. All right, take a second and catch up with me there if you like. Now let's go ahead and use the print description function like so. And let's use the year property like so. I'm going to save my work and then I'm going to type in node object or object. And the first printout is BMW 745Li because we're printing out the make and the model of this car. All right. And then here I'm just getting the year of the car and printing that out in a console window. All right. So in this case, this object that I've built on screen, we're dealing with a tangible, real world and very relatable concept. That of a car. We've all driven in cars or have driven cars. In your JavaScript code, you'll occasionally be working with objects that define tangible real-world things like cars, but you're also going to work with things that represent more abstract concepts that are specific to web client or web server development. So in this sample, I created an object using what's called object literal syntax. So I literally want to create this object, and then I'm going to assign that object to a variable named car. And the body of the object is, like I pointed out, defined with a series of curly braces. Here, this set of curly braces at the outermost level here, this defines kind of the boundaries for the object, and everything that lives inside of it is either a property of that object or a function called a method inside of that object. So let's start off in lines 3, 4, and 5. Here we have a list of name value pairs. So here's the name of the property and here's the value of the property. In this case, notice that each of the names of the properties are just identifiers. They're just like variables. In fact, you'll probably want to use the same naming conventions that you would use with a variable. And then the values can be any data type. In this case, I have a literal string BMW, a literal string 745Li, and a literal number 2010 that represents the year. All right. And notice that the property and the value are separated by the colon character. All right. And then each Property definition as well as each function up until the last one are separated by commas. Now I put each of these properties and functions on their own line or series of lines, as it might be for the functions, in order so that we could see some readability, but that's not entirely necessary from JavaScript's perspective. It would be fine if we put all this on one line of code. All right. So again, with regards to the names of both properties and these functions, which I call methods, you'll want to use the same naming conventions that we used previously when we talked about variables. Now there's some other ways to create objects, and I'll discuss another technique in one of the upcoming lessons. So we'll come back to that notion because it'll lead into another discussion that kind of takes us off at a whole other tangent that I don't want to go on right now. So here we define the function, kind of the same notion. I gave it an identifier, the name of the function that I want to access, and then I'm using a function expression and define the function expression within several lines here, but essentially we're just returning a value, or in the case of the second one, just calling console.log. But we could write any number of lines of code inside of here. These are just happen to be very simple for the purpose of illustration. All right, so I've defined my object. Now I want to actually use it and reference it. How do I do that? Well, you can see that whenever I wanted to access a specific property of my object, or when I wanted to access a function, I use the variable name that I set the object reference to, and then I use the period on the keyboard, which I call the property access operator, just the dot on the keyboard. Same is true when accessing a function. As you can see here in line number 15, I use that period, that member access operator. And then, you know, all else is fair. This is a function, so I'm going to use the method invocation operator, just like I would to invoke a normal function. Now, I keep referring to these functions that are inside of an object as a method, and I think you should probably start referring to functions defined inside of objects as methods. It's a more descriptive term, and I'm already used to it from my work with other programming languages, but simply put, a method is a function that belongs to, or rather is defined inside of, an object. Now, there's another syntax that I could use in addition to what you see here, and it opens up some interesting possibilities that, frankly, I'm not very fond of. But you could definitely do something like this. So it almost looks like I'm using the array element accessor to access a specific property here. Let me go ahead and save that, so we'll see the year appear twice here if all goes well, and we do at the bottom. So that's one approach to accessing an individual property. And the other is similar, but it uses an index. So it's actually kind of interesting how this works. What is the index 1 of my car? Let's find out the hard way here. And it's set to undefined in this case. So actually it doesn't reference any of these. It basically creates its own new property and sets its value to undefined. Let's never do that. Let's not do that. I prefer the dot syntax. Again, it's going to be most familiar to those of us coming from other programming languages. But you could, in some advanced scenarios, use these techniques to do something a little more advanced, and that's way beyond the scope of this lesson. All right, so I'd recommend you just use that dot notation for now, and all will be happy. So you can do, like I kind of mentioned a second ago, some pretty advanced things with objects, and there's a lot of room for variation. So I'd recommend taking a look and taking notice of how other people work with objects in their JavaScript code as you're perusing the internet, because there's always seems to be a new twist. I think I understand how objects work, and then I'll see somebody do something really extreme and interesting, and I'm like, wow, that opens up my understanding a little bit more to how objects work. I'll just give you a quick example of what I'm talking about here. Here we can create another car, and I can create an empty object like so. And then I don't have any properties inside of my another car. How do I reference another properties of inside of that? Well, what I can do is just kind of just say, hey, I want to create a property here called whatever, and I'll set it equal to Bob. All right, and it'll just automatically create a property called whatever and set its value equal to Bob, just like that. No let or var keyword or anything. If I do console.log, you'll see that car.whatever, in fact, will come out to be Bob. Or I thought it would. Oh, I think what I'm going to need to do is save my work here and then try this again. Whoops. Oh, I'm sorry. Another car. I had the wrong reference. It didn't exist on car, but we need to look at another car dot whatever. And there we go. There's Bob. Okay. So just an interesting feature of objects. You can add properties kind of ad hoc, and some people do that, and that is kind of a feature, not really a bug of JavaScript. It's dynamically typed. You can just say, hey, I need a property here, I need a function here, and you attach it to an existing object, and there it is. You've got an object now with this additional property called whatever. All right. You can also do some other kind of interesting things. Might as well take a few moments and look at these. So I'm feeling unoriginal now. So I'm going to create a new object called A, and inside of this I'm going to create my property, and I'm going to actually set that to another object. I'll define a property inside of that, and I'll just say hi, because again I'm feeling rather unoriginal. And so let's figure out how can we actually print out the A. So console.log a.myProperty.b. Will I get what I think I'll get? I will. So you can see how I can chain things together, whether they be functions or properties, by just continuing to use, this is an object that has a property that has an object that has a property. And so I can kind of chain through and create essentially what becomes a namespace. And we'll reference that a little bit later when we talk about solving the global namespace issue, or putting our variables at the global level of our applications, which we're trying to avoid. All right. Let's take a look at another quick, cool example of things you can do with objects that might not be so obvious at first glance. So here I'll create var c, and inside of that I'm going to create another myProperty. And this time I want to create an array. So this property, the value of my property now will be an array of, I could do strings, I could do numbers, but I could do an array of objects. So and that's perfectly valid. So here, think with me again. I have an object that has a property that contains an array of objects that each have different properties. All right, and that's perfectly valid. So objects can contain properties of the type array, that can contain other objects that can contain, well, really just whatever makes sense for your application, however you need to store it and kind of represent the data that you're working with. Also, if you're going to work with an array of objects, it might make sense for all of them to have the same set of properties. Like in this case, each object has a different property. I'm not so sure that would be so useful, but it might be something that you need to model in your application. There's nothing forcing you to keep the same set of properties for any given object inside of an array of that object. As long as your JavaScript code or whatever will consume this object understands how to interpret it, that's all that matters. So once you get past a simple hierarchy of values, you typically refer to something like this that gets a little more complicated as an object graph, a graph of objects. All right, just keep that in mind. Let me paste in some more interesting examples here. Just kind of expand your thought process on how work with objects. Let's say I have a car lot and I want to store an array of objects. Each object has year, make, and model. All right. Then I could iterate through the car lot and print to screen each of those individual car objects, right? So that's one example. How about, you know, if this was more of a I guess you could say, a system that kept track of all of our customers and employees, we might do something like this. This gets a little more complicated and unfortunately runs off the side of the screen a little bit. But you can see here I'm creating a contacts object. Here's the start and the end. And inside of that I have a property called customers and a property called employees. Now both of these have, as you can see, an array of objects. And these objects look very similar in so much that they have a first name, last name, and then phone numbers. And then phone numbers actually is an array of strings. In this case, this particular, what is he, a customer? This customer, Bob Tabor, has 2 phone numbers. Richard Boughton has 2 phone numbers. And then, but our employees like Steve and Conrad and Grant, well, Steve has 2 phone numbers, but Conrad and Grant only have 1 phone number. All right, so you can see that things can get pretty crazy really quick. But that's a perfectly valid object initializer. It just happens to be a little bit more complex than the ones that we started off with. So now as you're looking at this, you might think to yourself, wow, this actually looks similar. Where have I seen this before? It looks a lot like JSON. Have you heard of JSON, J-S-O-N, or JSON? I guess some people put the emphasis on the on. It's short for JavaScript Object Notation. JSON is both descriptive and compact, and it's probably the most popular way to send information between 2 disparate systems. So we might, in fact, use it to store settings or properties inside of you know, a more advanced JavaScript application, or they use it in Visual Studio and C# projects to store application settings, for example, now in the new version of C# and .NET. We might use it in our application sooner than later to send data between a single page application that lives on the client and the backing web API that on a web server that hosts a web API. If none of that made sense, don't worry about it. Eventually you'll get to that point if you continue on learning JavaScript. All right, so what was my point here? Well, if you're familiar with what JSON is, you might notice that there are a lot of similarities between the object literals that we've looked at in this video and JSON. However, there are some subtle but important differences between the two, and I'm not going to take the time to go through that. You can easily do a quick search online to see what the differences are between object literals in JavaScript and the JavaScript Object Notation, or JSON. Just be aware that these are not one in the same. There are subtle differences. You cannot use them interchangeably, but their syntax is very, very similar. And JavaScript has a built-in function that'll let you work with JSON, as you might expect. Okay. Wow, I've really gone long on this one, but objects are pretty important and we're going to use them a lot, and there's a lot to them. In fact, we're probably going to be talking about them a couple more times before the end of this course, maybe even in the very next video. So you're doing great. Hang in there. We'll see you in the next video. Thanks. Previously, I said that much effort and education is centered around the dangers of defining variables and functions in the global scope, also referred to as the global namespace, especially when writing JavaScript that will ultimately be targeted at running in a web browser. But I never really answered the question, why is it dangerous? I never kind of ventured into that. And I'm going to illustrate more clearly later on why this is dangerous and how you can really hurt yourself when you are creating variables and functions in the global scope. But in a nutshell, the global scope is global. So number one, each variable that you define in the global scope is not removed from the computer's memory until the web browser, or the tab of the web browser, navigates to a new web page. So the more that you add into that global scope, the more memory you're taking up, and that memory just is consumed the entire time that that tab is open for that particular web page. But more importantly, number two, again, emphasizing that this is the case with JavaScript in the web browser, not so much true whenever you're building these node style applications. As you load JavaScript that you wrote and you rely on JavaScript code that others write, whether that be code that JavaScript libraries that you've downloaded from the internet or that you include in your project somehow. Maybe they're ones that other people in your company have written and you need to include them in your project, or perhaps even sold commercially online. Some product that you purchased came with a JavaScript file and you include it. Maybe it hasn't been updated in a number of years. The variables and the functions that are defined in those files, when you consider the variables and the functions that you've written in your files, the more that you write at the global scope, the more that they wrote at the global scope. If they didn't take precaution, the more likely you're going to have a collision of names. At some point, somewhere down the road, somebody's going to have a variable named what you named, and they're both trying to contend for for being the variable, the winner in the global scope. So we call these naming collisions. And when these naming collisions happen, either your data will get overwritten by their code or their data will be overwritten by your code. But either way, undoubtedly, it'll cause unanticipated bugs that are difficult to track down and quite frustrating. And the reason why this is even a thing is because it's happened. Okay, so now that it's happened, everybody is extremely concerned about it. And so a series of suggestions came out, and a lot of effort went, again, around trying to figure out how to solve this issue, given the tools in JavaScript that they had available. And the first one that has come out and that I've recommended from the very first lines of code that we've written is to use the let keyword instead of the var keyword, because the var keyword will attach variables to the global scope, which in a web browser is the window object in the document object model. We'll talk about that a little bit later. It's also recommended that you use the technique, the design pattern that we're going to discuss in this video whenever you're writing JavaScript code. Or there's a third option too, which is new in JavaScript, in the latest version of JavaScript, called modules. Unfortunately, and I may even talk about this at more length later on, the implementation of modules is a little bit uneven between Node and the web browsing environment. So I'm not sure how helpful that would be, at least as we're getting started and learning about JavaScript. Just keep in mind that there's several different attacks, but this is probably the one that you'll see used most often in at least JavaScript that's been written over the course of the last 5 to 10 years. But there are some newer ways to tackle this. All right. So, at any rate, the technique that I'm going to discuss in this video, or the design pattern, actually uses a couple of techniques that we've learned about so far. We're going to use an IFI. Remember what that is? An immediately invoked function expression to create a function, and then that function will return an object, and that object will have defined functions and variables that will then be kind of scoped to one variable. So instead of having 5 or 10 variables, we'll have only one variable in the global scope, or at least in some scope, and then we'll be able to reference the individual variables and variables and functions of that particular object that gets returned. All right, so we'll see how variables and functions can be made essentially private, so that we can hide some implementations from the ability for just any code to call them. This is often called encapsulation in software development terms. And so these will be unavailable outside of the public variables and the public functions that we return, and that's generally a good thing. So there will be a couple of benefits that come out of this. All right, so let's get started by creating a new file called module pattern.js. All right, so let's start by creating an IFI. And to do that, hopefully you remember how to do that. We're going to start with a function expression. We'll just create an empty one to start off with. We wrap it in a set of parentheses, and then we use another set of parentheses to actually invoke it. All right. So what I'm going to do before we get any further is actually set this immediately invoked function expression to a variable. I'm going to call this counter. So I'll set counter equal to whatever is returned. So eventually what we're going to do here is return an object full of properties, properties that have values, properties that point to functions that can be called. But we can also do some private stuff here. And this will not be accessible outside of the calling the counter dot something to access it. And so we can like have a private variable here, like let count equals 0, and we would not be able to do counter.count. It just wouldn't be accessible. We'll fix that here in a moment when we return an object. We'll give an accessor to it. We'll take a couple of passes at that actually. Okay, so let's go and create now a private function as well, and this will just print out a message and style it up a little bit differently, so we won't get crazy here. So console.log, and we'll just say whatever the message is, and then we'll just do like 3 dashes like that. Just a little bit of style, just to show that, you know, we have something here that could be private. But now, ultimately, what we want to do is return an object that will get set to counter here. All right, so we're going to start off simple. We'll come back to this a little bit later because there's going to be an issue with one part of this, actually this part right here. What if I just want to return back the counter, the current value of, or rather the current value of count? I can try that. Again, we'll come back to that in a minute. But let's say we create like an increment property, and it will return a function. And inside that function, we can do something like count plus equal to 1. And then we can call our print method and then just say after increment, something like that. We can also, and here let me use a comma right there because we're going to create another property of our return object called reset. And what this will do is call a function. So we'll create another function expression, print before reset. Then we'll call the count, and then print, or we'll set count equal to 0 because that's the point of a reset. And then after reset, it should always display 0, but let's just double check that. All right. So now we have basically our module pattern. We've created a module, which is essentially an iffy that returns an object that will expose functions and other properties like the current count. And now here, because I've invoked this immediately, this is available. It's already been executed, and counter now is fully populated and ready to be used in our application. So I can do counter dot value, I think. Wasn't that the name of it? I've forgotten everything already. Okay, yeah, value. So console.log counter.value. And I could try to do console.log counter.count just to prove that it won't give me anything back. So let's just start there, and we'll go node module pattern. And first time we get an undefined. Why? Because count is not a property of counter. Because we didn't, it's not exposed and it's not being returned in the return object. All right, so that is impossible. Now what we can do, however, or we will try to do, is call counter, counter dot increment. You can see it shows up in IntelliSense. That's a good sign. So we'll call increment. In fact, let's call it like 3 times. Whoops. Kind of ended up below where I wanted to go there. All right, great. And then we'll call counter dot reset, like so. All right, so let's see what we get this time. It's not going to quite be as satisfying because we're going to get a little issue on these lines here. So you can see after the increment, the value is 1, 2, and 3. But then when we attempt to get the value of counter from this property, count, we would assume it would be 3, right? But it's 0. What happened here? Well, we accidentally created something called a closure, and another little topic we need to talk about in JavaScript. So let's not do that. We're going to need a different way to implement this basic functionality. So can't use this technique. What we're going to need to do is take a different tact, and we're going to implement 2 more functions. Here we'll create a set function, or I'm sorry, let's start with a get function. And get, we'll do something super simple. It's just going to return count. And then, and I did it all in one line. Could have done it on multiple lines. Didn't need to. It's pretty simple. Function. And here we're going to set count equal to some value that's going to be passed in. So here we'll say, we'll accept an input parameter called value. Making sure we add some commas in between these new properties here that are set to these functions. We'll take in some value and we'll set count equal to that. So we should be able to come down here. And now, since we've kind of removed that, let's go counter dot get, or actually let's set it to the value of 7. Here we'll do a console.log counter.get to ensure that it is 7, and then we'll call our reset. Let's see what we get when we run it this time. All right, this is a little bit more interesting. Well, almost interesting. I need to invoke get. Okay, so I forgot that. Save it, run it one more time. There we go. Okay, so here we go. Lines 33 through 35 will produce these 3 lines where we're after increment 1, 2, and 3. Then we call counter set, passing in the value 7. And so we then do console.log get, counter get, and we get that 7 back out. Now we call reset, and before the reset, the value will be 7. After the reset, we reset it to 0. Okay? So hopefully you can see that this technique of returning an object from an IIFE will, first of all, allow us to keep some implementation details private. Like we couldn't get to count, and we didn't try, but we wouldn't be able to get to print because only certain things are being returned. And mostly in terms of functions that give us access to the private functionality and a little bit more. But in addition to that, we've reduced, think of all these variables that we've reduced out of the global scope. There's no count variable now. There's no print. There's no get, set, increment, or reset. They're all part of this one variable called counter. And so there's less of a chance that our namespaces are going to collide as a result of that. Now we want to pick something unique there, maybe something that describes a little bit better what the intent of this is. Maybe something specific to our brand or company, and maybe pick something fairly unique there. But as a result of that, we've protected ourselves and written our code a little bit more defensively. Now, there's one more thing that I want to talk about here, and that is that, okay, so keep in mind, this technique that I've just demonstrated here is so popular that it has a name. This is the module pattern. There's another variation that was created on this called the revealing module pattern. You might see this used as well. Let's go ahead and create another file, and I'm going to call this revealingmodule.js. All right, and I'm just going to paste some code in so that we can kind of compare and contrast the 2 versions. All right, so it's very similar in so much that we have an IIFE that we've defined. Inside of that IIFE, we have some private stuff, just like we had before. Here we have some more private stuff. These are the implementations of get, set, increment, and reset. But I've created these as function declarations with names. Now here at the bottom, we have, this is the revealing part of the revealing module pattern. Here I'm revealing publicly accessible functions by including them as properties in this return object. So I can call counter.get and counter.set exactly the way that I could before, but behind the scenes they're calling the implementations that are defined here. And so there's a couple of benefits and a couple of downsides. First of all, what makes it a revealing module pattern is that it reveals the public functions through these properties in the return object, okay? And it's a cleaner, clearer presentation of what actually gets returned. But there is a downside, and that is you can accidentally overwrite. These are just properties, so I could set the value to get equals 7 and forget the method invocation operator, and as a result, I can pretty much just break the association between get and the function name get count, and so that's a downside. We could accidentally break this, whereas in our module pattern, you can't really do it. That's not possible. Okay, so that's the module pattern, the revealing module pattern. It brings together a bunch of techniques we've learned, all to the greater good of removing or reducing rather our impact on the global namespace by removing variable names and function names from the global scope. Okay, and we'll see why that's important on the web development side of things as we move in that direction, but wanted to kind of bring all that to a head. All right, so let's continue on in the next video. We'll see you there. Thanks. As you're getting started, closures can be another mind-bending topic in JavaScript, but they don't have to be. If you understand them, you can really unlock the power of JavaScript. Now, having said that, personally, I don't rely on them very often when I write code, but I'm not a JavaScript ninja, so your mileage may vary. You're going to see a lot of articles and tutorials out there that talk about closures, and I think sometimes they make things more difficult than they really need to. So I hope to provide a really simple explanation that will simplify this topic for you, and you can get into some of the more advanced stuff a little bit later on. But basically, a closure allows you to associate some data with a function and then use the function with that data already kind of baked into it from that point on. In my mind, it's kind of like this. I'm basically taking a function and I'm marrying it to some data through an input parameter, an input argument, and then they live happily ever after in their own variable. And from that point on, they work together as a team. Whenever I want to invoke that function with that data already pre-filled, I guess you could say, into the input parameters, I can call that new variable. All right, that's all it is. And then, well, okay, there's more to it than that, but for the most part, that's all there is. So let's just create a really simple example or two, and hopefully it'll clear some things up. So let's create a new file called closures.js. And let's start with just a function. I'm going to create something super simple. Say hello. And then inside of here, I'm going to return a function, because that's kind of the point of this. And it'll just say howdy. And I guess we're going to pass in a name. So howdy plus the name. All right. All right, so that's really step one. I create a function that returns a function. Looks like I got a little problem here. Whoops. I return a function. There we go. So here's the function, returns a function, and I'm passing in a argument called name that I'll ultimately use in the body of this return function. All right. So then I can actually make a call. So for example, let Bob equal say hello, and passing in Bob. Now from this point on, if I call Bob, well, we'll see what happens here. Node closures. All right, howdy Bob. All right, so by itself it isn't all that impressive, but that's really kind of step 2 and 3 all in one shot. So I can pass in some variable that slightly modifies the way that this return function operates. So So in this case, it's pretty simple. I'm passing in a name, and it will change what gets printed out every time whenever you call this function in the console .log. All right. So this value is basically saved off in a variable outside of the returned function. So we're relying on how scoping works in order to get that closure behavior. That name kind of follows along this return function everywhere it goes. Bob gets passed along from that point on, and then this is step 3 where I save that off in its own variable so that I can call from that point on, and I kind of get this say hello with Bob pre-filled, right? So I can do the same thing with Conrad say hello, and then Grant say hello. And that's all a closure really is. So let's do those. And there you go. 3 versions of the same function that get returned. We modify the operation by taking advantage of how scoping works in JavaScript, by kind of giving it this value that it's going to hold in its own context from that point on, stored in these separate variables. All right. So this is really just the binding process that binds these together and then stores them off. That's all it really is. So another way to look at this, the say hello method has finished executing and it returns a function, but in the environment in which the method originally ran, it preserved that so that whatever value we passed in is preserved inside of this return function. The environment, or in this case just the name input parameter, this variable name, remains available. So now in step 4, I guess you could say, if there was a step 4, I basically use the new variable, which represents a call to the method, and a preset input parameter to conveniently call that version of my function now. All right. So the important lesson to take away is that each closure creates its own what's called lexical environment, and you'll see the term lexical used a lot in JavaScript whenever you're learning about scope. I've tried to steer away from that term because I feel like maybe it clouds the issue a little bit. It's basically just a fancy word for everything that we learned about in the scope basics here previously, where if you define a variable outside of a function, it is available inside the function, but if you define it in a child code block, essentially it's not available outside of that child code block. So that's basically what I mean by lexical scope. It basically defines how a parser resolves variable names and functions when they're nested. And the word lexical refers to the fact that lexical scoping uses the location where a variable is declared within the source code to determine where that variable is available from that point on throughout the rest of your code. So nested functions like we have here in our say hello that returns a function have access to the variables that are declared here outside of it, as well as any of the input parameters that are declared outside of it and outside of their original scope, right? And that's just how the lexical rules work, like we learned about in scopebasics.js. So when we create a closure, each closure gets its own lexical environment, meaning that they get, each time we create one, like we do here in lines 8 through 10, they get their own set of variables, their own name variable, and anything else we were to define outside of the function. In this case, we don't have anything else. And there's more to closures. You can get in some pretty advanced scenarios. They're a powerful concept in JavaScript. The ability to retain or bind to the lexical environment of the variables that enclose the returned function, like in lines 3 through 5, to create a version of the function with some values already pre-applied is pretty powerful. Now, if you don't completely understand that, that's okay. Don't get discouraged. For now, just understand that whenever you return a function from a function, you also glue any of the variables that were defined outside of the return function, including, in this case, our input parameters. All right? That's all you need to know about closures. Well, for now, anyway. All right, so let's continue on in the next video. You're doing great. See you there. Thanks. If you think back to the lesson on object literals, I think we were working in the object.js file. I created a car object with several properties and functions, and you can see that I've created a new file called this-keyword.js. If you're pausing the video to follow along, then you might want to go ahead and create a this-keyword.html. Yeah, that's right. We're going to write some JavaScript in an HTML page for the very first time in this course here in lesson number 18, because I want to show you how this works in different contexts, this keyword. But getting back to the point at hand, if you recall that example that I've pasted in from that object.js file into this keyword.js, you see line number 10, and at the time I didn't even proffer an explanation as to what the this dot make and this dot model actually mean in our application. The fact is that this keyword can be a little bit challenging. So even people with a little bit of JavaScript experience from time to time get a little confused about this keyword. And one of the reasons people get confused about it is because it means something different in JavaScript than in most other programming languages. So you actually have to kind of fight your existing knowledge. So if you're coming from another programming language, the best thing you can do is kind of just leave everything you think you know about well, a lot of topics, but in particular about this keyword at the door. And if you are just coming to JavaScript as your first programming language, then you might even have a slight advantage here because you won't have to fight yourself in what you think you know. But simply put, this keyword in JavaScript represents the way a given function is called. The way a function is called will determine what this represents. Okay? So you essentially bind this keyword to a given context, and we'll explain what that means, based on how you call the function. All right, so up to now, we've not really paid much attention to how we call functions. I told you there was really only one way to call a function, using the method invocation operator. So we would do something like this a little bit later on, right? Like a car.printDescription, all right? And I used the method invocation operator, and I didn't even hint to the possibility that there would be another way or multiple ways to actually invoke a function, but that's actually pretty important when you consider what this keyword represents. All right, you're going to learn in this video at least that there are other ways to call a method that allow you to set or rather bind this keyword to something so that you can do something interesting inside of, in this case, your object or your function or whatever the case might be. Now, you may never need to do this, but it's important to understand the basic rules and how this keyword gets bound to a context and gets referenced inside of your object or your function. There's an entire book written about how this functionality works and all the permutations, and it's awesome. It's a little bit over my head at times. So I'm going to give you an absolute beginner's explanation as to how this all works, but it should serve you well as you're getting started, and then you can refine your understanding a little bit later on. But let's start out by commenting out everything. And you know what? There's a really easy way to comment out everything that I haven't talked about yet. Alt, Shift, and A on your keyboard will add a beginning and an ending code comment character operator to whatever you have selected. So that's a nice quick way to do that. Great. All right, so let's start really simply. I'm just going to create a function called first. And this function is going to return the value of this. What is the value of this? Well, here, if you go console.log, first, is it equal to the global object inside of node? So the global object, we'll talk about that a little bit later, I guess. It is kind of the most basic context things that get executed inside of. So when we create something in the global namespace, a global variable, we would create it essentially attached to the global namespace. It's available everywhere in our application. All right. So let's see if when we call first from line number 20, is this, which gets returned, equal to the global object. So let's go this dash keyword, and it is true. All right. So when I call the first method, basically from the global context, because I haven't created it inside of using the module pattern inside an iffy. Remember what we talked about previously? So I'm basically just calling this here out in the global namespace. And what gets returned back is the fact that this is equal to that global namespace. All right. So now let's try something else. Actually, let me just do this. Let me copy this little comment that I have in my notes because it might be helpful to you for reference. All right. So let's start with another code example now. Function second. And the only purpose of this is just to show that there is this little flag called uStrict. There's a strict mode in JavaScript. We're not going to go into it much, but this will change how this keyword is bound. And so if you have uStrict turned on and you try the same thing that we just did here, in fact, let me comment all this out using that Alt-Shift-A technique. And we essentially do the same thing here where we go console.log and then second equals global. Let's see if we get what we think we're going to get from the first time around. False. All right, well, I happen to know that it will equal undefined. And that is a true statement. What gets returned from this when we use uStrict is an undefined value. It gets bound to essentially nothing. All right. So just keep that in the back of your mind. The rules around binding the this keyword change depending on the context. In this case, the context is uStrict. It will fundamentally change how it works. All right. So with that out of the way, let's move on to the next example here. Let my object equal, and I'll create a property called value and set that to my object. And then I'm going to use create a global variable called value, and I'm going to set it on the global object by doing this global.value. At this point, I've created a new property on the global object, and I'm going to call this global object. All right. Again, in Node, this has special significance. If you're doing web development, it's actually window, and we'll look at that here in just a little bit. All right. So now let's go function third, and we'll return this dot value, and then we'll do a console.log third. So by default, what do you think will get printed out? Will we print out the value of the global object, which I set to the string global object, or the value of my object, which is set to my object? Well, hopefully, based on what we learned in this first example, you already know where I'm going with this. And because we called third from the global namespace, when we reference this keyword, it's referencing this global variable. So when we grab the value property, it's grabbing the value property of the global variable, thus printing out global object. Let me show you that there are other ways to actually invoke the third function, and we can control the binding of the this keyword like so. So here we're going to console log, and then I'm going to call third, but I'm not going to use the method invocation operator. I'm going to use the call method or the call function of the third function. All right. So it has a built-in method called call, and there I can pass in my object. And this is how I will bind the this value to my object, so the value will be pulled from my object, not from the global variable. So let's save that. Here, let me actually comment this one out. Save it, and let's run it. Okay, hopefully that makes sense. There's another similar function called apply, and they're very similar. And in this context, won't be obvious how they're different because I don't have any additional properties to send in, or rather input variables to the third function. So if I had something like name, I would use then like call dot, Bob. But this can also take an array here in the apply, which could include Bob. So let's just do this. See what we get. I haven't tried this beforehand, so yeah, object Bob. Okay. Now, just out of curiosity, what would happen if we did this? Probably nothing at all. It'd just be blank. Yeah, object undefined. All right, global object with the word undefined next to it. Okay, so hopefully that makes sense, what I just added on there. That's really to illustrate the difference between call and apply. And so if I had multiple input parameters in the call, I would just add them on there. If I had multiples, I could add them on inside of an array. All right, that's the only difference. Okay, but let me just kind of annotate this and talk through it just for a moment. So just to kind of recap this, the this keyword depends on how a function is called, and an object can be passed as the first argument to call or apply, and the this keyword will be bound to it, like we did here in lines number 54 and 55. All right. And so just to kind of remind you about this, I'm going to go ahead and say this property is set on the global object, and then kind of works inside of here. This will return something different depending on how we call this method, right? And then just want to add this little annotation here as well. Both call and apply allow you to explicitly set what you want to represent this, or how we want to bind this. The difference is how the additional arguments are passed in, like I show you here. Okay. So when it comes to calling a method of an object, the call site will be the object itself, and all of its properties are available to this. In fact, if we take a look back here, that's what happened. That's how I did this and why I use this.make and this.model. Again, when it comes to calling a method of an object, in this case print description, the call site, in this case car.printDescription, will be the object itself, and all of its properties like make, model, and year are available to this inner function only when I use the this keyword, because this represents this context. All right, because I'm calling print description using the car object. All right, so to call the function, I would use the object reference. That object reference car gets bound to the this keyword. So to further illustrate this idea, let's do this. I'm going to actually select everything we've done from here down, and Shift Alt and A. And so let's go function fifth. And here I'm going to go console.log and this dot first name and a space and this dot last name. And hopefully this will make a lot more sense. All right, so now what I want to do is create two objects. So let customer1 equals, and then we'll go first name colon Bob, last name colon Tabor, and then I'm going to create a print property that's going to point to the fifth function, like so. All right, and I'm going to copy this and just duplicate it. I'll make this customer 2. Call this Richard Boughton. All right, and then finally we'll go customer2.print, customer1.print. All right, so now look at how this works. What is the context? How do I call the print method that's pointed to fifth? Well, in this first case, I'm using the object, if it'll let me get in there, object customer2. That is the context. We're going to bind the this keyword to customer2 because I'm calling it as a property of customer2. I'm going to bind next in line number 85 the this keyword of the print method to customer1. So let's go ahead and so to me, this example is really interesting because the call site is the object's reference to the function, and the this keyword can be used to reference the various properties of the object that was used to call the function. So it becomes an interesting and elegant way to essentially pass values into a function without defining a bunch of input parameters to the function itself. All right. So now what I want to do is kind of stop working with Node for a little bit and look at the this keyword in the context of a web page. So I've created a new this-keyword.html. I can use the term doc. You can see that when I type in the word doc, it's an Emmet abbreviation. If you're not familiar with Emmet, just search for it online. It's basically a shorthand syntax for, I guess you could say, for snippets for code editors, right? So when I hit enter on the keyboard, it kind of creates this, bam, this whole document outline for me. And it has some replaceable areas like the device width and the initial scale and the content and all that business. I don't want to change any of that stuff. What I do want to do is add a script section here near the bottom for reasons I'll talk about in another video. And then what I want to do is above that create just a simple button. So here we go, button, and inside the button I'm going to say, hey, click me, and then I'm going to set a onClick equal, and we'll come back to that in just a moment. Here I'm going to actually create a function that I want to call whenever the button is clicked. So function, and I'll give it a name, click handler, like so. And inside of here, I'm going to go, first of all, I'm going to allow something to be passed in. I'm going to allow a value to be passed in, and then I'm going to print out whatever that is to the console. So console.log arg. All right. Now, we'll come back to this in just a moment. I'm going to leave a space and go console.log this. All right. And then in here, I'm going to say the button on click equals click handler. So I'm going to call the click handler. I'm going to pass in this, the this keyword. All right. So if all goes well here, I should just be able to right click on this and say reveal in Explorer. And then when it's in the Windows Explorer, I can just like hit the enter key on the keyboard to actually open it up in my default browser. And what I want to do is I want to use the F12 tools in Edge. I'll bring up this little window at the bottom here, and I want to look at logs. So make sure that you're on the console tab and select the logs subtab. I'm going to click the click me button, and we'll see the results of both of our console.logs. In the first case, what we get back is the this that was passed in as arg and printed out directly to screen. And so in this case, the this keyword will reference this entire element. All right, so let's take a look at that again here. You can see how button on click gives me the whole thing. So I can do something like this, which if you're familiar with web development, should not blow you away, I should be able to do arg.innerText, and if you're familiar with web development at all, you would expect to see what there. Let's refresh the page, click the click me button again, and you see click me. All right, that's the inner text of that button. So I'm able to get to all the properties of this button, but the key here is that the this keyword represents this entire button, and I'm passing the this keyword in so that I can look at this entire button, inspect it, grab a property out. But when I use the this keyword inside of my click handler function, what do I get? I get the global object. Now we said in Node the global object, the name of it is global. In a web browser, the global object's name is window. So I can actually just like use this little arrow, this little caret, chevron right next to object window, and it will allow me to view all of the objects, the child objects of the window. And there are literally maybe, if not hundreds, definitely dozens of different objects and properties that we can inspect and change programmatically. We'll come back to some of those ideas a little bit later. But basically, the takeaway from this is that whenever code is called from an inline on event, like on click, on event handler, this is set to the DOM element on which that listener is defined. That's why we got back this entire button, including the text, including the closing button tag. But we've not taken any special steps to bind this inside of this function we've defined here, the click handler. So it defaults to the global object, the window object. Okay? So the moral of the story is that what this keyword is bound to is not always obvious. It takes a bit of detective work, more so than the this keyword in other programming languages, but it has to do with how a given function is called and the site from which it is called. So in this case, this keyword is used at the call site is at this element level. In this case, this keyword is used at the global level, all right? And that will change the value of this and what it's bound to. But by default, functions that are called using the method invocation operators alone will use the context in which the call is made. So if the call is made in the global context, then this keyword will be bound to the global object. If the call is made in an object, then, like we saw here near the end, this keyword will be bound to that particular object. And we were able to use it to grab out the values of the given object, all right? And you can take control of what this keyword is bound to by calling it using either a call or the apply method of a given function. And we talked about what they do and how they're different. And finally, whenever you use them use the this keyword in a browser, once again, what this is bound to depends on how it's being called and who is calling it. All right. So hopefully that clears up what this keyword is. I've given you a lot of examples. I've tried to speak a little bit more slowly, and hopefully you can wrap your mind around what this actually is. And hopefully from this point on, you'll be able to identify what this is in your code. All right. Hopefully that helps. All right. You're doing great. Hang in there. We're getting close to being we're more than halfway done, and you're doing awesome. See you in the next video. Thanks. In this lesson, I'll briefly demonstrate how to use destructuring, which is a fairly new technique in JavaScript for unpacking values from arrays into individual variables, or I guess into other array elements of a different array. But you can also use it to unpack properties from objects, again, into other distinct variables or a different object. So use this term unpack. You'll see what I mean here in just a moment. Let's start by creating a new file called destructuring. destructuring.js. All right. And the first thing I'm going to do is create a bunch of loose variables here, just A, B, C, D, E. We'll wind up using most of these at some point. And then I'm going to borrow that array that we created a while back. Maybe recognize some of these names. And then next up, let's start by just destructuring this names array into a set of variables. So I'm going to start off by using names, which I know is an array, and I'm going to use this bracket syntax and say, take the first element of the names array and stick it in A. Whoops, whoops, whoops. There we go. In A. Take the next element, stick it in B, you know, C, D, and I could even change the order. Instead of D and E, I'll go E and then D. All right. And so let's just do console.log A, console.log B, and then console.log D, because that's a little bit more interesting. We'll just go ahead and print out C as well. Why not? And then we'll go E. All right, and so here we'll go node destructuring. All right, so take a look at what happened. We have this array. We destructured it down to a set of individual variables. And we start off with A representing David, the first element of the original array, Eddie, the second element of the original array, Alex, because we're grabbing them off in sequence. I did something a little bit interesting here, and so much that I switched E and D so that E will represent Michael and D will represent Sammy. When I print them out, going back to alphabetical order, D, then E, Sammy's first, then Michael. All right, so, but the key to this example is that I've taken everything inside of an array, and using this style syntax, I've destructured it down to individual variables. All right, so that's just one example. There's some other interesting ways to work with this. Let's just go here. I'm going to take all this, Alt-Shift-A, comment it out. And the next example, I'll do a let others. So I'm adding an additional variable here in addition to the other ones that we created originally. And here I'll go A, B, and then I'm going to use this weird syntax of ... others. All right, equal names. So now console.log A, console log B, and then let's see what gets put out into others. All right, so this time A is from David, B is Eddie, just like before, but this time I said basically everything else, just go ahead and stick them in a new array called others. All right, so that's what we see here printed out from line 21. We get this array representation in our console.log, including Alex, Michael, and Sammy together. All right. So that's just another twist. We can basically take some elements one by one. We can then also kind of combine together entire groups of elements together. Let's move on to another interesting twist on destructuring. So in this third case, what I want to do is actually work with an object. And so whenever you're working with object, objects and you're destructuring out of one object into variables or even into another object, it's really like a form of projection if you're coming from other programming languages. Grabbing out the parts that I want of the original object and putting them into a new object with a different shape, all right, without having to take all the contents of the original object. So I may only want 1 or 2 properties where the original has 10 or 20 properties. So here, let's start off with just saying let year and model. Then I'm going to start off with car equals, but I'll get rid of that here pretty soon. We can start out with let car equal, but it won't matter because we're going to remove that. And I'm just going to create a typical old object, like let's say it's BMW. The model will be a 745 Li. The year will be 2010. The value will be $5,000. All right. And in order to destructure this, what I'm going to do is actually remove this and say, hey, I want to take the year and the model and put that into a new object of its own. And then what I'm going to do is wrap this whole thing in a set of parentheses and then an end of line character like so. So now we'll do console.log year. That'll be the value here that I'm pulling out. And model. It'll be that value there that I'm pulling from the original object and printing it out. So let's see what we get. All right, so 2010 from line 34 and the 745 Li from line number 35. All right. So that's just some examples of destructuring. Pretty simple concept. It really is just a compact syntax that helps to clean up code whenever you're trying to map from one data structure into another or into a set of variables. And that's all that it is. All right. So hopefully that made sense. We'll see you in the next video. Thanks. Another new feature of JavaScript allows you to create better literal strings through the use of templates. So the term template literal is a kind of oxymoron. Parts of the string will be literal and parts will be templatized. They'll be variable based on an expression. And so you can inject in other values, variables, or you can actually run entire expressions. And we'll see the use of a ternary operator in just a moment. Let's start off pretty simple. We'll begin by creating a new file. Call this template literals.js. Inside of here, I'll do something really simple. Let name equal Bob. All right, that's not the template literal. This will be console.log. And now I want to use the backtick characters, usually over the tilde. If you're not familiar with that region of your keyboard, it's usually right next to the number 1, 2, 3, 1, right next to the number 1. You'll have to hold down the shift key to get to it. So there's one backtick. Whoops, I'm sorry, you don't need the shift. The backtick key, all right, usually above the tab key on your keyboard. And so inside of there, I'm going to use hi. And then whenever I want to add something variable that will get kind of injected in from the outside, it'll be interpolated from outside of this, I'm going to use the curly braces. And right before the curly brace, I'm going to use the $sign character. You can see that the syntax highlighting in Visual Studio Code changes the color of this to this bright blue color. That's cool. And so then I can just say, hey, I want to use the name variable inside of there, like so. Okay. So we should be able to do something like node template literals, like so. And I get hi Bob. Awesome. So the other cool thing about template literals is that they will allow you to create multi-line strings. Now before this, you would have to do a lot of using the append operator and so on, but in this case you can do something like, and I'm just going to copy and paste this because I don't want to type all this out. You can see here that I start my template literal with a backtick, and I end it with a backtick down here at the bottom. So I'm setting this sentence, or sentences, actually this paragraph, equal to this whole string, and I split it up on multiple lines. And there's no append character or anything like that. What I can do is console.log sentence. And the neat thing too, at least from what I'm concerned, is that it preserves the indentation level and the line feed character. So, you know, I could do something a little more, I guess, artistic here. Come on, let's do this just with spaces like that. And it preserves that indentation level that I have. Pretty neat, right? All right, and then the other cool thing is that you can do anything inside of the expression interpolation area that you can do in a normal expression. And let me comment all this stuff out. Alt-Shift-A. And here I'm going to create a function, real super simple function. Get reason count, just a very pithy, silly idea here. And I'm going to hard code this to return the value 1. All right. And I'll change that a little bit later so you can see the difference here. But I'm going to create a variable called interpolation. Interpolation equals, I'll use the backtick character, give me $ curly braces, we'll come back to those in a minute, to try this. All right. Inside of here, make some space for myself, I can create any expression. I'm going to use the ternary operator. And so I'm going to say, hey, if get reason count, just because I wanted to make things a little bit more interesting, so I'm actually calling a function. If it is equal to 1, and here's where the ternary operator comes in, I'll say one good reason, otherwise a few reasons. All right, and this is starting to pop over out of the viewable area, but hopefully you can kind of keep track of using this syntax coloring. You can see where the expression interpolation begins and ends. Inside of that, here I'm going to evaluate the call to get reason count, and if it's equal to 1, I'm going to inject that part of the string in here. Otherwise, I'll inject this part of the string inside of my template literal. And now, I guess the only thing left to do is just a console.log interpolation. Like so. Let's go ahead and actually run this. So give me one good reason to try this. Well, maybe we should try 2. Give me a few reasons to try this. All right, so you can, and I see the need for this all the time, especially in web development where you may have 1 item in your shopping cart or 2 items in your shopping cart to change up the string that gets outputted to for the end user based on a quantity. All right, and probably other good uses of that as well. So string template literals are a nice addition to the JavaScript language. Here again, they can make your code more compact and readable, allowing you to do some interesting things in line that would require a lot of appending of strings previously. All right, so doing great. Let's continue on. See you in the next video. Thanks. Regular expressions allow you to create a pattern to determine if a given string matches that pattern that you created. Regular expressions, or they're often just referred to as regex or regex, are not exclusive to JavaScript. They've been around forever. They can be used in just about every programming language. And I absolutely hate talking about them because they make my head hurt. I've not committed the syntax of regular expressions to memory, and so pretty much creating a pattern to find something is hard for me. And I've developed a few little crutches through the years so that I can, approximate or fake my way through the usage of regex, and I suspect you'll probably find yourself doing that as well, unless you're one of those really annoying people that just commit to learning regex inside and out, and then can impress people at parties based on that knowledge. So I try everything I can do to avoid memorizing it or learning the syntax. Usually if it's something simple like making sure that a string matches the pattern of a phone number, a zip code, something that's fairly common, especially with data in the United States, I can usually find a good example of what I'm looking for online using a search engine or Stack Overflow. But if it's something custom for the given project I'm working on, then I have to go and relearn just enough regex to get through that project, and then I try to purge it from my memory again. So I'm going to show you where to go, how to find the answers, and cobble together your own little regular expression. But I'm not going to pretend like you should go out and memorize any of this. I know people have done it, but I usually wind up hating those people because they're smug know-it-alls. But I digress. Let's just take a super simple regex example and use it in JavaScript. So I'm going to start by creating a new JavaScript file called regex.js. And here we're going to say, I'm going to create a simple variable called pattern. And you can create a regex pattern by beginning and ending with a /. So in this case, I'm just going to say, hey, search for this pattern where there are exactly these three characters, X, Y, and Z. All right. Super, super simple pattern. You would almost never use something this simple unless you were looking for specifically the letters X, Y, and Z inside of some long string that you want to search through, or series of strings. All right. But there's my pattern. And so before we get started in earnest, let's just say, hey, what are you really? First of all, I want to print it out, and then I want to console.log, see if we're working with a new data type, or is this just a data type that we already know? So let's go node regex, and looks like just attempting to print it out will just be a string representation of the pattern. The type of the pattern is object. Okay, so it's a special built-in object to JavaScript. We'll talk about some of those global objects. This is just a shortcut to creating an instance of that global object for regex patterns. Okay, so here, let's continue on now and actually create some text that may or may not contain that pattern that we've defined. So let value equal, and we'll go, this is XYZ, a test. All right. And so what we can do is there's a couple of methods built into both strings and regular expressions that allow us to use regular expressions against a string, or use our pattern against this value, in this case, this variable called value. So we'll start with the console.log, and we'll use our pattern dot, and IntelliSense shows us there's actually quite a few interesting things that we could use. I'm going to keep this example simple and just say use the test method. And so IntelliSense tells us that this will return a Boolean value that indicates whether or not the pattern exists in a search string. So what I'm going to pass in is the string I want to search through. So in this case, value. And I would expect to get back a Boolean, a true or false, if we can find XYZ in that string. So let's save it. I'm going to comment out these guys. Now I'm going to save it. And now I'm going to get back here and go node regex. And it is true. We do find XYZ, our pattern, inside of this string. So I'm going to comment that out. The next thing that I might want to do is actually replace that pattern that we found in that string with some other string. That's pretty useful. And I do that sort of thing a lot in software development. This time I'm going to start with the string itself, say value.replace. And so that string's replace method has the ability for me to give it a pattern. And then I also want to give it the value I want to replace. If I find that pattern, replace it with this string. And I'll just use the word just. All right, like so. This is just a test. So I've removed XYZ and I replaced it with the word just by using the replace method of the string, passing in the pattern and the word. Okay. There are a couple of other things. Those are the two that I find myself using most often. Here we can do something a little more interesting, I guess. Log value.match. And this match function will return back an object that it gives some information about what the string was, what the pattern was, if it was found, what the indexes in the string, like if you were to split it up into individual characters, at what point in the string would we find an instance of that pattern match. So here we're going to pass in the pattern itself. So I'll save that. And you can see it gives me back this array with the pattern we're searching for, the index where we can find it. So I think 0 is T, so 0, 1, 2, 3, 4, 5, 6, 7, and 8. So the X, the beginning of that pattern, is found at the 9th character, index 8. Oh, I guess it would be 7th character. No, it's the 9th character, index 8, right? So at any rate, and then the original input was the entire string itself. So we can actually modify this, or actually grab that object out and work with it individually. So value.match and pattern. Now that I have that array that we saw down here, I can grab an individual part of it. So console.log. And here I might go match.index. So it just shows you how to get an individual part of it. So here I can grab the index itself, and I could use that to do some sort of custom replacement logic if I wanted to do that. I'm not sure I would ever want to do that. Okay, so now this comes to the part where I teach you how to cheat. And if you really want to cheat, you go out to your favorite search engine and you type in something like zip code regex, and then if you're lucky, Bing will pop it up to the top, whether it be from Stack Overflow or just gives you a nice little usage example right there in line. That's a little dangerous because you don't know if this particular example was voted up or down. You might want to go and actually search through the comments and see the one that gets the most upvotes and the selected answer and the one that doesn't cause any argument in the community. The other way is to go and kind of trudge through this yourself by looking at this page that, and there's plenty of references out there. I prefer the developer.mozilla.org website personally. I think their documentation is awesome, and here you can learn about the various special characters and regular expressions and try to cobble together your own regular expression to find what you're looking for. But that's all you're going to get out of me. That's all I can tell you about regex because I'm not a big fan of it. But at any rate, just to recap what we talked about in this video, you can create a regular expression, literal, with forward slashes. You can use the regex's test method, passing in a string to see if that pattern exists in that string. You can use the match method to find more details about the match. You can use the replace method of the string to replace a given match with some other string like we did when we replaced XYZ with the word just. And then, like I just showed you here at the end, I showed you how to cheat. You already know this. Look online whenever you need regex, help. Okay, so let's continue on. We'll see you in the next video. Thanks. Up to now, we've looked at a number of types. Can you remember them off the top of your head? We looked at string, number, boolean, object, undefined, and function as its own type. And there are a couple of others that we haven't talked about yet. We'll talk about null later, and then there's symbol, which is new in the latest version of JavaScript. Probably won't talk about that in this course, but what I wanted to point out, though, when we were using string in particular, but this is true of the other of some of the other types that we worked with, it seems to have some methods that are available to it to do some interesting things. So, for example, whenever we looked at regular expressions, and let me just create a new file here called natives.js. Whenever we looked at the regular expression lesson, we did something like value, which is a string set to this literal string. This is XYZ attest. And we did value.replace. Well, how is it that this value has this dot replace method? We really never addressed that. How is it something like a string can have a method? After all, we said that methods are really just functions that are defined inside of an object. So that would make a string an object, right? Or no? But a string's a string. How can that be? Well, actually, both of those are true statements. The fact is that the types we've been looking at so far, like especially string and boolean and number, are known as primitive types. These primitive types then have corresponding built-ins or natives that are functions that return objects with a bunch of cool methods that are added to them by JavaScript. So behind the scenes, JavaScript does something interesting. The JavaScript compiler will coerce your primitive, in this case, primitive string, into an object that's returned from a native string function with all kinds of cool stringy type functionality included. So actually, although we haven't demonstrated this yet, you could create a string using the actual string function to do something like this. And let me comment this stuff out here. And so notice what we did here. Let string equal new. Then here's our function, that built-in function string. Notice that has a capital S. We'll talk about that in a moment. All right. And then if we were to save this, and then let's go ahead and get down here and type in node natives. It works, well, kind of works almost exactly like a normal string. We'll get to that in just a moment. So before I address that specifically, I'm going to work with strings in this particular video and with the string, capital S string function, the built-in, the native string. But what I'm about to say about strings is true whether we're talking about numbers or booleans or other primitives that have an equivalent native associated with it. All right, so I want you to notice a couple of things and we'll work through this. First of all, this starts out just like any other variable that we're assigning to a string, except we use this new keyword. And I'm going to explain what the new keyword means in the very next lesson when we talk about constructors. But basically, this is what creates a constructor call to this function. And then here we are calling a string function, capital or uppercase S in string. But isn't that bad form? Didn't you say, Bob, that we should create our methods with camel casing, and so strings should start with a lowercase s? Actually, this is a special situation. It's still a convention indicating that this is a function that should be called using a constructor call. Again, more about that in the very next lesson, so you'll get a part 2 to this. But just keep that in the back of your mind. We'll come back to it. All right. So whenever we run this, as you can see here, when we ran node natives, we didn't get an actual literal string output. Instead, we got basically an object that has a string property and a value set to howdy. We actually need to call a method on this native that's returned from the string function to convert it into a primitive string for the proper display inside of a console.log. So we'll need to do something like let me just comment this out, and we'll go to string, like so, And now, there we go. We grab, we convert that object return from our native string function back into a primitive string and then display it on screen. Okay. So, and while we're looking at things here, just out of curiosity, let's go console.log and then go type of my string. What would you expect to see here? Well, it is a type of object. All right. So again, what's going on here is that these built-in native types provide extra functionality like this toString method, like this replace method, and others that we'll look at in other lessons. And they provide this extra functionality to their corresponding primitive types. And so just real quick, here's a list of those built-ins, those natives. All right, so it includes kind of corresponding to the primitive string, lowercase s and string, number, boolean. There's also an object, a function, and a symbol. And then there are built-in natives that do not have primitive versions. The primitive version, as you know, of array is object, and the same with regular expressions here, regex. But it does provide this native built-in with extra functionality for our arrays. So the same kind of thing happens. It's just not with directly back to a primitive, it's to an object, but it still works with anytime we're working with arrays. And then there are some other built-in natives that provide foundational data types, I guess you can say, for important features, but are essentially just objects whose methods implement a lot of logic for their features. So things like the date function and the error function, and we'll look at these a little bit later. But in this lesson, I want to focus solely on the relationship between primitives and built-ins. So whenever we do something like this, and let me just copy and paste some more code in here. So here we're creating a literal string, and then on this literal string, I'm going to call this method toLowerCase. Behind the scenes, what's happening is that JavaScript's compiler is coercing, it's wrapping, it's boxing that primitive string, my primitive, into a built-in native equivalent in order to provide that rich set of methods that transform the string, in this case to all lowercase letters instead of all uppercase. So if JavaScript is coercing, wrapping, boxing our primitive into this built-in native equivalent, then what happens whenever we need to get a value back out of it? Well, the JavaScript compiler will do the opposite. It will unbox that object back into a primitive without you having to do anything special. It manages it all on its own. So in this case, let's just kind of see what happens here. Just out of curiosity, let's get the type of here. We'll put the type of there. All right. And we'll see that when we run this. And let me make sure there's nothing else here. Let me comment all this stuff out too at the very top of that file. All right. So now let me save that. And we can see that it treats this literal string as a string here in line 31. Then in line 32, it does that unboxing thing that we talked about to take string, make it into an object so that we can call the toLowerCase method on it. And then what do we get back? Well, at the point when we attempt to find out what the type of my primitive is, it already has, for our purposes, essentially unboxed it back into just a primitive string. All right. So it's recommended that you stick with using the primitive and you allow JavaScript to do its magic. The compilers can do this sort of thing without breaking a sweat, so don't worry about all this boxing and unboxing and its impact on performance. But let's suppose that, just for the sake of argument, that you wanted to start out with a built-in native and you want to explicitly convert that built-in native version of a string into a primitive string. How would you go about doing that? Well, here, let's take a quick example. And let's go ahead and move away from strings and just to numbers, but the same idea will apply no matter what. So I'm going to comment all that out. Let's go let my number equals new number. Notice capital N or uppercase N in number. And then in the constructor argument, we'll pass in the actual value that we want to set that number to. All right. So at this point, let's do a console.log. And let's find out what the type of number my number is. Have any guesses on what it will be? Let's go ahead and stop right there and let's make sure we understand it's of type object at this point. Now I want to take it out of that built-in native and I want to grab just the value of my number out and put it into a primitive. So here we go. Let my primitive, I'll just reuse that variable name here, equals my number dot, and then to grab the value out, regardless of whether we're working with string, number, Boolean, whatever the case might be, we'll use this method on this object called value of. So the value of method, and now we should do a console.log my primitive. Actually, we know what the value will be. What's more interesting is the type of. So now let's run that. And so here in line number 36, we're going to get, it's an object, but we use value of to retrieve the actual value of our built-in native object into a regular number. And we print that out in line number 38. Okay. So to recap, the point of this lesson is to explain what these functions are that have the same name as our primitive types, but with an uppercase letter. They are built-in native functions that are intended to be constructor called. We'll learn about that in the next lesson. And the JavaScript compiler uses these functions to return an object that supports lots of rich features to each primitive data type, and we'll see those in upcoming lessons. But the JavaScript compiler will box and unbox your primitive types into these built-in native equivalents as needed, and we'll do so without any help from you, and we'll do it all behind the scenes. And you can explicitly create instances of these objects and then use the value of method like we saw here just a moment ago to convert them into their primitive equivalents, but it's not really necessary. So, what's this new keyword all about? And what's this uppercase letter in this function name all about? Well, I'm going to explain that in the very next lesson. We'll see you there. Thanks. So previously we saw how to create an object literal using this style of syntax, and you'll note that I've already created a file called constructors.js. Go ahead and take a moment to create that yourself if you want to follow along. I'm just going to paste in the car that, the literal car that we created in a previous lesson here with the make, model, and the year property set to BMW 745 Li and 2010 respectively. Now, there's actually another technique for creating an object, and that's through the use of what are called constructor functions. So let me go ahead now, comment this out, and then let me go and create a new function, and I'm going to name it car, and it'll have some input parameters, one for each of the properties that I want to initialize upon the creation of the object that gets returned from this function. So make, model, and year. And then we're simply going to say, hey, the object that gets returned, set its make property to the make input parameter that was passed in as the first input parameter. And you're going to add a model property to that object, and you're going to set it equal to the model parameter that was passed in. And then you probably guess what this next line of code will do. Same thing with year, right? And most importantly, whenever you're creating an object using this function, it requires the new keyword. So let my car equals new car with a capital C. Did you notice that I named my function with a capital C car? I'll explain that in just a moment. And IntelliSense tells me that it requires 3 input parameters into this function. So here we'll go BMW 745 Li 2010. All right. And so what's really going on here, and let's just go ahead console.log just to prove there's nothing up my sleeve here. My car. And here we're going to go node constructors. And there you go. We get a car object that has the properties make, model, and year populated. All right. So what's going on here is that the new keyword creates an empty object. Calling the function, in this case car, it will take that empty object as the this. Remember our discussion about how the this keyword gets bound to the context from which it's called? Well, in that case, that new object becomes the context for this function call. And so this empty object starts receiving new properties on lines 8, 9, and 10 with new values set to those new properties. What gets returned from this whole thing with the call to this function is an object with properties make, model, and year already set. All right. So it's important to remember that the functions themselves that we define here beginning of line 7 are not constructors. Although if you're coming from another programming language like Java or C#, you might be inclined to think in those terms because that's how they work. But rather in JavaScript, it's the new keyword in front of any normal function, any function, that makes it a constructor call. All right. It creates a new empty object, and it will pass it as the this to that function call that you make. So the new keyword kind of elbows its way into the execution. Pardon me, excuse me, I need to get in here. And it says to the function, first, before you execute, I need to create an empty object and give that to you in the this. So it's bound, so this is bound to this new empty object. And then it says, okay, now you can continue to do whatever you were going to do. Now, the function itself could ignore that new empty object, or it could use it like we have in 8, 9, and 10 here. All right. So just to kind of prove that, let me go ahead and comment all that out. And let's create a function, my function. And I'll just do something simple like, hey, I am a simple function, right? And then we're going to go var my function equals new my function. And then we're going to go console.log type of my function, or actually let's go lowercase m for my function. I've got some things wrong here, like there we go. That's what I want to do. And so let's, all kinds of problems with that line of code, but I caught him before I executed it, so that's good. All right, so you can see here in line number 21, we are creating a new empty object and then calling my function. My function executes, but not before a new empty object is kind of passed to it in the this. Now this is not used in the body of my function, so it's returned back to this variable of the same name but with a lowercase m. Probably should have chose a different name. If that causes any confusion, I apologize. Just remember lowercase m my function is different than uppercase m my function in this particular case. But when we take a look at the type of my function, it is object. All right. And so at this point, you know, it's an object, so you can't really do anything interesting with it. It's no longer a function, so you can't do that. In fact, here, let me just, kind of copy and paste this little note I put to myself in my notes here. You can't really do anything with this particular object. It's certainly not a function reference anymore. It used the function as a constructor, but the constructor function didn't really do anything to populate the properties of it. And, you know, this will not actually do anything. In fact, if anything, let's just see what happens if we run this. Yeah, we get an exception here that my function is not a function. So we really can't do that. All right, hopefully that makes sense, the right reasons why. But the only thing you can do with, you know, what gets returned here, my function, is that you can attach properties and methods to that empty object, which is kind of the point of the new keyword entirely. All right. So what about this uppercase first letter convention? I said that it was a convention. What's a convention? What is this particular convention, you know, specifically? Well, you're basically saying my intent is that this function be called using the new keyword. That's what the convention is. Basically, I am a function, but I should be called, I should be used as a constructor, so you should only use a new keyword on me, and I'm expecting an empty object be passed to me so I can set some properties on it, or maybe add some methods, as the case might be. All right. So just keep in mind that in JavaScript, what makes a constructor function has nothing to do with the function declaration itself, but rather how the function is being called. It must be called using the new keyword in order to be a constructor function. So in the previous lesson, we learned about the built-in native constructor functions that return objects with properties and methods to wrap around the primitive types and give them essentially superpowers, giving them new properties and methods that will operate on the primitive value. New functionality like the to uppercase, the to lowercase, the length property, and others that we'll learn about. But that's why they're defined as uppercase S in string, uppercase N in number, uppercase B in Boolean, and so on. That's why you can explicitly create one of those built-in natives if you use the new keyword like we demonstrated in that previous video. So hopefully that all makes sense. If nothing else, I hope you're learning how JavaScript is all about functions, first of all, and secondly, how you call a function really changes the meaning of the function and what it's intended to be used for. It changes, even in some cases, the functionality that's defined inside of the function, like in the case of this, or perhaps changes the purpose of the function like we saw here with the new keyword and calling into the function. All right, so doing great. Let's continue on. See you in the next video. Thanks. JavaScript has objects, and we've seen how to create a literal object, and we've seen how we can construct an object using a constructor function and the new keyword, like in the previous video. In some of the most popular programming languages, you create an object using a pattern called a class, or a construct called a class. In other words, you create a class named car, and then you create individual instances of the car class as individual separate objects. Now, furthermore, you can create specialized versions of one class, borrowing all the properties of that parent class in the new child class. So you have an original class, and you say, I want to inherit everything that that original class does in my new class, and then you can extend it by adding properties and methods to it to make it a more specialized version of that original or parent class. So to kind of extend the analogy here, I may have a car class, but I want to create a sports car class that extends the definition of just a normal car, and it adds on things that make it sporty. Same thing with a minivan. It's just like a car. It has some of the basic principles of a car, but a minivan also has like number of passengers and cargo capacity, things that make it unique, a unique type of car. All right, and then I can create instances or objects based on that minivan, or objects based on the sports car, and those objects are both have similarities to a regular car, but they have differences as well. All right, so that's kind of the notion of of classes and inheritance. And classes and inheritance are a foundational concept associated with object-oriented programming. Not sure if you've ever heard the term, but it's a pretty big deal among software developers. So you might be asking yourself, well, first of all, does JavaScript have classes? Well, yes and no. I mean, in JavaScript, you have objects, and you can create an object and dynamically add properties and methods to it whenever you want to. But objects are the focus in JavaScript. In languages like C# and Java and C++, you create a class and you add properties and methods to the class up front. And they're static in so much that they cannot be changed. So you can't be adding properties and method declarations to the object at runtime. I mean, you can, but it's not the original intent of object-oriented programming. They can't be changed over the lifetime of any objects that are instances of that class. So here in object-oriented programming languages, base languages like C# and Java, classes are the focus. JavaScript, objects are the focus. C#, Java, C++, classes are the focus. The latest version of JavaScript does in fact have the concept of a class, but it's a weird little stopgap measure to help people that are trying to make the mental leap from an old language that they might be familiar with, like C# or Java, into the world of JavaScript, to a dynamic, object-based programming model. So I talk about JavaScript classes in one of the upcoming lessons, and we'll get to that soon enough. But I guess, okay, so JavaScript kind of supports classes, kind of doesn't support classes. What about inheritance? Well, here again, JavaScript, yes, it kind of supports inheritance, but not really the kind of inheritance from traditional object-oriented programming. So in JavaScript, you have something different called a prototype chain. So let's suppose that you've defined a literal object like our typical car example that we've seen so many times. I won't even paste it to screen. You know what it looks like. It has a make, model, and year property, right? And so you define this literal object like our typical car example. You like the properties and the methods that you've already added to that object, and you would like to use that car object as the basis for a new car object. You'll probably wind up changing some parts of the object's definition, maybe some new values and a few of the properties. You might even add some new properties and methods to that new object. And I'm going to demonstrate a technique that allows you to construct a new object based on an existing object here in just a moment. But when you do that, when you create a new object based on an old object, something special happens in JavaScript. There is a permanent link that's created between those. The new object always knows who it inherited all those properties, its original set of properties from. How did it get created? It always knows kind of the link between it and the prototype that came before it. All right. In other words, the original object serves as a prototype for the new object, and the new object is essentially chained to that prototype from that point on. So in languages like C# and Java and C++, those traditional object-oriented programming languages, you create a class hierarchy where one class inherits from another class. So whenever you create an instance of the child class, there's really nothing that's linking that instance of the child class back to the parent class. So there's nothing linking that child object back to the parent class definition. So here again, the focus is not on the relationship of individual objects that happen to be linked to each other and kind of have a brotherhood, but rather more of a parent-child relationship in traditional object-oriented programming. Again, the relationship between classes is the focus of object-oriented programming, whereas in JavaScript, it's the relationship between objects and how they're chained together. It's a subtle but important distinction between JavaScript and traditional object-oriented programming languages. So some people use the term JavaScript prototypal inheritance, All right, but I've tried to stay away from the term inheritance when talking about JavaScript because it might conjure up traditional object-oriented programming concepts that would mislead you whenever you're considering how it all works in JavaScript. One of my favorite JavaScript authors, Kyle Simpson, called this style of object-based prototypal inheritance, it calls it really objects linking to other objects, or OLOO, O-L-O-O, objects linking to other objects. And I really like that description. And by the way, I'm not sure one way is necessarily better than the other. They're different. There are pros and cons depending on what you're trying to accomplish, the given problem you're trying to solve. So what I do want to do is have a better, thorough understanding of how objects linking to other objects actually works and what are some of the ramifications of that. So that's what we'll do in the rest of this video. So you can see that I have a new file called prototypes.js, and here I'm going to paste in my original car. This looks an awful lot like the car literal that we've been creating, object literal that we've been creating up to this point. Now I told you that there's a way to create a new object based on an existing object. And so let me do that. We're going to say, hey, let our new car equal capital O object dot create and then original car. All right, so at this point, if we do, for example, console.log new car.make, for example. So let's go node prototypes. Okay, so we have this new car, and what it looks like, at least at first glance, it appears as though we have a new object called new car, and the value of the original car has been copied in of the make property of the original car has been copied into the make property of the new car. But that's not exactly what's going on here, as we'll talk about here in just a moment. But at this point, I have two objects. I have the original car and I have the new car. And I could do several things at this point with new car. I could change the values of the existing properties that I have on new car. I could add new properties to new car or new methods to the new car, or I could delete the existing properties from new car. All right. But more interestingly, I want to revisit something I said earlier about the relationship between the original car and the new car, that there's a link between the new object and its prototype, its predecessor, the original car. And so if we do something like console.log and we say object.get prototype of, and inside of that method, I'm going to say new car. So tell me who the prototype of this object new car is. And it'll say it's this object right here, where the make is BMW, the model 745 Li, and the year is 2010. All right. So it's pointing to this original car. So let's do this instead. We can actually get a reference to my prototype. Get prototype of, passing in new car. And then I can do console.log my prototype.make. And so you can see here that I'm able to get back to that, to the make property of the original car. Now, there's no way to really prove that because they both seem to have the same values right now, but we're going to push this a little bit further. What happens if I were to add a property to the prototype? In other words, what happens if on original car I were to add a doors property, like a doors count? So if you remember, all I need to do on an object to add a property is just go, hey, I just want a new property called doors. So I do dot doors. And then I'm going to create the value and say, hey, it's 4. Now, let's go console.log new car.doors. All right. And you can see that the new car gets this doors property, and it seems to be copying that new property over, but that's really not true. But we definitely see that there's a link between the new object and its prototype, the original car. But how do I know if the property is defined on the new object or on the prototype? Well, here's what we can do. And so this is going to help us to kind of get to the bottom of this relationship right here. We're going to start with the original car and says, do you have your own property? Does this property belong to you? Or are you essentially borrowing it from your predecessor? So first of all, it's true that the original car has its own property called doors. Okay, so console.log new car, do you have your own property called doors? And that's false. All right. So kind of tying this all together and kind of explain what's really going on here. Well, whenever we attempt to get a property or call a method on an object, JavaScript will go through a series of lookups to find the value or the definition of the property or the method in order to call it. So after we created new car, it had none of its own properties. If we asked it for the value of one of its properties, doing something like we did here in line number 9, it would find the prototype that new car links to and see that if it has its make property. So we know that the new car does not have a property that we define on it called make. But what about its prototype? And yes, the prototype, the original car, has a make property and it's set to BMW. Okay. But once we do something like this, new car dot make equals Audi. All right. So we are changing the property, or actually we're creating a property on new car and we're setting its value to Audi. At that point, what happens is whenever we come down here and basically call the same, essentially same line of code now in line 11, it's saying, hey, new car, do you have a property called make? And new car says, yes, I do now. I have my own property called make and it's set to the value Audi. All right. So no longer do you have to continue and look at my prototype to find the property and its value. You can look at me and find the property and its value. All right. So JavaScript doesn't need to look at the prototype chain if the property is created and set on the new object that is essentially created from the prototype. So if we ask for a property that's not yet been defined, so here we go, let's go here in line number 12, console.log new car.whatever. All right, now think about this. Whatever property does not exist on new car. Whatever property does not exist on its prototype, the original car. So what happens next? Well, then JavaScript will traverse back and say, hey, original car, what are you linked to? And since we defined original car like this, we're linked back to type object. Actually, it is the built-in native object function. However, the whatever property is not defined on that either. So now what happens? Well, finally, JavaScript will do one final traversal asking the object built-in native object what its prototype is, and by default, it will return the primitive undefined. So when we get to line number 12, in fact, let's go ahead and comment out just about everything else here. I'm going to hit A there, and we'll get rid of all this just so we can kind of see what we're doing here. So at this point, what happens? We get undefined. Why? Because new car doesn't have a whatever property. We look back and the prototype, original car, doesn't have a whatever property. Its prototype, object, doesn't have a whatever property. And its prototype is undefined, and that gets returned. Okay. That's the end of the chain, so to speak. And that, my friends, is basically how the prototype chain works in JavaScript. You don't have to use this. You probably should know it, although you could probably go your whole career and not really have to ever deal with it. However, this is fundamentally how all your objects work and why you get the undefined type returned when you attempt to access a property value that doesn't exist. So I tried to make this as simple as possible, but this is a post-beginner topic. In fact, I was looking at some tutorials online and I saw that this was actually an advanced topic. But if you kind of understand what we're talking about here, just think about how far you've come in your JavaScript understanding to get to this point where you can kind of understand what's going on. That's impressive. So I would just recommend that you watch this again, you take a look at a few other tutorials online, and you give it some time to sink in, and you'll probably leapfrog over a bunch of people who are trying to learn JavaScript, but not really pushing themselves past the absolute basics. You're doing great. Hang in there. We're making great progress, and we're getting close to the end, relatively close. All right, so we'll see you in the next video. Thanks. In the previous lesson, I said that JavaScript doesn't have classes, at least not in the traditional object-oriented programming sense. Nor did it have inheritance in the traditional object-oriented programming sense. I explained how JavaScript is focused on objects and the linkage between objects that are based on objects. We also looked at constructor functions that allow you to construct a new object from a function call, but this really isn't a class in the traditional object-oriented sense either. But technically, JavaScript does actually now have classes, or the notion of a class, and it was introduced in the last version of JavaScript. Now, JavaScript classes give you the impression that you're working with something that resembles traditional object-oriented programming, but in reality, nothing has really changed. JavaScript remains object-focused, and objects can still be prototype chained together. I don't know how to say it correctly. JavaScript classes are what is termed syntactic sugar on top of the existing JavaScript object and prototype models. That term, syntactic sugar, you'll see that frequently in software development circles. It's programmer slang. That means that they added a few keywords and structures in JavaScript, but these merely map to existing features of JavaScript. They don't really add new features per se. So the syntactic sugar might help those who are transitioning from more traditional programming languages to JavaScript, but JavaScript purists are quick to point out that this new feature, the class feature in JavaScript, may do more harm than good, because at the end of the day, you still have to make the switch from classic or traditional object-oriented programming to a more object-based prototype inheritance, if you want to use that term. And if you're working with prototypes, you have to learn the things that we talked about in the previous lesson. Okay, so in a nutshell, let's talk about what a class is and define a class. It's essentially a way to define and create objects. And so just like there are function declarations and function expressions, now there are class declarations and class expressions. So let's start off with just looking at a class declaration. And so you do something like class car, whereas an expression would be more like let car equal class, and then whatever. Okay, so fairly simple and hopefully straightforward. It's basically declaration, you give it a name, and expression is, well, it's an expression. So JavaScript classes can have a constructor function that gets called automatically whenever you use the new keyword. So let's go with the declaration version of this. I'll comment this out, this expression. All right, so inside of the declaration, let's create a constructor function. You have to use the term constructor. Then you can add any input parameters that are essentially going to map to properties that you're going to add to a new instance of an object based on this class. So here again, you do something like make model and year. And just like in the constructor functions that we learned about a couple of videos ago, you would still use the this keyword, make equal make, this.model equals model, this.year equals year. Okay, so you can see similarities here, right? And then to create a new instance of an object based on this class, you would do let my car equals new car, passing in, you know, BMW 745 Li and the year 2010. Okay. So again, I want to make the point here that that word or that name of your constructor function in a class definition in JavaScript has to be named constructor in order for this to work. And here you're still using the new keyword. New still creates an object instance. It still passes it to the constructor function. Now, in this case, the name of the function is not car. The name is constructor, but you're passing input parameters into that constructor method. And then using this in this context, it's the new empty object that we're attaching properties to and then initializing their value to the arguments that are passed into the constructor. All right, hopefully that all makes sense. And it's similar enough to what we've already learned that it kind of, you can see where things are mapped. Again, syntactic sugar on top of what already exists. All right, so you can also create methods on the class. In fact, let me do it outside of the constructor method. So here I want to create a print method, and you know, I can do something like console.log, and then I'm going to go ahead and use our special string syntax, interpolation syntax. Let's make some space for myself here, and I'll say this.make, this.model, and I'll format it a little bit with some parentheses, but inside we'll go this.here. All right, so here again, now that I have an instance of my car class called my car, I can call print, like so. And so let's go node classes, and you can see I get the nicely formatted version of the information in my car class calling the print method. All right. Now, beyond these basics, you can actually approximate inheritance, at least inheritance in the classic object-oriented programming sense. So in our case, let's kind of go down here to the very bottom, and I want to create class sports car, and I have to use the keyword extends car. All right, so right off the bat, when I do that and I create a new instance of sports car, let's do that. So let my sports car equals new sports car. Now I don't have a constructor function defined, but when I use the open parenthesis, notice that IntelliSense still sees that I have make, model, and year. Why is that? Because by extending sports car from car, I still get the constructor method defined on car, and I can still set the make, model, and the year. So here, let's go Dodge Viper. And I don't even know if there's a 2011 version of it, but I don't know if they stopped making it or if they're still making it. I'm not even really sure, but it doesn't matter. All right. So at this point, and we can even call my sports car dot print. All right. And now we get that printout here like so. So we're extending, we're borrowing the entire definition of our class, and we are getting the constructor method defined in car. We're getting the print method defined in car, but I can extend and push beyond the boundaries of the car's definition by adding properties and methods. So for example, here, let's just add a quick method. And I'm going to call it, since it's a sports car, we're going to create a method called rev engine, which will be a unique printout of information. So console.log, and we'll do something .vroom goes the this dot model. Okay. So now I can call my sports car dot rev engine, and I get vroom goes the Viper. I guess I should have added a space right there. All right, now what if I were to do this? I still have my car. Can I go my car rev engine? Let's see. Nope, can't. Why? Because it says rev engine is not a function. Well, it is a function. It's just not defined on the car class. It's defined on the car class's inherited child called sports car. All right, so you can't access rev engine from the car class. And you know what? Honestly, there's more to it than that. There are some advanced scenarios, but that should be enough to show you what the class keyword and the extends keyword can do and how it operates. And you can see the rough equivalence between what we did here and what we've done previously. And hopefully you can kind of see that there's a mapping, and that ultimately what's going on behind the scenes though is that we're creating a sports car object and its prototype is car, and we're adding on a rev engine method. But when we look up the constructor function, when we look up the print method, it's still using prototypes behind the prototype chain behind the scene to manage all that. It's just JavaScript is kind of covering that up just a little bit with some different syntax. Okay? So my personal opinion is that if you're coming from a traditional object-oriented programming environment and you need to become productive very quickly because you have a looming deadline or whatever the case might be, you might be better off trying something like TypeScript, which was created by Microsoft. It gives you the feel of C# and Java more so than JavaScript will, and it gives you more of that traditional object-oriented programming look and feel, and ultimately it will transpile down to pure JavaScript. Kind of out of the context of this conversation, just what you should do is go to typescriptlang.org and you can study up on it a little bit, but it's essentially a super type of JavaScript, meaning anything you do in JavaScript will work in TypeScript, but TypeScript gives you some extra features that will make it feel more like Java or C# if that's something you need. But most importantly, if some of this doesn't make sense, the things that we've talked about here, don't beat yourself up about it. Again, this is a feature that was added for a specific demographic, people coming from other programming languages. It may not have been intended for somebody who is just starting to learn JavaScript. So don't feel like the pressure now to go out and learn traditional object-oriented programming before you can understand how to use class. You don't even need to understand this. It's just, again, something for a stopgap measure for people coming from another programming language. So it might not be immediately obvious to you in what situation you might find yourself using this and why you would prefer this over what we looked at in the previous lessons. But at this point, just focus on the language, the fact that these things exist, the fact that they were added for a reason, and the reason is to help somebody else, maybe not you specifically, somebody coming from a different background, to make that transition to JavaScript. And you know, ultimately, I think with a lot of the things that we're talking about here, their usefulness will reveal themselves to you later whenever you start programming and creating real applications with this language. All right, so you're doing great. Just hang in there. We're making great progress. You know, the fact of the matter is that learning is iterative, and if this is your first attempt to learning any programming language or your first attempt at learning JavaScript specifically, no doubt you're going to need to come back to some of the ideas that we talk about, you know, in the coming days, weeks, or months. And you'll continue to come back to some of these ideas over and over. I mean, I keep studying and kind of pushing in new directions, coming back to studying the basics and then pushing a different direction. And you have to do that in order for these ideas to fully sink in over time. I mean, I've been working with JavaScript almost my entire career, and I'm still learning things. So it's just the nature of learning this sort of stuff. There's so many details, and there's only so much time in the day. So don't beat yourself up. You're doing great, and you're taking great strides towards understanding JavaScript. So hang in there. We're just kind of entering the home stretch now. You've come so far, just a little bit more, and then you can honestly say that you've got a firm foundation of JavaScript to build on. Okay, a little encouragement to get you over the hump here. All right, we'll see you in the next video. Thanks. In the most recent version of JavaScript, you can define a function using a shorthand syntax called arrow functions. And arrow functions, since they are just a shorthand syntax for creating a real function, and functions are used everywhere in JavaScript, as you know by now, you might not be surprised to hear that there are many different ways that arrow functions are used in JavaScript, and there are many different syntax variations to boot. So what I want to do is start simple, and I want to look at a few practical applications of arrow functions, but we'll start using them as frequently as possible from this point on, and you'll begin to see them pop up just about everywhere. All right, so you can see that I have a file called arrowfunctions.js that I've already created, and I want to create my very first super simple arrow function. So here we go. I'm going to create a function called hi. I'm going to set it equal to a set of empty parentheses, what's called the fat arrow operator. So equal sign and a greater than symbol after it to kind of resemble a fat arrow, I guess, as opposed to a thin arrow, which has absolutely no meaning in JavaScript. This fat arrow then will point to a body defined by an opening closing curly brace. And then we'll do console.log howdy. Okay, so far so good, right? One line of code, an entire function declaration, and we can just call hi. So here we go. Let's go node arrow functions, and we get a simple word howdy printed out. Okay, that's easy enough. So let's comment that out and move on to a slightly more interesting example. We can actually go let hi, and inside of the opening closing parentheses, we can accept an input parameter. So what these really are, instead of using, the keyword function, we just get rid of the keyword function. But this remains, and it allows us to define an input parameter, name. Inside of, or after the fat arrow, and inside of the body, I can go console.log. We use our special backtick character, and we'll go howdy, and then $, opening closing curly brace, name. Add a few semicolons to the ends of some things here. Really probably don't need this one per se. Now let's call hi Bob. Howdy Bob. Okay, so you can see that all we're really doing here is just creating, again, a shortened version of a function. And we don't need the keyword function. We just go ahead and start with the opening closing parentheses to define the area where we can add input parameters. The fat arrow points to the body of this arrow function, and inside of there we can just do whatever we want to do, just like we can in any normal function, even reference input parameters like we've done here. All right. Now, up to this point, we've just been kind of creating what I call void functions. They don't return anything. But what if we need to use the return keyword? Let's create a different version of this. So we're going to create add equals, here we go. We're going to allow this to take two input parameters, A and B, and we'll just do something super simple. We'll hear once again, but we will use the return keyword, A plus B. And now we can do console.log add 7, 3, and we get 10 printed to screen. Okay, Can you see this? Same basic structure. Here we're accepting 2 input parameters separated by a comma. Here we're still referencing those in that body that we've defined using open and closing curly braces. Use the return keyword. It'll get returned to our method as a return value of our method call. And here we're just passing in numbers, getting that value back and printing it to screen. Okay, so far pretty easy stuff, right? Now, you might be wondering, how could I ever use this sort of thing? What is its pertinence? And so I think that one of the ways that I see them being used the most is whenever you need to run a function over each element of an array. And so let's use our let names equal, and you'll recognize these names once again. Okay. This time, we're going to call the map method. Now, this happens to be a method defined on the array built-in native object that we learned about, but we'll talk about more of these helper methods built into the array built-in native object in an upcoming lesson. But the map is a pretty cool one, because what it allows us to do is to basically iterate through each element of an array, and when it iterates through, it will actually allow us to call a function. And this is a perfect spot for creating, right inside of here, one of our arrow functions. So in this case, we'll say you're going to iterate through each element of names. Whoops, I need to use the right word here. Names, right? And so here we're going to create an arrow function that accepts a name. And what we'll do is, kind of to marry these two ideas together, console.log, and then howdy name. All right. And you can see, basically in one line of code, I was able to map each element of the array to our arrow function. It passes in the name to the arrow function. In the body of the arrow function, now we can simply operate on it just like we were doing previously. But as a result now, for every single element of our array, we're getting a console.log with our little message. Okay, pretty cool, pretty cool. Let's take this one step further as we continue to build on this idea. Let me grab this line again so I don't have to retype that. And then I'm going to say let I equal 0. And actually, let me just grab this line too, because I want to do something a little bit more interesting. Because I want to show that you can actually do a little bit more in a single line. Like, for example, here I might increment the value of I and then use I here in the body. But now I'm essentially doing, you know, two commands or two statements inside of the body. And I'm not saying you'll do this very often, but it's certainly possible. All right. So now let's do save that, get back to that. So now David 1, howdy Eddie 2, howdy Alex 3, howdy Michael 4. All right. All right, let's continue to build on this. And now let's use the return keyword kind of in the same, doing the same sort of thing here. So we'll start with names. In fact, let's go var transformed equals names.map. And then I'm going to borrow some of these pieces here again. I'm just going to borrow that. Except I'm not going to call console.log. I'm just going to return that string. Let's see if we can get this all kind of lined up here. Okay, so I'm going to take every name in names, and I'm going to return howdy plus the name. And now I'll do console.log the entire array that is going to be returned from this and saved into transformed. So here we go. Whoops, I got to spell log right. All right, and so you can see that what gets returned here, because we're returning multiple values, they get added to essentially an array. And now you can see on each element of the array is the literal string that we construct inside of this map function using an arrow function to do the construction. And those individual names are now transformed and saved into a new array. Instead of just David, Eddie, Alex, now it's howdy David, exclamation mark, howdy Eddie, exclamation mark, and so on. All right. So arrow functions are simple to create, and they're just a shorthand version of function expressions. They really are useful whenever you're working with functions on arrays, like this map method that allows us to map each element of an array to one of our arrow functions, and then basically execute that function against each element of the array. And so we'll see some other examples of this in some upcoming lessons. All right, pretty cool stuff. All right, we'll continue on in the next video. We'll see you there. Thanks. Designing a course can be challenging sometimes because when you finish a topic, there's a number of directions you can go after that topic. But if you have an overarching idea that you want to get to eventually, you're going to have to kind of leave some important thoughts on the side and come back to them later. And that's really what's going to happen in the next 4 or 5 lessons or so. These are topics that could have easily been covered much earlier in the course, but because I was trying to get somewhere, I left those details off till now. So hopefully you don't mind that we're going to circle back and fill in some of the, or backfill some of the topics that we just didn't cover in a lot of depth. And the first that I want to talk about are these terms Truthy and Falsy, which seem to be specific to JavaScript. I haven't seen them used in other programming languages. Maybe I just haven't looked at the right programming language. But basically, it has to do with evaluation. So when you evaluate an expression, like for example in an if statement or in a switch, and you perform an evaluation of expressions, sometimes they're going to return absolute true or false. 1 is greater than 2. That is false, patently false. And I would expect that I would get from that expression the false value. But then there are other things that are not quite as obvious. And there are rules in JavaScript that dictate whether an expression is truthy. It's in and of itself, it doesn't look like it would be true, but because of the rules of JavaScript, it is true. And things that are falsy, it doesn't look like it would be false, but based on the rules of JavaScript, we're going to call it false. All right. And so if you just don't know what those are, you're going to maybe perform or evaluate an expression, you're going to get a true or a false, and you're going to be like, what in the world's going on there? Why is that true? Why is that false? So I want to cover these cases, and I hope you don't mind that I'm just going to copy and paste these right in because it's a pretty big chunk of code, and we'll just look at these things. But in the top, these are things that are falsy. Well, right off the bat, in line number 1, if you're going to evaluate an expression, if false, that's always going to be false. That's not really falsy. It's just false. All right. But then there are things like null, if null. Well, in and of itself, null, if we're looking at this completely subjectively, null is not true or false. It doesn't really have a connotation of being true or false. It's just null. We'll talk about null later. However, it's considered by JavaScript to be a falsy value. Same with undefined. Undefined is not good or bad. It's not true or false. But JavaScript says that if something pops up and after evaluating an expression, it comes to undefined, that's going to be a false value. The same with the number 0. If an expression is evaluated and what's output is the number 0, that is a falsy value. It will return false in that expression. Same thing with not a number. Same thing with an empty string, whether you use in lines 6 or 7 single quotes or double quotes to define your string. Now, everything else is pretty much truthy. In fact, I don't even know if there's the notion of truthy in JavaScript. It's just everything is that's not in falsy is essentially truthy. But I gave you some examples here. Obviously, just like if false is falsy, if true is going to be truthy. It's just true. But things like an empty object, if you evaluate an expression and it returns an empty object, for the purpose of truthy and falsy, it's truthy. Same thing with an empty array. Same thing with a string that's not empty. So we saw empty strings are falsy, but a string, if you have something in it, it's truthy. Okay, a new instance of an object is truthy, even though there's nothing associated with, there's no properties or methods, doesn't matter, truthy. Same thing with any non-zero value, whether it be an integer or a float, which means values after the decimal point, those are all truthy, as is a constant in JavaScript called infinity, whether positive or negative infinity, all truthy values. So here again, if you ever come across something in an evaluation, it returns an odd value that doesn't strictly return true or false. It returns null or undefined or not a number or 0 or an empty string, falsy. It's gonna the evaluation of that expression will be false. But everything else is pretty much gonna return true. Okay, that's all I needed to say in this video. Hopefully that makes sense. All right, we'll see you in the next video. Thanks. Continuing the sentiment from the previous lesson, where we're kind of doing a roundup of topics that by all rights could have been discussed earlier in this course, but we're going to introduce them now. I want to talk about the last of the data types that we'll encounter, the data type null. So it basically, null represents a variable that points to nothing, but an object reference was expected in that case. So just as a quick reminder, you can create a variable and not set any value to it, not initialize the value, not set the value. And in both cases, or whenever we look at the actual value or the type of the value, it is going to return undefined. So the value of A, because we've not set it to any value, is undefined, and the type of A is undefined. All right, but here that's just a variable. We didn't set it to a primitive string, number, or Boolean, or anything of the sort. All right, let's suppose that you actually are expecting the variable to hold a reference to an object. So just to kind of copy a quick example from a previous lesson, let me comment all this out and paste in this. So here we have our regular expression example where we're going to try and match a pattern X, Y, Z. And we're going to use the strings match method, passing in the regular expression, literal, that we created in line 5. But this time there is no match. There is no string XYZ in my value variable. So what is result set to? Well, let's see what we get. In this case, we get result is set to null. All right. Well, what is the type of results? Type of result. All right. This is going to require a little bit of explanation, okay? That's the quirk with null. It will actually return object, not the primitive type null. And that's a known bug in JavaScript that will likely never be fixed because too much code on the internet depends on the fact that type of null equals object is, you know, it's basically baked in and grandfathered at this point. But by all rights, if JavaScript had been designed correctly from the start, that would be null. But hopefully you get the idea there. All right. But the interesting thing about getting a null result when we expected an object back is that we can do something like this, and I'll just copy and paste this instead of typing it all in. We can check result and say, are you, and we'll do the strict equality evaluation. Is result null? And if it is, then we can say, well, no match was found. XYZ was not found in our value. All right. And so this can be extremely helpful whenever we're building our applications. All right. So just to kind of recap, null, the primitive data type null, is not 0. It's not undefined. It's not an empty string. It simply means that you have a variable where an object reference was expected, but it's not set to any object reference. It's different than undefined, right? Because undefined says I'm expecting to have a value, but one was never set, and it was expecting maybe a number string or Boolean. No. We're expecting an object reference, but we don't have an object reference at this time set to our variable. Okay, so hopefully that makes sense. And let's continue on. See you there. Thanks. It's been quite a few lessons now since we've talked about the built-in native functions that return objects. We saw at that time that there was a date constructor function, and that date constructor function will return an object that allows us to work with dates. And so I just wanted to take a brief look at what it can do and how you can actually work with date type information using the date object. So let's start off with a very simple case here. I'm going to say, hey, let today equals new date, and that will by default give us right now, this date and time. All right. So what I can actually do is actually initialize that date object with a specific date using one of several different formats. So I may want to create a date that represents my birthday. So I'm going to create a new date, and I'm going to pass in. And this is interesting, right? Because if I look at IntelliSense, it has an up and down arrow. I can actually use the arrows on my keyboard, and it will show me the various versions of constructors that are available with which to initialize the state object. So we can start off with something really simple and just kind of a full date, like December 7, 1969, and we'll give it a time even at 7/01/23, just guessing at the actual minute and second of my birth. I don't really know exactly. I know it was early in the morning, that's all. So that's one way to initialize the date, but there's a couple of other ways. Let's just do let Bob equals new date. And there's a file system date type that looks something like 1969-12 for the month -07, and then T for time, and then 07 because it's on a 24-hour schedule, :01:23, and that's roughly about the same. These two will create the same basic time. All right. There's also, we could just kind of simplify things a little bit here using a different format. Just give it the year, month, base 0, and day, I think base 0 as well, though I'm not really entirely sure about that. And then let Bob equals new date. It's kind of the same thing. 11/6, and then 7/1, 7:1:23. So I think these are about the same. I may be off by one. I forget if it's 0 based or 1 based, but you can look that up fairly easily. I'm not going to use these, but I just want to show you that they exist. Okay, but we have here now today's date and my original date, my birth date. And so what we can do is something interesting, like get the time that's elapsed between those two dates by just saying var elapsed time equals n equals 2 today minus Bob, console.log elapsed time. And what it will give back to me is the number of milliseconds, all right, between those two dates. So this is the number of milliseconds, and then I could divide it out, calculate the years, the months, the days, the hours, minutes, and seconds if I wanted to. All right. So that's one thing that I can do, is determine the elapsed milliseconds between two dates. You can also get parts of a given date. So I can go console.log bob.getDate, and it returns 7. What does that represent? That represents the day of the week. So in this case, Monday would equal 1, and Sunday would equal 7, which seems a little backwards to me, but hey, that's what you get when you create a language and you set null equal to object and other kind of quirks like that. Moving on, console.log bob.getTime, and this will be represented the time of day in our date object. So that was the number of milliseconds. And so that's a little bit less useful, but you can do other things. And let me just paste in a bunch of these all in one shot. You can get the month, the day, hours, minutes, seconds, and milliseconds. And then there are also some additional date functions for things like conversion to UTC or universal timecode and local dates and times. So converting back and forth between UTC and local date time. And that's pretty much what you can do with the date object. And so let's continue on in the next video. Thanks. Previously, when learning about built-in natives, I explained how the string primitive is mapped to the string built-in native object. And by boxing the string primitive into its equivalent string native object, built-in string native object, JavaScript therefore will supply us with a rich set of functions. Now in this lesson, I want to demonstrate just a handful of these very useful string methods that are supplied to us by the string built-in native object and explain why they're useful. And I'm just going to pick the ones that I think are useful, to, at least they've been useful to me in the past, but there's a bunch more, and I would just recommend that you use Bing or your favorite search engine to search for JavaScript methods of string, and you might find the Mozilla developer site, and it will give you a full listing of all the methods that you can get on that string object. All right, so first of all, we're going to need a few strings to work with just for fun. And so I'm going to create some different ones here. 2 are quotes. So the first quote is knowledge is power, but enthusiasm pulls the switch. And second is a famous quote from a good friend of ours, do or do not, there is no try. And then finally, a listing of random numbers that mean absolutely nothing. And then, you know, one of the things that I didn't really mention at the time is that do you realize that, and I'll just put this here, you can even call these methods on string literals. Like, for example, console.log Bob loves you dot. Isn't that crazy that you can just do dot on a string literal and call to uppercase? Well, you certainly can. So let's see this message in all of its glory, because I do in fact, whoa, let's call strings. I do in fact love you. All right, let's move on. All right, so let's use a couple of interesting methods of string. So we're going to use the split method. I'm just going to call set my split equal to the third, this third one defined on line 3 with those with those values, those numbers that are separated by commas. And the split method will allow you to say, hey, every time you see a comma, split that up and take the element in between the commas and add that to an element of a new array. And so let's go console.log my split. And here we have an array. with each value as a separate member of, or separate element of that array. Pretty cool. So you'll do this a lot whenever you're working with data and it comes to you in some sort of string-like format. You can split it out. All right, next up, we can slice a string. So let's go let my slice equal first.slice. And then we give it the starting index and the ending index just to kind of pull out one little piece of the string and put it into its own variable. So then we can do a console.log my slice. So this first sentence we would count, you know, to the position 13 and then to position 18, and hopefully we'll grab out that word. And we grab out power. Same basic idea with the next one, which is substring. It's just a tiny bit different. So let my substr equals first.substring. And here we'll start with that same index, but we'll say just instead of giving you the end position, just go over five positions. So this is the start, and then this is the length that we want to pull from that first string. And so then we'll go console.log my substr, and we get the same value there. Okay, similar ideas between slice and substring. Moving on, we want to return true or false if our string ends with a given string to compare it with. So my ends with equals, and we'll use that second string that I created here, try or do or do not, there is no try. And we'll say, hey, does that string ends with true or false the word try period? And then we'll go console.log my ends with true. Great. And hey, well, then we can do sort of the same thing. Let my starts with equal second dot starts with. And so this is just a way for me to say, hey, is this the string I was expecting? Does it have the values in it that I want? So I can say, does it end with this? Does it begin with this? True or false? All right, so that's true as well. And then we can even say, hey, you know, someplace in the string, does it include the substring or the string there? So is the word there used in that second string? Console.log, whoops, my include whoops, there is no there, all right? How about capital T in there? That's true, all right? So it is case sensitive. All right, so let's comment all of these out, which is interesting. Now, let's say let my repeat equals ha exclamation mark space dot repeat, and the number of times I want that repeated is 3, and then let's do a console.log my repeat, and I get ha ha ha. So the repeat method will repeat whatever the string is the number of times you tell it to, and then we save that off to do its own variable. And I think the last one we're going to look at is a way to kind of clean up a string. So let my trim equals, and I'm going to put a bunch of spaces here, and then in between I'm going to say this is bloated, right? And I want to clean it up a little bit. So I'm going to go console.log, and the first time through I'm just going to say trim.length. This will give me the total number of characters in that string. But then the second time I'm going to do what's called chaining, method chaining. So my trim dot I'm going to use the trim method. That should clean off all the empty spaces at the very beginning and the very end of my string. And then I'm going to grab the length property. So you can see dot trim, dot length. I'm able to, since trim will return a string, then I can call the next method or property on the string because I'm working again with the string type. So I'm chaining those calls together to get the result, essentially the before and after. So before I call trim, we're looking at 16 total characters here. But when I call the trim and I get the length, there's only 7 characters. That means the word bloated should only be 7 characters long, and it is. All right. So those are some helpful string methods on the built-in native string function, constructor function. And we'll do the same thing for array in the next video. We'll see you there. Thanks. Since we gave strings methods the proper treatment, I want to do the same for arrays. So we'll do that here. And let me create a couple of arrays. Here I've got an array called names and an array called others. I've got an array called lost and an array called Fibonacci. So the obvious difference is that here I'm working with strings, here I'm working with numbers. All right, so we're looking at methods that can be applied to arrays, right? So the first thing we can do is combine 2 arrays together. So we can use the concat method. So here I'm going to take the lost numbers and I'm going to concat them to the Fibonacci numbers, giving me a combined set of array values. And here I'm going to go node array-methods, the name of the file I created. And I get a long set, a complete set, or you can kind of see the division between the 2 sets. Now they're all in one array. Okay. Seems like it might be helpful at some point. Otherwise, we'd have to loop through and push or pop, or I mean push elements of one array into the other array. That might be a little bit of a cumbersome process. You can also do something interesting like console.log, and we can take combined, or the combine. Well, we don't need that. We can use Fibonacci. And what we'll do is call join. And I can say, hey, join all the elements of the array together and separate them with this string. So I'm just going to use like a tilde here for no other reason than the fact that we just haven't used a tilde yet. And I think now we've used every character on the keyboard at least once. All right, so let's save that and then run it. All right, and you can see that I just merely printed out the Fibonacci numbers with a tilde. Join them together into a single string, but they're separated by a tilde now. Okay. We've already talked about or demonstrated push and pop. I don't want to go back into those, but they're essentially ways to add elements to the array or remove the last element from the array. There's some other ways to do that too. For example, here we've got a console.log. We'll take the lost numbers and we'll call the shift method. And what the shift method will do is take one item off the front side of the array and it'll return it back to us to print out. But then if we go and look at the array, we'll see that it actually removed it. So it's essentially a pop, but instead of working off the back end, it works on the front end. Okay, so let's see that in action. And we get that exact behavior that I described. Great. We can do something called an unshift, which is to add items to the front. So it's essentially just like a push, except we're going to add items to the front, one or more items. So here we go with the lost unshift, and then we're going to say, hey, let's add we can add 1, we can add 2, we can add a bunch of items, right? And so now when we do console.log lost numbers, whoops, we'll see, whoops, what did I messed up? I call it list instead of lost. There we go. And so now I've added the values 1, 2, 3, and 4 as new elements of my array, and then it continues on with 8, 15, 16, 23, and 42. Okay. Let's comment all these out. Moving on. Let's find an element, or first of all, here, console.log. Let's take the names and reverse their order. So first of all, we'll start with the original order, and then we'll tell it to reverse, and we'll print that out. So originally, David, Eddie, Alex, Michael, but then we get Michael, Alex, Eddie, David. All right. Furthermore, what we can do is go console.log names.sort. It's a sort method. I got to use the method invocation operator. So now when I run it, we get the alphabetical order: Alex, David, Eddie, Michael. All right. Next up, let's see how you can identify where a given element is in an array by looking up its value using an index of method. So here we're going to go console.log, and we'll go others.index of, and I'm going to look up the element named Mark. All right. And so let's see where it's at. It should be the third element of the array. So I'm going to go back up here to others, 0, 1, 2, 3. It's at the third element, so then I can go grab it. Okay. How about we look at and find the last index of, and let's take those combined numbers. Remember all those numbers, we basically put them together. Let's go the last index of the value 1. So here, first of all, let's do this, just so we can easily see what the current value of combined is, and then we'll say, hey, we're going to search for the last time the value 1 appears in my list. Which array the element is it at? All right. Whoops, what did I do this time? I think it's just combine, right? Still not right. Ah, because I commented it out. Now let's try it. There we go. All right, so you can see that our combine variable holds 4, 8, 15, 16, 23, 42, 1, 1, 2, 3. So now I want to see what element is the last, and it says it's at the 7th element. So 0, 1, 2, 3, 4, 5, 6, 7. 0 based. So the last index of 1 would be at 7. So it's useful if I'm looking through a large set of data and I want to find the last instance of a given value. I can use last index of instead of index of, which will give me the first index. Okay. All right, moving on. Previously we looked at the map function of an array. I don't want to belabor that because we've already seen it. But we can do other interesting things too, like we can create a filtered list. So using arrow functions. So var filtered equals, and we'll go with combine dot filter, and now I'm going to give it an arrow function. So for every number, I'll just say it's x. I can give it any input parameter name. So here's the body of my little arrow function. If x is less than or equal to 15, then I want to return x. All right. And effectively what will happen is it'll return only those numbers that match this expression, so that when I do console.log filtered, I should only see numbers that are less than or equal to 15, and so I get a filtered version of that of that combine array. Pretty cool. And a good example of why you would want to use arrow functions. Similarly, you can do something using a what's called an iterable. It's a method called for each. So this will go through each element of an array, and inside of that I can then create an arrow function similar to things we've done in the past. Right, where I'm actually just going to, for each element of the array, go ahead and console.log this string and interpolate in the name that's passed in. Pretty cool. And then we can also do some checks. So for example, I can say, hey, can you tell me if every one of the values inside of my array match a certain condition? So here I would go console.log, and I'm going to take that filtered list that I just created here. So this should contain all of the values that are less than 15 from my combine. And here I'm just going to say, hey, let's go filtered. Is every one of those values, and here's where I'm going to create an arrow function. So let's call this num. Are every one of those numbers less than 10? True or false? False. Why is that? Well, I happen to know that there's at least a 15 in there. Maybe if we increase the number to something like 16. Are all the numbers less than 16? Well, they better be, because they wouldn't have matched this criteria, right? True. Okay. So that's the every method of an array. Similarly, we can look at sum. So tell me if at least one element of the array matches a condition. So here again, console.log, start with that. Let's create an arrow function. Whoops. We'll start off with, use the Fibonacci numbers. So sum, true or false? Well, let's start off here with an arrow function, number. Are all the nums greater than 50? True or false? True. Okay. Are they all greater than 100? Or are there any of them? There's at least one item greater than 100. That's what we're testing for here. False. There's no items in that Fibonacci sequence that we have here in our array that are greater than 100. All right. So hopefully, first of all, you can see that there are some very useful helper methods on the array built-in native. Secondly, more examples of arrow functions that are used inside of some of these methods. Hopefully that's useful. Let's keep going. See you in the next video. Thanks. You have to try really hard to force JavaScript's compiler to throw an exception with the code that you write, unless you simply just typed in the code incorrectly. Now, I suppose some might consider the fact that JavaScript tries so hard to work with whatever crazy code you offer it as a positive thing, but personally, I wish that JavaScript's compiler would throw errors more often. I mean, you should never be able to do something as absurd as what I'm about to do here. Let me paste in a little code. I mean, this makes absolutely no sense. Here we're going to attempt to multiply 7 times undefined divided by Panama. Okay, what's the answer to that? Well, you know, it looks at it and says, well, I'm not really sure that that's going to come out to be a number, so I'm just going to return not a number. And we can check for that, not a number, and, you know, I guess we can account for that in our logic of our application, but kind of wish it would just throw an exception, but I guess that's not the way that JavaScript is made to work. I suppose it tries to do whatever it can because it, I guess, figures that perhaps people come from many different programming backgrounds, or that since it's a dynamic language, maybe it should be able to accommodate any of these crazy situations. But when JavaScript does encounter finally something that it cannot work with, we call that an error. We call that sometimes an exception, an exceptional situation, an exception, something it just can't work with. And the JavaScript runtime will simply quit at that point, throw up its hands and say, I can't do anything with this line of code. And if I can't do anything with this line of code, that means I can't do anything with any other lines of code. I quit. So it's when it does actually reach an exception, it completely bails out on any additional code that you might have written. All right. So when this happens and you can identify where in code these issues are likely to occur, you can and should build some safeguards to ensure that they never happen again. Like in this case, we might write several lines of code prior to attempting line number 1. We might do things like to ensure that if, for example, these values were contained in variables, we might try to make sure the variable was not undefined. We would try to make sure that the variable had a data type of number and not string or something else, right? So that we could do that calculation and expect a real number to be assigned to the variable a. Oh, if we were working with objects, we might want to make sure that the property actually existed on the object that was passed into our function. And so we would look and say, do you have a property with this name? Does it have a value? Okay, we can work with that. And so there are some safeguards that you can kind of build around your code to bolster it, to make it more resilient to the possibility that its inputs were bad and that it ultimately might throw or raise an exception. So other times, these things might be completely out of your control. You still need to write your code in a defensive manner. So for example, you might want to request data, maybe JSON data, from a web server that hosts a web API. And depending on what you're requesting and depending on whether the web server is functioning correctly in that moment, you may or may not receive the data that you're expecting. So this might cause your code to throw an exception. Well, here's another case where you should be able to kind of code defensively, account for the possibility that an exception could occur, because calling into another resource across the world is a highly risky proposition, and it could result in an exception. So an exception and an error, I use those terms kind of interchangeably. In my mind, they're the same thing. But whenever a problem arises, an exception is raised by JavaScript in some way, the information about that exception is boxed into one of these built-in natives that we learned about several videos ago that were created in the exception, capital E, exception function. And it will give you an opportunity to inspect that exception or that error object and look at, for example, the error message and be able to handle it gracefully. And we'll talk about that in this lesson. How you can safeguard your code. The code that you suspect or that you know would be prone to throwing exceptions. And you can do that by wrapping it in a construct in JavaScript called try-catch. So here, let me comment this out, and then I'm going to create some examples. Let's create one where I know I can create an exception. So here I'm going to create a function called before try-catch. So here we're just going to create one and not attempt to catch any issues that might be created. Now here I'm going to just say let this variable obj equal to undefined, and I'm going to act like obj is an object. So I'm going to just act like it should have a property on it. So I'm going to do console.log obj.b. All right, and I know that this obj does not have a property b. That should trigger an exception in JavaScript. It's one of the few cases where we can actually force it to happen. So if that happens correctly, as I suppose, then you should never be able to execute this line. So if the previous line of code throws an exception, you'll never see this. All right. And just want to point this out here. I'm going to have to escape this in my literal string, this single quote in the contraction UL, because JavaScript, and in this case, Visual Studio Code, doesn't recognize it as an apostrophe. It recognizes it as the closing single quote for my literal string. So to escape that character and treat it like I mean to treat it, as an apostrophe, I'll use a backslash right in front of it. So now that little combination of characters will treat it as an escaped apostrophe instead of the closing single quote. All right, but at any rate, just an aside there. Line 7 should never get executed because I am expecting line number 6 to essentially throw an exception. So here's what we'll do. We'll just call before try catch, and we'll execute that. And you can see that cannot read property B of undefined. Perfect. All right. Now let's introduce a different function called after try catch to kind of show you how this works. I'm going to comment out the call to before try catch. Here, let's just grab all this and copy it all. But I'm going to, first of all, create a try. And I'm going to go ahead and just hit enter on my keyboard. I'm going to use the arrow keys to create a try catch statement. All right, see that? And inside of the try, I'm going to attempt to perform these 3 lines of code. Now, I don't have high hopes for 17 ever running. However, I suspect that what I can do is do something like this if we were to reach an exception in line number 16, which we will. So in this case, what I can do is say I caught an exception that was thrown by the JavaScript compiler. And I can even inspect that error object, and I know that it has a message property. So we'll do something like that. But the key here is that this will not break my application. My application can continue to execute. So I can go console.log. My application is still running. So even if we encounter an exception like I suspect we will in line number 16, we can catch the exception, handle it, do something, and then move on. So let's start with this, then we can move on and see if there's other things we can do here. Whoops, what am I doing wrong here? Oh, I need to actually now call my after try catch. So now let's try to run it. All right, I caught an exception, cannot read B, property B of undefined, but my application is still running. So it did not completely just shut down my application. Perfect. Now, what I can do is actually add another statement called finally. And this will run regardless of whether my try makes it successfully all the way through or whether the catch has been invoked. So I can just do console.log. This will happen no matter what. All right. And usually use a finally statement to clean up any resources that you no longer need. I'm not sure how useful that is in JavaScript personally, but you might find a use for it. All right. And so you can see that we have hit the catch, but then it also executed the finally statement before continuing on with the remainder of the application. So there's a pretty effective software development strategy of throwing custom exceptions from your functions with the intent that those exceptions are caught by the caller. So it's a form of communication. If it succeeds, then it should succeed quietly. But if it fails, your function would then throw an exception that would be handled by the caller, and it can decide what to do next. So I'm going to comment everything we've done so far out. And we're going to create one more example here. So let's do that. And I'll comment all this out too. And let's go here. Okay, so this time, let's go function, perform calculation, and this calculation will take and look at a object that will pass in, and we're going to say, hey, if that object obj dot has own property b, wait, if it doesn't have its own property. So I could do equals false like that, or I can do a shorthand version of this by just using the exclamation mark right before the expression. See that? That exclamation mark? It kind of makes it the negative. So if has own property returns false, then the entire expression will be true. This is if not has own property equal true, essentially. Then what we can do is actually throw a new error. All right. So here we'll just describe or give it the message we want to tell what the problem is. Object missing property. All right. Otherwise, if that turns out to be a truth that the object does have its own property, then we can continue with the calculation, and I might just return, you know, the value 6 or something like that. Okay, whatever the calculation using obj dot property b. All right. So here we go. Now we're going to call into that function perform higher level function operation. And here let's do let obj let that value equals 0. All right. And then let's do a try around value equals perform calculation. And I'm passing in an object that's undefined, right? Because I didn't set it to anything in line 41. So I know it's going to throw an exception. Here, I'm going to catch it. I know it's going to come back to me as a boxed built-in native error. And print that out. And what I can do then is kind of to show how this would work is if, you know, value is equal to 0, I know that the perform calculation didn't work, so I can run my contingency. Perhaps I can do some retry logic, you know, whatever I need to do to make my application handle this exception gracefully, and then continue with whatever logic makes sense after that. So let's see if this works. I think I got this right. Let's call perform higher level operation, and I'm not sure what to expect to see here, but I don't want to see any exceptions pop up, yeah, other than the one that I'm printing out and throwing here. So let's try that. All right. I think in this case, I'm going to need to do this. Let's see if that works. All right, try that again. All right, that worked perfectly. Okay, so in this case, created an object, passed it in, doesn't have the property B, so we throw an error. Remember, this is a strategy for us to do some checking and then look to make sure that if an exception happens, we can handle it. If not, we grab the value back. But if the value is 0, then perhaps we need to, we hit an exception. Maybe there's some other flag we can use to see whether we're getting the value we thought. Perhaps in the catch we can do some work. Maybe in the finally statement it makes more sense to put it there. But at any rate, we can gracefully recover from the exception being thrown, because that's kind of just our strategy that, hey, this function does not have what it needs, so you're calling into it, but you didn't give us what we needed, so you're going to have to write some logic to figure out what to do next. All right, that's all I'm trying to say there. So this is a good start to help you understand that you do have options when you think about how to safeguard your application against potential exceptions that could occur and shut down your code completely. Ideally, you could think of all the ways that your code could possibly fail and attempt to mitigate those potential issues up front. But after you've done a reasonable amount of work to perform gated checks like I demonstrated here in line number 33, 34, and 35, then you can ultimately wrap your code in a try-catch statement, try-catch finally, whatever works for you. And furthermore, you can throw custom errors from one function to another as a means of communicating failure and allowing the caller to implement some contingency like we looked at in line number 50 there. Maybe even some retry logic to ensure that ultimately the application is performing correctly and it can recover from any exceptional situations. All right, that's all we really wanted to say. All right, so we're doing great. Almost done. We'll see you in the next video. Thanks. Up to now, I have avoided talking about JavaScript in the specific context of a web browser. I actually re-recorded this entire course from scratch earlier this month because I started talking about JavaScript in a web browser from like the very first video, and it became obvious that I spent so much time fiddling with the HTML, explaining the DOM, and ultimately I was struggling to get just to talk about JavaScript by itself, and so that's why I took a different tact and re-recorded this. So this time around, as you know, I started with pure unadulterated JavaScript, and now here at the very end of this course I'm talking about JavaScript and how it's used in a web browser, which there are some peculiarities that I wanted to talk about. And I hope the approach makes sense. I hope that this approach worked for you, and even if this isn't how you wanted to learn JavaScript, I hope you can understand and see the rationale behind it. All right, enough of the pretense. As we start dipping our toe into JavaScript in the web browser, I want to talk about the amazing work of a web browser and how it will actually turn a request by just typing in an address into the point where we're actually viewing a page on screen. I want to talk about how it begins to understand the HTML that it has downloaded, as well as other files like CSS and JavaScript files. And I want to talk about all the things that it has to consider before ultimately rendering a web page out to the end user to see. It's really quite amazing. So let's start at the very beginning. I don't want to talk about all the process of requesting and resolving to an IP address and all that. Let's just speak in very broad terms. There's a request made from the web browser to a server, and ultimately an HTML file will be downloaded, or I should say a collection of HTML is downloaded to the web browser, and then there are references to other resources like CSS files and JavaScript files and things that begin to be downloaded as well. Kind of all this happens really at the same time, along with everything else I'm going to talk about here. And this isn't really intended to be deeply technical. I'm really just going to paraphrase the general order of events because I'm not really privy to what goes on inside of a web browser. I haven't really looked at the source code. But at any rate, while it's downloading all the resources, it has its HTML. Now it's grabbing its CSS. Now it's grabbing its JavaScript. And it's working asynchronously in the meantime with what it does have in hand, in memory, as it's continuing to grab these resources down. Well, while that's going on, the browser is beginning to construct this object-based representation of the HTML elements in the HTML page, and it constructs them into a series of objects that are called nodes. So it'll create a node for a given paragraph, a node for the ID of that paragraph, a node for the class of that class attribute of that paragraph, a node for the text that belongs to that paragraph. You can see where I'm going with this. Everything gets its own little instance of an object, and ultimately it's building this object graph that represents all of these elements, their attributes, and their values, the text values. And so each element node could contain other element nodes as well. So a paragraph could conceivably have some div tags, or probably more likely vice versa. A div tag has a paragraph, a div tag has a header, has an unordered list, which has list items, and so on. All right, so there's just that nature of HTML, and the object model that's being constructed in memory has to consider all of those kinds of relationships, as well as the attributes and the text values of each of those attributes. So at any rate, the final result of all of that work is this rich object model that represents the document that can also be accessed programmatically. We'll talk about that in just a little bit. But at some point, the browser considers then all the styles that it has downloaded, whether embedded in the HTML page itself or through one or more CSS files that have been downloaded as well. And it also has to consider any of the default styles for elements. So these are ones that are baked right into the web browser. It starts to decide which styles will overwrite the other styles, which values will overwrite the other values. And so now it has to then start to apply those styles to the various nodes inside of this large object graph of node objects. And once it's kind of settled on which styles to apply to each of the individual nodes, it then has to calculate how much space each of those will take up on the web page, all right? So that it can essentially at some point visually render those onto the web page for the end user to view. The next thing that it's going to do is it's going to start to parse through the JavaScript that it's been downloading from various files, and it'll determine what needs to happen and when it needs to happen. So some code can be executed immediately. Some code is attached to the various events of the various nodes in this object graph of nodes that represent the web document. And we're going to see this in a little bit. It'll impact how we write our code and where we write it in the HTML document. So when we're talking about this collection of nodes from a programmatic standpoint, as well as the entire API of the methods and properties that we can access programmatically to change things about the nodes that represent our document, to modify them, to add new nodes, to remove nodes, things of that nature, as well as the web browser as a whole and all of the functionality that it provides to us, like the ability to manipulate things like the history, the console window, and any of the other debugging windows that might be available. Take all of that into consideration, and that is at essence something called the document object model, or the DOM, all right? And so we'll talk about the DOM in the remainder of this video, in the next couple of videos. But eventually, after it's taken all those things into consideration, then it finally will render the page visually to the end user. But its work is not done at that point. Now it's listening for the user's interaction with the various nodes inside of the document. And when the user interacts, it might click or hover or mouse up, mouse down. It might use a keyboard. You know, the user can interact with the various elements on the page in various ways. And if the software developer or the web developer has attached event handlers, functions that should be called in response to those interactions, those events, then the web browser has to say, oh yeah, we have these two functions that we're going to call because the user clicked on this button. Go ahead and execute those two functions now. All right, so when we create those associations, HTML actually gives us a couple of ways to create those associations, but we're going to look at some programmatic only ways to create those associations. We'll talk about that in the next video. But at any rate, as developers, we can also interact with other APIs that are exposed to us. For example, most web browsers expose the console window so that we can write little error messages out like we've been doing up to this point. So we're primarily interested in the document object model as JavaScript developers. Again, it contains an object graph that represents every element, the attributes of those elements, the text that might be associated with those elements, and the relationship between two elements. You know, one might contain the other, or they might be siblings, and so on. Each of these objects are referred to as nodes, as I said earlier. And I just want to make the point really quick that when we're talking about nodes inside of the document object model, that shouldn't be confused with Node.js, the environment that we've been using up to this point to execute our various little JavaScript examples. They're completely different. They have no relationship to each other. All right. So at the highest level, you have the document node, and the document node will contain one or more element nodes, and each of those could contain other element nodes, but each element node will probably have some attribute nodes associated with it and maybe a text node associated with it. Okay. So the DOM also includes a rich API, so lots of functions that we can call in order to access the various nodes, their attributes, the text, and so on. All right. So we can find a specific node or a collection of nodes that match our criteria. And then once we have a programmatic handle to a given node or multiple nodes, then the API also gives us some functions that we can use to modify the values of those nodes. Everything from changing the text of a node to changing the attributes of the node, like changing the class that is associated with that given node. We can remove nodes, we can add nodes, all that programmatically. The API also allows us, as I mentioned a little bit ago, to associate events that are raised by the web browser, usually because the end user triggered the event with a mouse over, a click, whatever the case might be. As developers, we can associate our functions with those events. And then finally, the API provides some helper functions to perform various things. One that comes to mind is network operations, like being able to call out to another web server to grab data or to grab some other code that can be executed. But finally, there are several ways that we're going to talk about in this video to basically write your JavaScript in a web page or associate your JavaScript with a web page. And if you have professional aspirations, then you should be aware that not all of these techniques are smiled upon. In fact, most of them are frowned upon. There's one that's not. So you might see some examples, and here we'll just add this to our existing page here that I just created randomly in dom-intro.html. And I'm going to create a button, and in that button I'm going to say click me, and then here I'm going to add an on-click equal. I believe we've done this already, right? But I'm just going to write some JavaScript right here. Now, using this technique, I'm able to pop up a box, an alert box in the browser to just kind of execute one little simple line of code. So let me see how I'm going to do this. Let's right-click on this, and let's reveal it in Explorer. And from here, I can double-click it, and it should open up my default web browser. I click me, and I get a message box, an alert that pops up with a little message that says hi. Okay. And I can also do something a little bit different. This might be a little bit more akin to what we've been doing, console.log. And I could do hi in the console. All right. And let's just refresh that page. So I'll hit refresh. I'm going to hit F12 on the keyboard. This will allow me to see the console tab. And specifically, I want to look at the logs. When I click the click me button, hi in the console. Okay. So hopefully that all makes sense. Now, using this technique, you're only going to be able to write one line of code at a time. Maybe two, you might have to write some, but there's no doubt that just keep writing a bunch of statements here inside of this on-click event right in line in the button is not a great idea. So your other decision is, or choice is to actually add a script tag, like so. Now, for reasons that I'll explain a little bit later, typically you don't see script tags added there. You would probably want to put them at the bottom of the document. And the reason is pretty simple, that the web browser is going to look at the code line by line, and if it encounters a script tag up here and we reference elements in the body, those elements may not have been loaded yet into the document object model. If we put the script at the very end, we can ensure that everything above this has been loaded already, so we can reference the various elements in our HTML, all right, or the various nodes in our document object model, to say it in a more programmer-friendly way. Okay, so here's what we can do instead. I can actually create a function. Let's call this just a click handler, And, you know, I could even just add message. And here I can just do something like console.log hi, and then maybe ... and then maybe message like that. So now in the onClick, I can kind of wire this up and say, hey, call click handler, and I'll just say from the button click event. All right, so we'll save all that, and with any luck, you can see where we make the call to the function we've created, and then passing in a message, which should display in the console log. Let's open up our web browser again. Let's refresh this page, F5. I'm gonna click the click me button, and we get hi ... from the button click event. All right, so you might be wondering, well, wait a second. You are calling a function before it is defined in your JavaScript. Isn't that a problem? No, and this is something I wanted to talk about before, but never really got a chance to, and this applies whenever we're executing all of our examples in Node. Function declarations are hoisted to the very kind of top of the execution environment. So the JavaScript compiler will go through and look for all the function declarations. It'll put them at the top. It knows where they're at now, and then it will continue to execute any additional code. So this is, in essence, added then to the top of the execution chain. So when by the time we get to the click event handler for this button, JavaScript's already very aware that this function exists. All right, so small point there. But these techniques of using this onClick equal and the script tag in this manner, these are generally frowned upon professionally. You probably want to do what's called separate your concerns. So your JavaScript it might be more appropriate to keep it in its own file and to kind of remove all of these references like this, like we have there. So I'm going to say, don't write JavaScript in your HTML page. All right, and some people might argue with that and say it's perfectly fine, and you know, it just depends on how much JavaScript there is and what your professional aspirations are and the other programmers and what they're doing in your group. But generally speaking, what you want to do is kind of just add your code to another file. In this case, I'm going to create another file. I'm going to call this dom.intro.js, right? And then what we're going to do is actually wire up the event handler to the button click event, but we're going to wire it up in our code. So what we're going to do to start off with is to create an ify. So remember how to do that? We're going to create function. I'm going to wrap it in a parenthesis, and then we're going to say execute immediately. All right. And in here, what we'll do is we'll define our function, or the click handler, and then I'm also going to, let's go here to our dom.intro.html. I'm going to give this guy an ID, and I'm going to say your ID is my button. All right. In fact, I hope you don't mind that I'm going to delete all of this out of here. All right, and I'm going to delete all of this out of here. It's gone now. And I'm going to go into the dom.intro.js. And the first thing I need to do is get a reference to my button, all right, or my button. So what we'll do is let my button equal document dot get element by ID, and then give it the ID I want, my button. All right. Next thing I want to do is go my button, add event listener. I'm going to say which event I want to listen to. In this case, I want to listen to the click event. And when that happens, I want to call click handler. And I guess I could pass in a message if I wanted to at this point. So hi from my ify, right? Now I need to go back to the dom.intro.html. Here I'm going to add a script tag like so, script type equals text / JavaScript, source equals, and then we'll give it the name dom intro.js, like so. Save that. And now, hopefully, let's load this guy up, refresh, and you can see I did something incorrect. Let's go back here. Let's get rid of all of this business right there. All right, now we don't want to call that method just yet. We just want to wire it up to the button and say whenever the click, we want to listen for the click event. When that happens, then we want you to execute click handler. All right. All right, now that we have that in place, let's go ahead and refresh, click me, and there we go. Now we get pointer event, not exactly what I was looking for. If it's really important to us to pass in the message, which I actually forgot about, sorry, what I'll do is just kind of wrap this call inside of a function expression. So we'll go function, like so, and inside there we'll make the call like that. And then hi from iffy. All right, that should work, hopefully. So let's save it. Let's try that again. There we go. That is what I wanted to happen. Okay, so had a lot to say in this video about the DOM and about how to attach your JavaScript into a web page and still access the various elements of the document object model or this document object by using helper methods like getElementById, passing in the ID, and now getting a programmatic reference, which we can then use to add or even remove event handlers to. In this case, I'm just adding a function expression to make a call into another function that I created earlier. All right, hopefully all that makes sense, and we can continue on in the next lesson and kind of expand on this. All right, we'll see you there. Thanks. In this video, we're going to talk about working with the DOM, specifically how to access DOM nodes, how to change attributes of those nodes, how to add nodes dynamically, and more. So in the past, I've created like 3 or 4 lines of code, and then we would look at what those lines did. And I wanted to change my tactic for this particular example to show you something a little bit more interesting, a little more compelling. So I've already created a DOM nodes HTML, DOM nodes CSS, and DOM nodes JS. And you can see here that I basically created just a little playground. It does nothing of practical value. It's completely contrived, but it will show you how we can manipulate various DOM nodes and their attributes, and you might find some of the practical side of this, how did I accomplish that, useful as you pick apart this program, and we'll walk through it here in just a moment. But again, this does nothing useful. It has a click me button, a series of div tags, each with a color and the name of the color itself, and then a number beneath that. And I'm just going to click the click me 2 or 3 times. All right, you can see that several things are happening all at once. First of all, we are changing, every time the click me button is clicked, we are changing the selected color div. You can see the selections change because there's this thick bottom border applied to that particular div. Furthermore, that color is applied to this number, and that number seems to be growing each time we click the click me button. So here we're going to click it, we go to pumpkin. What happens when we get to the end of our list of colors and I click the click me button one more time? We start back over at the beginning of the list, and so I can just continue to click this. The number is growing. I'm using relative ems, rems in CSS. Using it, the number of times I've clicked it, that's the number of rems that I'm applying to this font. And so you can see that things are changing. They're very dynamic, and I just wanted to kind of, it's a large enough application to be interesting, small enough that I think you can pick it apart and kind of understand what's going on. And that's really the intent here. So let's take a look at the source code itself. And we'll start with the HTML. There's really not much interesting here. I'm pulling a font from the Google Fonts, and then I'm also applying a style sheet. The style sheet itself, not a lot interesting in it, and I don't want to take too much time. It's just making everything look a little bit nicer than our previous examples. Here we're looking at the result container, and that seems to be where we have basically the white area with everything else inside of it, this button, this row of divs, and the number. And so you can see that each of these have IDs applied to them. The click me is my button. The color div will contain a series of child divs, and I'll talk about that more in just a moment. And then the result div is where we add the current number of clicks that continues to grow and grow. Here we have our script reference to domnodes.js. That's where all the magic happens. First of all, you can see that I've created an iffy here, and I can roll it up using the little plus and minus right next to that line of code in line 1. You can see that I've created a couple of functions, one called increment counter, one called update UI, and then one called handle click. You can see that I've initialized a variable called counter to the value of 0. Here I'm getting a reference in line 74 to the button, and then I'm wiring it up like we learned about in the previous video to every time that the click event is raised for my button, I want to add an event listener. Here we have a function expression that will execute both the increment counter method that we looked at the very top, and then the update UI method that we looked at. It was right below it, and we'll go in. This is where a lot of the magic happens, so we'll look at that in more detail in just a moment. Then here you can see in line number 80, I execute update UI in order as the page loads, because again, as a immediately invoked function expression, I want this to happen as soon as this file is loaded into our HTML by the web browser. Okay, so let's go here to the top, and we can see increment counter is very simple. It just takes whatever the current value counter is and increments it by 1. All right. Now, update UI is where a lot of the magic happens. First of all, we start off with an array of color objects. Each color object has a name. This is the name that you saw printed kind of in the top middle part of each of the div tags, as well as the color value itself. And I just grabbed these from a website that has colors. I think you see the colors. I'll give you the site in domnodes.css. All right, the first thing we want to do is grab the result div. This is where we're going a reference to that element, and we use the ID result div to get an access to it so that we can programmatically work with it. This is the div that will contain the current number of clicks. Not only will we increment the display the incremented click number, but then we will also change its size and its color attributes as well. All right. Next up, what we want to do is then set the inner text attribute or property of the result object. So this result div, we're going to set a property called inner text. That's how we're able to put 1, 2, 3, 4 inside of that div tag here at the very bottom of our white section of our web page. Okay. And then, so you can see this is one way that we are getting a reference to a DOM node or a DOM element and then changing the attribute. We're changing the text. Whatever it was, we're overriding it with the current value of counter. All right. Then what we do is additionally access the style of that div. So here we're going to the style object of the result element. And then the style object has a series, and I can hit the period on the keyboard to look at the IntelliSense. All of these are attributes or properties of the style object for our div tag. And we can change all of these attributes if we want. Most of them are visual in nature. And here I just want to change the size of the font, taking the current value of the counter and appending EM to make it larger each time, that EM being a unit of measure in CSS. All right, so that's how we're making changing the number of times that the button has been clicked in that div tag, and then also changing its size every time we click it. Okay, so next up what we want to do is determine what the current color is in our array of colors. So here's what we do. We take the current value of counter and we use the modulo or modulus operator, which will give us the remainder. So if this has been clicked 6 times and there are 6 elements inside of our array of colors that we define as a const here at the top, then the modulo would be 0. There would be 0 remainder, so we would access the first element of that array, and that would be this alizarin. It's that coral color, all right? And so we would use that. So that's how I'm using and being able to kind of select each of the items. I take the current counter. So if it was 2 and there were 6, then that would give me a remainder of what? Of 4. So it would be the we would grab the 4th element from our colors array and grab the value property of that particular object and set that as the result style object's color attribute. All right. Moving on now, what we want to do is clear out all the existing child color divs. So I basically tear down and recreate this list of colors by basically removing everything first of all from the previous call to update UI, and then I begin to re-implement it as I'm looping through each of the color objects to create a new div. If it's the currently selected one, then I want to apply not only the bottom border, but then also use that color here. I guess I already did that part, but at any rate, this is why I'm setting the inner HTML to an empty string of the color div, because I'm emptying out everything inside of the current div. But now I'm going to loop through each of the colors, and here I'm basically dynamically creating new div tags. So I create a new div tag, and then I create a text node with the name of the color for, whether it's the first object, the second object, the third object. I'm grabbing that name and creating a text node. I append that text node as a child to the div tag that I just created. I style it up, and then at the very bottom here, you're going to see I actually append that node that I've been styling up to the larger outermost color div. So I do that 6 times. And if it is the currently selected item, then I'm going to change the styling of that particular node by adding a class, the selected class, and that's what's going to add that bottom border. In fact, here, I wonder if I could just go to here and find selected. So there we go. It is just adding a bottom border of 5 pixels with no padding. All right. And so that's pretty much it. Now you'll see that throughout I'm accessing the style object or attribute of the given div tag, setting its width, its height, and other properties like float, padding left, padding top. And I could have just created a CSS style and then added it using the same technique that I've used here. But I chose just to demonstrate that we can get at all those style attributes. In addition to the style object, there are other things that we're able to do to it, like append a child to it. So we have a div tag and we want to append something to it. We have a div tag and we want to append it as a child to that div tag, which is already a child to a div tag, child to the body, right? So hopefully this will help you to see how this whole process works, and that we can basically get at any DOM node. We can modify it. We can add new child nodes to it, creating them essentially out of thin air. And we could even do more, like move nodes around if we really wanted to, and so on. Obviously, this example didn't call for that. But essentially, once we get a handle to an element, then we can do anything we want with it that we can conceive of. So there are so many options that it didn't really make sense to kind of go through them in a laundry list. Basically, this is a matter of imagining what it is you want to accomplish, getting a reference to the element that you need to start with, determining do I need to create a new element and append it on, or do I need to remove elements that are currently child of the existing node? Which attributes of that node do I want to change, and so on, until you kind of construct. I mean, it took me several minutes to build this example, and it started really simply. It started by, can I just increment the current number of clicks? All right, I got that working. Now let's move on to the next thing. Can I create a bunch of colors and have them applied to the number? Can I create a bunch of divs and apply those colors to the div? And so you just keep working at it little by little until you've, tackled essentially the whole application. And that's how I built this. All right, so hopefully that was helpful as kind of a larger example that we're able to dissect and understand better how to accomplish something that we conceive of by working with nodes inside of the DOM. All right, so let's continue on. I guess we're pretty much done, so let's wrap it up in the next video. See you there. Thanks. I just wanted to briefly congratulate you on finishing this course. That's quite an accomplishment, and that's awesome. And I have to say that I definitely respect anybody who puts the time in to learn a new technology or a new skill. So you're awesome. I congratulate you and I wish you the absolute best. I sincerely hope that this course was helpful to you in some way and that you came away with some confidence in JavaScript and that you have a solid foundation now to build on. And I'd strongly encourage you to keep pushing forward. In fact, modern development with JavaScript will require that you learn some of the most popular tools and libraries that are currently in vogue by the JavaScript software development community, as well as the build and deployment process for JavaScript applications. Finally, a quick thanks to Microsoft Virtual Academy. You guys are awesome. Quick thanks to you, the viewer, for watching this and staying with it through the entire course. And as we close here, just want to say that I sincerely and truly wish you the best. Hope you can leverage this course and do something really awesome. And if you do, let me know about it. So good luck.